This video features over 6 hours of hands-on JavaScript content. It's organized into 15 projects ranging from beginner to advanced, and you'll find the timestamps down below along with all of the links to code and resources for the various projects. Now, these projects are curated from past videos on this channel, and I compiled them all into one large video to make it easier to follow along with and find all of the JavaScript projects that I've made in the past. Now, whether you're just starting out or you're already experienced, there's definitely something here for you. And if you're a complete beginner, this video is going to be great and help you build some really practical experience. Now, the projects are in no particular order, and you can simply pick the ones that you want to work on based on what sounds most interesting to you. Again, you can see all of the projects from the description or in the video player. Now, with that said, let's dive in. So once you master JavaScript from this video, chances are you're going to want to deploy the apps that you build. Now, if you're tired of cloud platforms that nickel and dime you with surprise fees and artificial limits, then you need to check out Savala, the sponsor of today's video. It's an all-in-one platform for deploying apps, static sites, databases, and object storage. Now, it's built on top of Google and a Kubernetes engine across 25 global regions with Cloudflare's 260+ edge network baked in for static site performance. Now, that means that your content loads fast no matter where you are. There are no seat licenses, no fixed plans, and just no BS. There's unlimited collaborators, unlimited parallel builds, and usage-based pricing with free internal traffic between your various services. Now, you also get managed databases, object storage, and even a full database studio right out of the box. Plus, things like Git-based deploys, one-click templates, and instant preview apps are just standard in Savala. Now, Savala basically combines the best of other known solutions on the market, but without the traps. It's what a platform as a service should look like in 2025. Now, you're also getting real human support by developers who understand technical issues and are there to help you every step of the way. On top of that, enjoy enterprise-grade security from day one. Now, you can try it today with $50 in free credit. Just hit the link in the description. Thanks to Savala. Now let's get into this video. So what we need when we're writing code is something that can execute our code and then a place where we can write our code. Now, for JavaScript, we have a few different options, but in this tutorial, I'm going to use something called Node.js. Now, Node.js is actually a client-side application that allows you to run JavaScript directly in your terminal or your command prompt. You don't need to really know what that means, but the first step in this tutorial for anyone who doesn't have this installed is going to be to go to Google and search Node.js. I'll put this link in the description as well, and you're going to download whatever the recommended version of Node.js is for either Windows, Mac, or Linux. You're going to go to the installer. So when you download this, it should go in your downloads or something like that. Double click the installer, run it, and then it should run or install Node.js for you. Node.js allows you to execute a JavaScript file so we can do all of our code directly in our terminal, and we don't need to open up something like a browser or interact with any HTML. Okay, so make sure you've got Node.js installed. Once you have that installed, we're going to install something called Visual Studio Code. Now, this is a code editor, which is a place where we can write our code. So just like Microsoft Word helps us write documents when we are, writing an essay or something like that, we have special tools called code editors or IDEs, integrated development environments, that allow us to write code, kind of get some syntax, highlighting, formatting, etc. So that's what Visual Studio Code is. Go to this website, again, download the recommended version for Windows, Mac, or Linux, double-click the installer, install it, and then open it up. So at this point, you should be open in Visual Studio Code. Yours is going to look a bit different than mine because I have some settings and some themes and stuff. Don't worry about that. All you're going to do right now is you're going to go to File, Open Folder, and then you're going to make a new folder in some location that you can remember. So I usually just recommend going on the desktop. So you go to the desktop, make a new folder, again, Mac, Windows, whatever, doesn't matter. Call this something like Tech with Tim Tutorial, whatever you want to name it. Click Enter, and then open up that folder. So I'll actually just go through the step here so that I'm following along with you. From here, you're going to be brought into an environment that looks similar to this. What you'll do now is create a JavaScript file, and then we'll pretty much be off to the races and ready to write our code. So you can see on the left-hand side of the screen here, we have a bunch of different buttons. The tab you want to be in is the File Explorer, which is kind of the little files right here. You're going to click on this button, which stands for New File, or you're going to go to File, and then New File like that, okay? What we'll do is go to this New File button. It's going to pop up this little area, and we're just going to type something like script .js. Now you can call this whatever you want, so long as you end it in a .js extension. .js stands for JavaScript, and that's the extension for any JavaScript code files. So I'm going to go ahead and hit enter, and now I'm inside of a JavaScript file. From here, we're just going to make sure that our Node.js installation is working, and then we'll be ready to get onto the project. So we're just going to type console.log, and then inside of double quotation marks, we're going to type hello. So just exactly what I have on the screen here. Don't worry too much about it. Just type this in. Save your file with Control S or by going to File and then Save. And then what you can do is pop open this terminal from the bottom of the screen. So you can see I kind of put my mouse down here and I can drag this up. You also can hit Control and then backtick on your keyboard. Backtick is at the very top left-hand side of the keyboard where the tilde or the squiggly line is. And that's going to toggle the keyboard for you. For most of you, it's going to be easier just to kind of grab this from the bottom of the screen. From here, it's automatically going to open the terminal in the same directory where your file is. So what you'll do now is you'll just type node and then the name of your JavaScript file, which in this case is script.js. Okay, if you named it techwithtim.js, if you named it main.js, then you're going to obviously replace script.js with that. So go ahead and hit enter, and you should see that you get hello appearing in the console. If that worked, then you're all set up and ready to go. If for some reason you got some error with this command, you're going to have to look up how to fix your Node.js installation. Unfortunately, I can't help you with that in this video, but you just need a way to execute this JavaScript file. Quickly recap, install Node.js, install Visual Studio Code, open up a folder in Visual Studio Code like I just showed you, create a new JavaScript file, and then run the file using node name of the file. Okay, that's how we do that from our terminal. If you're on Mac, Linux, etc., the steps are going to be the exact same. You're just going to see probably a few slightly different things depending on your operating system. That's totally fine. Follow the same steps. Okay, so we're all set up now. What I'm going to do is go into full screen mode, and we're going to begin our first project, which is a quiz game. Now, what I'll be doing is writing a little bit of code, then I'll be stopping, kind of explaining that code. So if something doesn't make sense, just hold on. I'm sure I'm going to explain it in just a minute or two. All right. So for our quiz game, let's begin with what we want to build. The idea here is to make something that you can give to like your friend, your son, your spouse, whatever, that's a quiz about yourself or a quiz about something that you know a lot about. So in my case, I'll make a quiz about different computer components, but for you guys, you can make a quiz like what's my favorite food? What's my favorite pastime? What do I do at night? Where do I go at 9 p.m. on Thursdays? Whatever you want to do, right? You can make this as personal as you want. So I'll give you a bit of a template for the project, and then you can extend this on your own and make it as long as you see fit. The idea is we'll keep track of the number of correct and incorrect answers. And that way, what we can do is tell them you got 70% on this quiz, or you got 30%, or whatever the score is. Okay, so let's begin. The first thing we need to do is get some console input from our user. That means we need to allow them to type something into the screen. So how do we do that? Well, the way we do that is actually by installing a package, which is going to give us access to some function, which we can use to get some input from the user. So we're going to go back to our terminal here. So just open this up, right? And we're going to type npm install and then prompt-sync, okay? npm stands for Node Package Manager, and this is something that installs different dependencies on your computer you can then use within your JavaScript files. So we type npm install prompt-sync, and that's going to give us access to a module which will allow us to kind of ask the user to type in some input, okay? So just run that from your terminal. You're going to see some output here. Don't worry if you get any vulnerabilities or issues. That's totally fine. Now, once you've installed that, I'm just going to clear my terminal here. We're going to go to the very top of our file, and we're going to say const. This is how we declare a variable. We're going to say prompt is equal to require, and then inside of double quotation marks, we're going to say prompt-sync, and we're going to put another set of parentheses here. I know this is a little bit confusing. It looks like a lot of gibberish. Just type exactly what I have here. This is kind of the most complicated line that we need. What this does is load in this module, so it requires its use, and then we get access to it in this prompt variable. That now means we can use this prompt variable to actually grab user input, okay? So we said we're declaring a constant. This is a type of variable in JavaScript. We're saying this is equal to require. We're requiring prompt-sync module. And then we put another set of parentheses here. I'm not going to explain exactly why we need those, but just make sure you have the second set so you have this line exactly as you see it here. Now, let's just quickly test this code out by typing prompt. And then we're just going to say enter something, and then a colon and a space. Make sure you add the space. There's a bit of separation between where we're going to be entering some code. And then we can clear and we can run our code again. Notice, by the way, in the terminal, you can use the up and down arrow key to cycle through commands you've typed before. So I'm hitting the up and down arrow key, and it's kind of going through my commands, so I don't have to type it every time. Anyways, I'm going to hit node here. Notice it says enter something, and you can see my cursors appearing in the terminal. So now I can type something like hello world, and then we just continue with the rest of the program. Perfect. So prompt gives us access to whatever the user types. So now we're quickly going to talk about some variables. We're going to define those and use them, and then continue on from there. Okay, so what we're going to do to begin here is we're going to say const, and we'll just say value is equal to prompt. Now what we're doing here is declaring a variable. A variable is really just some named value that gives us access to some kind of piece of data. In this case, the data we're going to be getting access to is something known as a string. Now within our programming languages, we have some different data types. These are the different pieces of information essentially that we can store in our program. So we can have numbers, we can have a Boolean value, something like true or false. We can have strings, arrays. We'll talk about those later as we go through the rest of this video. And I'm sure for many of you, you already know what those data types are. But what this prompt function is going to do for us is it's going to give us something known as a string. Now a string is anything that is surrounded in double or single quotation marks. There's some more complicated strings as well, but typically your strings are going to be in double or single quotation marks, meaning if I have something like 1, this is the string 1. If I have something like hello, this is the string hello, and usually they'll highlight in yellow or some color for you in your code editor. Okay, so what we're doing is we're saying we're going to have a variable. We've made this a constant. Now a constant is a variable whose value cannot change, and we're saying that's equal to this function, which gives us some type of string. So what I'm going to do now is I'm going to type console.log value. And what this is going to do is print out or log to our console, which is really our terminal, the value that we typed in. So whatever gets stored in this variable, we can then access by using the name of the variable here inside of our console.log. Again, I know this is a lot of information, especially if you've never programmed before. I'm going to try my best not to overload you, but these are kind of fundamental concepts we need to go over. So I'm going to run my code again, and you're going to see I get enter something, and then I can type in hello. When I do that, notice hello gets printed to the screen because that's what we typed in from this function. Again, function gives us some kind of string. This is a data type, a piece of information we can have in our program. We store that in the variable value, and then we access what's stored inside of that variable by using the variable name. Notice if I try to use something like value1 here and I run the code, I actually get an error. So you can see this kind of reference error is popping up saying value1 is not defined. And that's because no variable called value1 exists. If I wanted to print value1, so I wanted to see that in my terminal, then I would actually need to surround this in a string. So I tell my computer and I tell JavaScript, hey, I'm not trying to access a variable. I actually want to print out literally value1. So now if we clear and run, and I type something like hello, you can see I get value1 this time because I put it inside of a string, okay? So that's kind of what we've learned so far. We know what a string is, anything surrounded in quotation marks, and we know how to access a variable. Great. So now we're getting something typed in from the user, and I just want to show you if I try to do something like value equals 1 here, and I go ahead and run my code, you're going to notice I get another error. Now the reason is I'm getting assignment to constant variable. Now this is where we'll quickly talk about the types of variables, and then we'll continue on with the rest of the code. So here we're using a constant. Now a constant is something that can't change. So think of constant value, right? Or think of something like gravity, which is a constant. This is something that's always going to be the same. So we have the ability to define on our variables if we want them to be able to change or not change. In this case, we've said, well, we're not going to change this variable, so we'll make it a constant. However, if we wanted to be able to change the value of it later on, we'd have to use this keyword known as let or var. For now, just use the let keyword, but there is this var keyword, which is effectively going to do the same thing. It just has a few small differences that we don't need to get into right now. So I'm going to say let value equals prompt. And when I use let, this says we're setting up a variable which can be dynamic, which can change. So we can modify its value without a problem. So now if we run our code and we type something in, you notice there's no issue because we used let instead of const. Okay. So already in 7 minutes there, you've learned more than you probably would in 5, 6 different tutorials for JavaScript. Okay, we have our variable now, and what we should probably do is start working on our quiz. We understand the fundamentals, now we can move on and kind of create this quiz game. So the first thing we want to do is probably welcome the user to our quiz. So we're going to put a console.log here, and we'll just say something like welcome to the computer hardware if we can type this correctly, quiz, exclamation point, okay? So now the program's gonna start. It's gonna print this message to the user. And the first thing I think I wanna ask the user is if they'd like to maybe play the quiz, or maybe we'll just go right into question 1. In fact, we can just do question 1. So what I'm gonna do here is I'm gonna say const, and I'm gonna say answer1, which is a variable. And this is a valid variable name, by the way. You can use numbers in your variable name. The rules for the variable naming are if you wanted to have something like a space, you'd have to use an underscore. So if I wanted to do answer1 hello, I couldn't do it with a space. That would cause an error. Instead, I'd need the underscore to represent that space. Or I could then put a capital on the first letter here. So something like answer1 hello to kind of space it out and indicate it's multiple words. This is something known as camel case, which is suggested when you're naming variables. Another rule is that you can't have any special characters. Something like an ampersand is not going to work. And you can't start your variables with a number, but you can have numbers inside of the variable, okay? So we're going to say const answer1 is equal to, and then we're going to ask a question. So what's the first question we should ask? We'll say something like, what is the brain of the computer? Question mark. Okay, and then we'll allow the user to type. Now we're going to be looking for a specific answer. And in this case, the answer we want is CPU, or central processing unit, okay? So now what we need to do is we need to check what their answer is, and we need to see if it's correct. If it's correct, we want to tell them they got it right. Otherwise, we want to tell them they got it wrong. So how do we do that? Well, we need a way to compare this value with the correct answer. So I'm going to make another variable here, and I'm going to say const, and we'll say correct underscore answer1 is equal to, and in a string, we're going to type CPU because this is the expected answer that we're looking for. Okay. Now what we'll do is we'll use something known as an if statement. An if statement allows us to evaluate something known as a condition and see if that's true. So we're going to say if answer1 is equal to the correct answer, then we're going to put a set of curly braces like this. Don't worry, I'm going to explain this in a second. And we're going to say console.log, you got it correct, exclamation point, like that. Okay, so what we've done here is we've set up an if statement. Now the syntax of an if statement is you write if, you put an opening parenthesis, and then you put something known as a condition. Now a condition is something that evaluates to true or false. Now the way that this kind of works is that we have another data type in our program, or in JavaScript, known as a Boolean or a bool, okay? Now this is anything that is the value true or false. So these are the only two valid values that are Booleans, so true or false values, okay? Now, what we can do is we can write something known as a condition, which uses something known as a conditional operator to see if something is a true or false. So when I use something like 3 equal signs here, what I'm actually doing is I'm comparing the left-hand side to the right-hand side, and I'm asking if they are equivalent, if they're the same exact value and the same type. Now, there is a double equal sign as well. Don't use that right now. Just use the triple equal sign. We don't want to get confused with the double equal sign, which works a little bit differently, okay? So I say, is answer 1 equivalent to answer 2? Now, this condition here is going to give me the value true or false. Now, the way the if statement works is if whatever is inside of these parentheses is true, then it's going to execute what's inside of this curly brace block, okay? So this little set of curly braces here is associated with the if statement, and it's saying do whatever's inside of this set of curly braces only if this is true. Okay, if it's false, we're just not going to do it. We're not going to enter into that block. So let's run this and see what we get. And it says, welcome to the computer hardware quiz. What is the brain of the computer? And we're going to type CPU, and then notice it says you got it correct. Whereas if I run this and I type something like the motherboard, we don't get any result. The reason for that is that the motherboard was not the same as the CPU, and so we didn't enter inside of this block, meaning we didn't print this out. Okay? Now there's a few more things to teach you related to this, but hopefully all of this is making a bit of sense, trying to kind of blur the line here between in-depth explanations and, actually writing some code. Once we get through all of this in this first project, we're going to go a lot faster. I just wanted to make sure that I cover all the bases in case you've never seen JavaScript before in your life. All right, so let's run this one more time. And I just want to kind of test something out. And this is what I would encourage you to do as well on your own. If you have a question, don't necessarily wait for me to answer it. You can try to figure it out by actually writing some code and modifying what you have. So for example, what happens if I type CPU with lowercase? That could be an answer. Someone could type that in without uppercases. And notice we actually don't get that output saying you got it correct. The reason for that is when we compare two strings in JavaScript, we're comparing them with their capitalization, so they're case sensitive. So what we actually need to do if we want to allow this answer, or an answer like CP and then lowercase u to be correct, is we need to convert either our expected answer or the answer the user types in to either lowercase or uppercase and then compare them against each other. So the idea here is that we keep our correct answer all in the same case. So in this case, I keep it completely in uppercase, which then means what I can do is I can take whatever the user types in and I can just convert it completely into uppercase, and then I can compare the two strings. So you're just going to compare them using the same case. So how do I do that? Well, there's actually a method, and a method is something that you can kind of use on a data structure or on a data type. And the way this works is you put a dot. So we have answer1, which is a variable. This variable is equal to a string. I'm going to do dot, and then this is 2, and then notice we have uppercase here, and put a set of parentheses. Now what this is going to do is it's going to take answer1, convert it completely into uppercases, and then give me that result kind of in place of this string, or in place of this kind of line or expression that you see right here. I'm trying to come up with the correct word there. It's not going to modify the value of answer one. Answer one will stay the same, but what will happen is it will essentially inject what answer one to uppercase is on the left-hand side of this equal sign, which then means we'll be comparing the uppercase answer one to the uppercase correct answer to check if it's correct, okay? So let's clear and run. And now you can see if I type something like CPU in lowercase, we still get it correct because we converted that to uppercase. And even if I type something like CPU like that, we still get it correct. Now, last thing to show you here is that if I do add something like a space, so I have CPU space, it's not going to give us the correct answer. And that's because a string that contains a space in it is different than a string that doesn't contain a space in it, okay? So just keep that in mind. You're comparing every single individual character, and you can kind of modify the string in a way such that you're avoiding any incorrect answers when it is correct. It's just not exactly what you were expecting, okay? All right, so that's a good start. Now, one other thing to mention is that we should probably tell the user when they get it wrong. So what I'm going to do is add something known as an else statement. Now, an else statement is the complement to an if statement, and this block, so whatever's inside of this curly brace, is going to execute if the if statement is false, okay? So if this condition here is false, we don't do this. Instead, so else, we do what's inside of this block. Excuse me. So I'm going to take this console.log, and I'm going to say, you got it wrong. ... Okay, so now if we clear here, bring this up a little bit, and run the code, and we type something like, I don't know, GPU, you can see it says you got it wrong. All right, so at this point, we've learned quite a bit already, and we're actually ready to just extend this project and add a bunch more questions. Now, we'll add some more things to it, like keeping track of how many correct answers we have, but for now, let's just copy all of the code that we have, paste this here, and let's change our variables just so we don't get an error. So notice here, if I highlight this, it's saying cannot redeclare block scoped variable answer1. Essentially what that's saying is we already have a variable called answer1, so I can't make that again, right? Because this is defining the variable when I use this const block. So instead, I'm going to change this to answer2 and then correct answer2. Now let's come up with another question. We can do something like, what is better, a 3090 Ti or a 4060. I don't even know if they have a 4060 or not, but let's just go with that. And for the correct answer, this is going to be a 3090 Ti, okay? So now we can just change this around again. So we'll say answer 2 and then correct answer 2. And now everything should just work the exact same. We've just kind of copied and pasted this and changed the answer and the question. Okay, so let's save that and run. What is the brain of the computer? CPU, excuse me, 3090 Ti. And it actually says we got it wrong there. Okay, so let me check why we're getting that. Aha, so the reason we're getting this is because we converted our answer to uppercase when our answer here is in lowercase. So what I would need to do is just change this to be capital Ti like that. Or alternatively, rather than converting this to uppercase, I would need to convert this to lowercase. So if you do get an error, don't freak out, obviously. Just do kind of something like what I just did and look through your code and say, hey, why am I getting that wrong? Well, I typed it in lowercase, it was converted to uppercase. Okay, that's probably the issue. And you know that you're kind of going to have the error in one of these few lines here because this is where it's evaluating if you're getting it true or false, all right? So this happens all the time, even to experienced programmers like me. Don't worry if you get an error. Very, very common. In fact, almost a good thing when you're just learning how to code. Okay, so now let's run this again. What is the brain of the computer? CPU. And now we'll type 3090 Ti, and it says we got it correct that time, so we fixed it and it is working. Great. Okay, let's do one more question, and then we'll add tracking of the correct questions. So answer 3, correct answer 3, answer 3, and answer 3. And this time we can do something like say, what is the recommended amount of RAM in 2023? Now, this is going to be a subjective answer, but I'm just going to go with 16 gigabytes like that. This time, we're going to convert this to uppercase. So we're matching the casing of our answer. And that's all we need. That'll fix that. We're just going to need to make sure these are answer 3. They are. Okay, perfect. Let's run this. And CPU, 3090 Ti, and 16 gigabytes. Okay, awesome. All right, so our quiz has now been written. We have 3 questions. Obviously, you can add a lot more. I'm just not going to bore you by adding those right now. The next thing that we really need to do is keep track of how many correct answers we have. Now, this is fairly straightforward, but what we'd like to have is some kind of variable that's storing you have 1 answer correct, 2 answer correct, 3 answers correct, etc., and then display that to the user at the end. So the way to do that is to go at the very top of our program. It doesn't really matter exactly where, so long as it's near the top and before your first question. And we're going to say let correct, and we'll just say answers like this equal, and then 0. Now, one thing I'll mention, just because some of you may be getting upset about this, I've used underscores for these variables. Really, it's going to be best practice to not use the underscore and to do it in camel case, like I have suggested. Different programming languages have different conventions for the way you write your variables. In JavaScript, you are supposed to use camel case, so just because that's the convention, I'm going to change these here. Doesn't really matter. No one's going to get mad at you, at least, you know, when you're just starting out. But just to kind of be correct, I'm going to make sure we're using camel case rather than underscores, which is actually a convention in Python known as snake case. Anyways, I have this variable, let correct answers equal 0. Now this time we're using something known as the number data type, and this allows us to perform arithmetic so we can add to the number, subtract from the number, etc., which is different than the string, right? So the string 0 and the number 0 are different, like discrete, unique values, and they can be used differently because of the type of their data, the type of their information, right? So this is a number, meaning we can kind of add to it, subtract from it, etc. So now that we have this variable here, what we're able to do is go inside of our if statements, and after we console.log correct, or before, it doesn't really matter, but just inside of this if statement, we can actually write correct answers like this, which is our numeric variable, and then we can say plus equals 1. Now saying plus equals 1 is going to add 1 to this value. Another way that we can do this is we can say correct answers is equal to correct answers plus 1, where we're saying, okay, well, what was the previous value of correct answers? Well, was it 1? Was it 2? Was it 0? Whatever it is, add 1 to it, and then assign that to correct answers, so changing the value. Or a third way is we can write plus plus, and plus plus stands for add 1. Okay, this is known as the increment operator, just adds 1 to a variable in JavaScript. So I'm going to use plus plus, and I'm just going to go here and put these inside of all of the if statements. And this way, at the end of our program, it will tell us the number of correct answers that we had. Okay, I don't think there's much more to mention here. I will just quickly say, if you see these semicolons here, you don't actually need them, but what these stand for is a line termination or a line break, which essentially means stop reading the current statement and move to the next line. Okay, that's all that means. I kind of excluded mentioning them because you don't actually need them for your code to work, but since they're here, figured I'd mention that. Okay, so now we're going to go down to the bottom of our program, and we're just going to tell the user how many correct answers they got. Excuse me. So to do that, we're going to say console.log, you got, and then we kind of need to embed this number in the middle of the string. There's a few ways to do this, but the way that we're going to do it is we're going to put a comma. We're then going to put the correct answers, okay? And then we're going to put another comma, and we're going to say questions correct like that. So now what this is going to say is you got, it's then going to put whatever the value of that number is, so 1, 2, 3, 0, whatever, and then questions correct, and it's automatically going to add a space between all of these different values because that's how this function works. So if I come here now, I can print this out. Let's go CPU. Let's get this one wrong. So we'll go with 4060. Let's go with 16 gigabytes. And then it says you got it correct. You got 2 questions correct. Perfect. Now, last thing we can do here is we can actually give them some kind of percentage or grade indicating like what their score was on the quiz. So to do that, I'm just going to make a variable here and I'm going to say total questions is equal to, and I'm going to specify the total number of questions that I have, which in this case is 3. Okay, so we're saying constant. We're making this a constant because we don't expect to change this value throughout our program. But if you did add another question, obviously you would adjust this and make this 4, 5, however many questions you have. Now what we can do is we can say you got correct questions correct, or correct answers, questions correct. Then we can say you scored, okay? And we can say correct answers, and we can divide this by using the / by our, what is this? Total questions, okay? And then we can multiply it by 100 by using the asterisk operator. And I'm just gonna put this in a set of parentheses so that we have this being applied before we have our multiplication. And then what we'll do is we'll just add a % like that, so they can see what their percentage score was. So say like 87.2, whatever, in this case, 33, 66, or 100, okay? So now let's run this. And what is the brain? CPU, 4060 and 16 gigabytes. And it says you got 2 questions correct. You scored 66.666666%. If you wanted to cut that off so that you didn't see all of those values, you do have the ability to round this. Now, I'll show this to you, even though it might be a little confusing. You can simply take math.round, and you can surround all of this here inside of that. Now, I know that gets a little bit messy, so what we might want to do here is say const % is equal to, and then put that there. And then we can just embed the % variable, so we're kind of structuring our code a little bit better and storing some intermediate values, making it a little easy to understand. I know I went a bit faster just because I want to move to the next project, but we're going to take math.round, and we're going to round the division of this multiplied by 100. That's going to round it to the nearest decimal value, so you are going to lose the values here. There is a way to keep them, but I'm not going to show that to you right now. So let's do this, CPU, and let's just hit enter there. It says you got 1 question correct. You got 33%. Perfect. Last thing, and then we'll move on. Some of you may want to actually have a % sign, and you might be getting a little mad that if you put the % sign here, there's going to be a space between it. So what you can do is actually perform something known as a string concatenation. The way you do that is you take this, which is a numeric value, okay? And you can't add a number to a string, because imagine this, right? I have something like 33 plus 7. Yeah, as a human, you can read that, but JavaScript doesn't understand this because adding a string to a number could result in kind of a weird value. Now, in JavaScript, this actually does work. I don't want to tell you to do that because you can get some strange values. So forget about the fact that it does actually work in JavaScript because you shouldn't do that. What you're going to do is you're going to convert whatever the numeric value is to a string. Then once it's a string, you can add another string to it, right? So if I have 33 plus %, then that's going to give me 33% because we're just kind of smushing the values together, which is known as a concatenation, all right? So we're going to take % plus that, but to do this, we're going to say %.toString, which is a method that, again, does not modify the variable. It just gives us the string representation of it. Then we put the % sign like that, okay? So let's clear and run, and let's go CPU, enter, enter, and you got 1 question correct. And it says you score 33%. We really should have you scored 33%. Okay, so that is project 1. I know there was a lot of stuff we covered there. I'm going to go faster in the next projects, but I was assuming you had 0 knowledge of JavaScript. We went through a lot of stuff here. Don't worry if it's a little bit confusing, but hopefully this was a bit helpful, taught you a bit about JavaScript, and you're ready to move on to the next project. All right, so now we are moving on to project number 2. What I've done is I've created a new JavaScript file. So I've called this script2.js, and I've just copied this line in here because we're going to need to use this. For this project, we'll be creating a random number guesser where we'll ask the user to input a number, and then we'll tell them if they are higher or lower than the random number they are attempting to guess. Then we're going to kind of keep track of how many guesses they've had, and we're going to tell them at the end, it took you, say, 7 guesses to guess this random number. Blah, 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 you get the idea. This will allow us to view a few new pieces of syntax in JavaScript and to practice working with math and numeric types rather than strings, which is what we focused on in the last project. Quickly, I'll mention that I am going to pick up the pace a little bit here. If I'm too fast for you, feel free to pause the video or to go to the playback speed and reduce that. Alternatively, if I'm too slow, increase the playback speed and you can get through this a little bit faster. Regardless, would love to hear your feedback on the last project and what you guys are liking or disliking so far. please let me know in the comments. I always take that feedback to heart and kind of try to adjust in my future videos. Okay, so let's get started here. First thing we need to do is generate a random number. Now to do this, we're going to create a constant. We're going to call this random number. We also could call this target. I think that makes more sense actually. Excuse me. And we're going to make that equal to math with a capital dot random. Now what math.random will do is generate a random number between 0 to 1. It's going to give you like a very long decimal value, okay? So if we go here and we console.log the target, let's bring up our terminal here and we run this. Oops, I'm running the wrong script as I was saying. So let's go to node and then script2.js. You can see we get a value like this. So what we essentially need to do if we want to generate a random number between a range or up to some specific value is we do the following. So let's say I want my random number to be between 10 and 100. The way that I need to do this is I say 10, which is the minimum possible value we can have, plus, and then I'm going to say math.round, and I'm going to take my math.random and I'm going to multiply that by whatever the difference is between the maximum and the minimum. So let's say we want the maximum to be 100. Well, then I'm going to generate a random number up to 90. So I'm going to multiply this by 90, which is the asterisk operator, okay? So I take math.round, which is going to round this to the nearest whole number, okay? And we're going to take math.random and multiply that by 90. Now, when we do that, that's going to give us a random number between 0 and 90. So now we know the minimum will be 10, and then it can be anything between 10 and 100, because if we had this at the maximum of 90, that would give us 100, all right? Hopefully that's making sense, but that's how you do a random number within a range. A lot of times you just want to do a random number that is going to be like, say, 0 to 100. If that's the case, then you just take this and you multiply it by 100. It's important that you round this, though, because if you don't, you're going to get a decimal value, which you don't want. You want a whole number, right? So we're going to round this off. So now let's just print our target out, and notice we're going to get a bunch of different random numbers. Every time I run this, you should get something different, or not necessarily different, but something that is random. Okay, so there you go. We're generating a random number. Now that we have that, we want to continually ask the user to guess this number. If they go above it, we're going to tell them you're above. If they go below it, they're below. Otherwise, they got it correct. So let's set up a few variables here. First, we're going to say let, and this is going to be guesses, equal 0. Now what we'll do is we'll add to this every time the user makes a new guess. Now, rather than doing this kind of constant asking right now, for now what we'll do is just ask them one time, get that logic set up, then we'll move into that new piece of syntax we have not yet seen. Okay, so we're going to say that we'll actually use let guess equal, and actually no, we can use constant, sorry, this is fine. We're going to say const guess is equal to, and this is going to be prompt, and we're going to say guess the number, and we'll just put 0 to 100 so they know the range. Then we're going to put colon and a space, and this is going to allow the user to type in a number. Now what we're going to do is we're going to compare this number to the target value and see if it's greater than or less than. However, remember that when we get a guess here, this is given to us as a string, right? So it's going to be like the string of 1 or 2 or whatever the user types in. So what we actually need to do is convert this guess into a number such that we can compare this against the guess, all right? Or against, sorry, not the guess, the target. So the way to do that is we're just going to take number here, and we're just going to wrap this whole prompt statement inside of this number function. All that's going to do is take whatever we type in here and convert that to a number. And just as a note, if you were to type in something that's not a number, something like hello, you're actually going to get what's kind of convenient, which is nan, standing for not a number. So if you type in not a number, number gives you not a number, which is actually a special type in JavaScript. In fact, we can have a look at this by saying console.log guess. Okay, and then running this. And if we type in hello, notice we get nan, right? Where if I type in something like 2, it gives us the number 2. And you can tell this is a number because it's highlighting in yellow. All right, so now we've converted our guess into a number. Now that we've done that, we're able to compare this against other numbers. So what I'm going to do is write an if statement. And for our if statement, we want to check if the guess is greater than or less than the target. How do we do that? Well, it's fairly intuitive. We're going to say if the guess is greater than, so I'm using the greater than sign, and then the target. Now, this is a valid comparison operator in JavaScript. This will compare either two strings, two numbers. It can actually compare pretty much any types, or quite a few types at least. In this case, when we use two numbers, it works exactly as you would expect. We're checking if the guess is greater than, because I usually think of it as like the alligator mouth is eating this value, is greater than target. Okay, if that is, for now, we'll just say console.log, your guess is too high. Okay, and then we'll say otherwise, and then console.log. So let's do this. Your guess is too low. Now, I know there's an issue with this. If you already know what the problem is, feel free to point it out in the comments, or at least just make a note of it mentally. But right now, let's just see how this works, then I'll explain the problem. So let's run this, okay? And let's guess the number of, say, 56. This says our guess is too low. Now, in order for us to determine if this is working, we're just going to print out what the target value is, just so that we know. So actually, we need to do this before the guess. So we're going to say console.log target right here. Okay, just so we can kind of make sure this is functioning. So it's 16 is the actual number. So if we guess, say, 13, your guess is too low. Okay, round it again, 52. We guess 55, your guess is too high. So this is functioning. Now, the issue I was discussing is what happens if I actually guess the number, right? So in this case, I guess 0. It says your guess is too low, when really we've actually guessed the value. So this is where I'm going to introduce something known as the else if statement. Now, the way the else if statement works is it's an additional if that we will check if the first if is false. So what I can actually do here is I can go else if, and just like I wrote my original if statement, I can write another condition here. So I can say if the guess is less than the target. So now essentially the way this works is we check this first if statement. If this is true, we just execute this block and we skip checking this. If this is false, we go to the else if and we see if this is true. Now, the interesting thing with the else if is that you can put as many of these as you want, and you can kind of check a bunch of different conditions in a row and be able to skip checking them if one of them evaluates to true. So the advantage, again, is that if this is true, we don't check any of these. Whereas if what I were to do is remove the else's here and just put a bunch of ifs, what would happen is we would actually check every single one of these if statements because they're actually separate statements that aren't associated with each other. Whereas if we return to having our else's, all of these are kind of chained and put in one single statement, meaning only ever one of these kind of blocks will ever be entered, all right? So I just wanted to show that to you, but we're going to have this else if now. So if this isn't true, check this. If this is true, do this. And now we can add another else. So now what I'm doing is using the if else, where now in the else condition, we can say console.log, you guessed it. Now, the reason why this works here is because if I check if the guess is greater than the target, and it's not, and I check if the guess is less than the target, and it's not, then it must be the actual target, right? It must be the same thing. So if these two are false, it means we must have guessed the value. There's other ways we could arrange this statement. Just wanted to show that to you. So let's now run this. Okay, and now let's guess the number. Let's actually guess 56. Your guess is too low. Let's guess 2, and it says you guessed it, okay? So the statement is working as we expected. Now, one thing to mention here, just while we're at it, it is possible to use the less than or equal to operator. Exactly what it says, checks if it is less than or equivalent to the value. Same with the greater than or equal to operator. Okay, you also can use the not equal to operator. So exclamation point equals equals. If it is not equal to this, do the following, otherwise do this, etc. Okay, just wanted to show you those operators. Okay, so now that we have this, what we'd like to do is repeat this until they get it correct. How are we going to do that? Well, in JavaScript, we have something known as a while loop. Now, a while loop is a loop that will continue looping while a specific condition is true. So what I can do is put while, put a set of parentheses, and inside of here, just like my if statement, I put something that evaluates to true or false. So in this case, I'm actually just going to put the word true. Now, I could do something like while guesses is less than 10. And that means as soon as they hit 10 guesses, we're going to stop, right? So you can do whatever you want here for the condition, but just put something that evaluates to true or false. So in this case, we can just directly write true. Now what I'm going to do is take this kind of set of curly braces here, and I'm going to put all of this code inside of here. Now what's going to happen is we're going to do this loop continually, okay? So we're going to keep doing this forever until we break out of the while loop, which is something I'm going to show you. Now, right now, what we've done is we've written what's known as an infinite loop. This means we just keep going forever and ever and ever because this condition is always true. So what we need is a way to either make this condition false, or alternatively, we need to kind of manually exit this loop, which is what I'm going to show you how to do. So inside of the while loop, we have a few keywords. Now, one of the keywords is break. What break will do is immediately exit the closest internal loop. In this case, the closest loop is the while loop, so we're going to exit out of that by using the break keyword. So as soon as we see break, we're immediately going to stop executing the loop and go right down to what happens after the loop, okay? So now what we've actually done is we've implemented a loop that will continually keep asking you to guess until you get the answer correct. We'll keep adding to that, but for now, let's test this. So clear and run. And, oh, I didn't print out the guess. Okay, well, we can just kind of run this. Let's guess 50. It's too low. Let's guess 75. Too high. Okay, let's guess 66. Too high. Let's guess 60. Too high. Okay, 55. Too low. 57. Too low. 58. 59. And we guessed the value. Okay, so you can see we exit out of the loop and we stop asking because we got it and we broke using this break keyword. Great. So that's how the while loop works. Now what we want to do is keep track of how many guesses the user has. So what we can do is we can simply go to the top of our while loop here and we can say guesses plus plus. This is going to add one guess every time we enter this loop, right? Because we're just going to keep repeating this code. So then what we can do down here is we can say console.log, you guessed the number in comma guesses comma tries. Okay, exclamation point like that, and it will tell us, how many guesses this took. Now that's pretty much going to complete the program, but let's go up here and just test this out. Okay, so guess the number, 50, too high, 25, too low, 37, too high, 30, okay, 34, 33, 32. You guessed it, and you guessed the number in 7 tries. Okay. So I think actually that's going to wrap up our number guessing program. Just a few kind of final educational moments here, I guess. Inside of this while loop, obviously we can use this break, which is what I'm doing, but we also have the option to use another keyword, which is known as continue. Now I won't demonstrate the use case of this, but all this is going to do is immediately restart the loop, okay? So what I could do here, and this isn't really ideal, but we can write it in this way, is the following, okay? This is just kind of an illustration of how this works. I could actually put a continue keyword here, a continue keyword here, and a break keyword here. Now, what this will do is if we enter into this statement, and this can be an else if actually as well, then we're going to continue. Now, what that means is bring us to the beginning of the loop. Don't continue executing anything after the continue statement. So if the guess is greater than the target, don't go down here, just continue the loop again. And then down here, same thing. If it's not greater than the target, but is less than the target, continue, bringing us back to the top of the loop. And then if for some reason it's not any of these, so if we did actually guess the value, then we print you guessed it and we break, right? Which is down here, exiting the while loop. This is a very like anti-pattern way to write this. Like I wouldn't suggest you write it this way, but I'm just demonstrating the use case, right? So if I go here, we can do this too low, 75, too low, 95, too high, 90, 93, 92. Okay, you guessed it, and then notice this works exactly as it functioned before. Okay, I think that's going to wrap it up. Let's move on to the next project. All right, so the next project I have for you is a rock, paper, scissors game. This idea is that we're just going to ask the user if they want to be rock, paper, scissors. We're then randomly going to pick for the computer rock, paper, scissors. And we're just going to see how many wins, losses, or draws that they have at the end of the program. Let's go ahead and start writing this. So I've created another script file. Again, I'm going to take my prompt and just paste this in here. I'm going to go a bit faster this time, and I'll write kind of some more code and then slow it down. So let's make a few variables. We're going to say let wins equal 0, let losses equal 0, and let ties equal 0. Okay, now what we'll need to do is we'll need to ask the user if they want to be rock, paper, scissors, and then generate kind of a random value and determine if the computer is rock, paper, or scissors. So we're going to say const choice or yeah, choice, I guess, is equal to prompt, and then we'll say enter rock, paper, or scissors like that. Okay, and we'll allow them to enter something. Now what I want to do is I need to make sure the user actually entered one of these valid options. If they did, then we'll continue. Otherwise, we need to ask them to retry. We're going to put this inside of a while loop, but I like to write some more logic before we do that. So I'm going to show you something new here. I'm going to say if choice is equal to rock, or choice is equal to paper, or choice is equal to scissors, and we're going to put a triple equal sign here as well, like I was mentioning. So what I'm actually checking here is 3 conditions in one, and I'm chaining them together using something known as a logical operator, which we've not yet seen. Now this double pipe operator here acts as an OR, okay? So it's equivalent to writing OR. Essentially what that means is if the left side or the right side is true, then the whole expression evaluates to true. Now in this case, I've confused you intentionally by writing actually 2 sets of ORs, but all this is checking when we put the ORs kind of chained like this is if any of these conditions are true, meaning they typed in rock, paper, or they typed in scissors, okay? You have to chain it like this, how I've written it, but if any 3 of these things are true, it evaluates to true. So we evaluate each individual condition. Only one of them can ever be true, but as long as one of them is true, we go in here. Otherwise, we would need to say something like console.log, okay? And then we're going to say, please enter a valid choice, okay? And in fact, I'm actually just going to reverse this just because I think this will be a bit educational. Rather than putting the else here, I'm just going to put this in the if, and I'm actually going to negate this. I'm going to say if choice does not equal rock, and I'm going to use something called an and choice does not equal paper, and choice does not equal scissors, okay? So now I've just reversed the condition so that you can see how we do this in the opposite direction using the other logical operator. This operator is the and. It works opposite to the or. Both the left and the right-hand side need to be true. So in this case, I'm saying all 3 of these need to be true to enter into this, otherwise don't enter. And then I've negated the condition, so rather than checking if it is true, I'm checking if it's not true. So I'm saying if the choice is not equal to rock, and the choice is not equal to paper, and the choice is not equal to scissors, so if it's not any of the valid options, tell them enter a valid choice. Let's just quickly test that before we go any further. So we're going to clear and run script 3, and notice that if I type in something like R, it says please enter a valid choice, whereas if I type rock, that is fine. Okay, so that is working. I know that's new, but wanted to show that to you. All right, so if they enter a valid choice, then what we do is randomly pick something for the computer. So how are we going to do this? We're going to say random, and in this case, I'm actually going to say index, I'm going to teach you something new again, is equal to, and this is going to be math.random, and we're going to multiply this by 2, and we're going to say math.round, and then round this. Now, the idea is this is going to give us a value of 0, 1, or 2, which we're going to use as an index for something known as an array. Now, I'm actually going to put const choices is equal to an array. I'm going to say rock, paper, scissors like this. Now, an array is a ordered collection of elements, okay? So what I do is I put a set of square brackets. This defines an array. Now, every element in our array is accessible by an index. An index is an integer that represents the position of the element. So the first element, rock here, is indexable or accessible by index 0. Paper, indexable or accessible by index 1. And scissors, index 2, okay? So what I've done is I've generated a random index, which will correspond to either 0, 1, or 2, which then in turn corresponds to rock, paper, or scissors, right? That's it. That's all we're doing. So that's kind of what we're doing. The reason I do it out of 2 is because, well, the max index is 2. It's always going to be 1 less than the length of the array. There's a lot more to talk about with arrays. We're not going to get into all of it, but I just wanted to show you a simple use case right here. Okay, choices, random index. Now we need to generate the computer choice. So we're going to say const computer choice is equal to choices. And the way we access an index of an element is use a set of square brackets, and then we place in here random index, which is the index we want to use. So if I put 0, that gives me rock. If I put 1, that gives me paper. If I put 2, that gives me scissors. In this case, we'll use random index because that'll be the random value. Now, because we're not quite done, we're going to say console.log the computer choice. Okay, we're going to clear and run, and we'll do something like rock, and then notice it gives us paper. Now let's run this again. Let's do paper. Gives us paper. I just want to give me something different. Gives me scissors. Okay, so you can see it's randomly generating something for the computer. Okay, perfect. So now that we have all of that, we're just going to check if the computer beats the player. How are we going to do this? Well, the first thing we can check for is if we have a draw. If we don't have a draw, then we can check the 3 different conditions that result in a win for the player. If they don't win, they lose. There's a bunch of different ways to check this, but it is unnecessary to check all 9 different combinations because of the fact that we can exclude the draws and we only need to check for a win condition. So you'll see what I mean, but I can say if the computer choice is equal to the choice, which is really the player choice. And what I'll do is I'll just show you in VS Code. What I can do is I can highlight this and I can hit Control H or Control F, and then I press this little button here, standing for find and replace. And I can actually put a string to replace this with. So I can say player choice like that. And then I can put this capitalization here and this little underscore. And now you'll see what this does is it only selects where we just have choice. Whereas if I remove these, it's selecting like choices and it would select like the capital choice. But if I put both these on, I'm matching the spacing and I'm matching the capitalization. And now I can press this little button that says replace all, and it just replaces all of those for me, okay? So anyways, now that I've done that, I have if computer choice is equal to player choice, then we drew, right? So I'm going to console.log draw. And then I'm going to say ties plus plus. Again, we're going to put all of this in a while loop in a second, but for now, I just like to write all of the logic kind of at once. Okay, so we're checking if they drew. If we didn't draw, then we're going to check if the player beat the computer. And if we didn't beat the computer, then we lost. Now, there's 3 conditions where we beat the computer, right? So we're going to say else if the player choice is equal to, and in this case, we'll say this is paper, and the computer choice is equal to rock, then we won, right? So we could say console.log 1. And then we can say wins plus plus. Now what I could do is write another else if statement and just do the same thing and check if we are rock and the computer's paper, or we can do all the other win conditions, or I can just chain them inside of here. Now, it might get a little bit confusing, but let's do it anyways because the whole point is to learn here. I'm going to put these in a set of parentheses. This is our first winning condition, right? If all of this is true, if the player chose paper and the computer chose rock, we won. Now, what's the other winning condition? Well, the other winning condition is, let's just copy this and paste this here. And you're going to see it goes on a new line for us, so it kind of formats it. Anyways, now I'm going to say if the player chose rock and the computer chose paper, then we won. Okay, so that's the next winning condition. So notice I've put these in a set of parentheses because I need to kind of separate them out. So we have the first winning condition, second winning condition, and now the third winning condition. And I'm going to check if any of these 3 winning conditions are true, because if they are, we won, right? Which is why I'm separating these larger conditions with the or statement. So now, rather than paper, rock, we're going to say, okay, scissors, and sorry, I realized this is rock and this needs to be scissors, okay? So we're going to say if the player chose scissors and the computer chose paper, then we won. Now, maybe I'm crazy, but I'm pretty sure these are the only conditions in which we win. So now we handle that, and then we have an else, and we say, okay, if we didn't tie and we didn't win, we must have lost. So we say const.log lost, and then we type losses plus plus. All right, so that wraps that up. What I'm quickly going to do is I'm just going to add another console.log here, and I'm going to say the computer chose, colon, comma, and then computer choice. And we actually don't need the space because it will automatically add it. Let's just zoom out a little bit because I know that's getting a bit hard to see. So we have our 3 variables, right? We ask them to enter rock, paper, scissors. We make sure they selected something that's valid. Now, we haven't actually put this in a while loop yet, which we will do. For now, this is just going to tell them to enter something valid, even though we'd continue with the program. In a second, we're going to not do that. Anyways, we pick what the computer is selected, okay? we print out what they selected, and then we check if they won, if they lost, etc., right? Saying, okay, if it's the same, then we draw. So we say that. Otherwise, we check the 3 winning conditions, win, otherwise, loss. All right, let's run this. Enter rock, paper, scissors, enter rock. The computer chose paper, you lost. Okay, perfect, let's continue. Enter rock, paper, scissors, paper, the computer chose scissors. All right, seeming like this is rigged, but let's see. Scissors, the computer chose paper, you won. Okay, nice. So you can see this is working. However, we want to now continue essentially until the user tells us to stop. So now how do we do that? Well, we use a while loop. So all we do is we take all the code we want to repeat. We're going to go here and we're going to say while true. Okay. And we're going to wrap everything inside of here. So now we have a while loop, which means we're just going to continually do this. All right. And then what we need is a way to exit the loop. Now, first of all, let's go here and put a continue statement. So continue like that. Now, the reason we're going to put continue is because if the user does not select a valid value here, then we're just going to tell them to kind of go again, right? So we'll repeat the while loop right from the beginning, which just means we're going to continue repeating this portion of code until they give us a valid value. Okay, please enter valid. This is going to be choice. All right, nice. Then we'll do all of this. And then what we'd probably want to do is once we exit the loop, or we need a way to exit the loop, sorry. So I'm going to say enter rock, paper, scissors. And then I'm going to put in parentheses or Q to quit. Okay. First, I'm going to check if they typed in Q. So I'm going to say if player choice equals Q, then I can just go here and I can say break. So it's just going to exit the while loop for us. Okay. So if they enter that, let's quit. And we can even convert this to lowercase so that if they type in uppercase Q, we still quit. All right. Then lastly, we'll go down here and we'll just say console.log. It will just print out their record. So we'll say wins, losses, and then ties, ties like that. Okay, I think that's going to be it. Let's run this though and give it a test. Okay, so let's just try to quit. Okay, so notice, there you go, that works. Let's enter, let me zoom in a bit here. Rock, okay, computer chose scissors, you won, all right. Let's enter paper, excuse me. Okay, scissors, let's enter something invalid. Okay, please enter a valid choice. So let's go paper and let's quit. It says 2 wins, 1 loss, and 1 tie. All right, so I think with that said, that's gonna wrap up this project. This is definitely the hardest one so far. I wanted to go a bit more challenging and show you some more different operators and things that we can use, but hopefully you guys were able to complete this and most of the code that you see here makes sense. All right, so this project is going to be a fast one with the idea that you can extend this and make it as complicated as you want. I'm just going to show you probably in about 5 minutes the structure of a project like this, but it's really extensible and something that you could even kind of combine with some of the other projects. The idea is want to have a choose your own adventure game. The point is that we have all these different nested paths that we can go down. So you might have seen those books before where it's like, do you want to fight the dragon with the sword or do you want to run away? And then it says, if you decide to fight, turn to page 35. If you decide to run, go to page 53. A lot of kids' books are kind of like that, right? Where you're picking the path you want to go down. And depending on the decision you make, you're going to either win or you're going to lose or you're going to end up in a different position. That's what we can do with code. I'm just going to start coding it for you and you'll see very, very quickly how you can kind of work on this on your own. All right. So the idea is we're going to first need to ask the user for some information. So we're going to take this prompt and we'll start with something like const answer is equal to prompt. And the first thing we might ask is something like, would you like to play ? And I usually just put what I expect the answer to be inside of parentheses so that the user knows what to type. So Y or no, okay? So we're going to say if answer dot to lowercase is equal to yes, then we'll play. Otherwise, we'll console.log and we'll say that's too bad. Okay, so that's kind of the first decision, right? Do they want to play? Yes or no? All right. Now, only if they said they want to play do we ask them the next question, which means we put that question inside of this if statement. So I'm going to say const answer to is equal to prompt, would you like to go left or go right ? Okay, and then we're just going to put here left /right. Now I do the same thing. I check if they answered left, we do this. If they answered right, go here. If you want, you can say if they didn't answer correctly, maybe you ask them to do it again, or you can just end the game. You can pick what you want if they give an invalid answer. I'm just going to essentially check for one answer. If they don't give me that, I'm going to assume it's the other one. So I'm going to say if answer 2 is equal to left, then I'm going to do something here. Otherwise, we're going to assume it's right. We're going to do something here. So I can actually make a comment. A comment is some code that will be ignored by your program, by the way. If I do 2 slashes, just to indicate this else statement is what happens if I go right. So let's say we go left, and I do something like console.log. Oops. You go left and fall off a bridge. bit extreme here, but you get the idea. You lost. Okay, so left was not the correct path, so they have to go right. So if they go right, we can do something like console.log. Nice. You go right and approach a bridge. Okay, you can be as creative here as you want. And then I can ask another question. So I can say const answer 3 is equal to prompt. And I can say, would you like to cross the bridge? Or we can say something like turn around and find another way. And then we'll put as the potential answers here, cross/turn. Okay. Excuse me. Same thing, we come down here. Let's just make this a little bit larger. And we now put another if statement, and we say if answer 3 is equal to cross, then you do something here. Otherwise, you do something here. Now, I don't really want to continue too far with this, so I'm just going to say console.log. You cross the bridge and reach the end of the game. Okay. Otherwise, we can say something like console.log. You turn back and trip on a log and hurt your leg. You lose. Okay. So the whole point of what I'm trying to show you here is that we can nest these different blocks inside of each other. Okay. So I've done this very, very simply because I'm just trying to illustrate this to you quickly because this is a project that's really meant for you to work on your own. But the point is that we only go into one block if the other block is true. So if this is correct, right, so like if we do want to play, then we ask the first question. Depending on the answer to the first question, we now branch off and we go to the left or we go to the right. So in this case, if we go to the left, you lose, but you could make it so that each answer could potentially lead you to the correct scenario, right? The whole point is that you can infinitely branch as much as you want by nesting these statements. So that's what we're doing. We have this, all right? We say otherwise, so if you didn't answer left, you're going right. Okay, nice, you approach a bridge, ask you another question, and then again, we check inside of here and only inside of here what the correct answer is. So if you cross, okay, you won the game. Otherwise, you lose, but we could just make it so you continue going down a bunch of other decisions. Now, you can even make this more complicated where you have previous decisions impact future decisions. Now, they already do, but what I mean by that is at the beginning of the game, you can ask something like, what weapon would you like to select? Do you want to wear boots or do you want to wear sandals? Do you want to wear a hat or do you want to take this? And you can kind of, collect some different items, for example, and then you can use those items later in the game. So eventually, maybe you reach a dragon or something, and you can say, oops, you didn't bring your sword with you, so you lose the game because you can't fight the dragon. So the decision they made maybe 20 steps ago is now affecting them here, and they have to restart, get all the way back there, but make sure they make the correct decision. So let me run this just so you get an idea of how it works. Okay, so sorry, we don't want script 3, so close that. We want script 4. Would you like to play? Yes. Do you want to go left or right? We go left, and it says we lost, right? So we can round again. Yes. Let's go right. Nice. You go right and approach a bridge. Would you like to cross the bridge or turn around and find another way? Let's cross, and we win. But again, you can see if we go the wrong way, so I decide to turn, it says you turn back and trip on a log and hurt your leg. You lost. You get the point. That's how the game functions. Now, I actually worked as a kind of coding teacher at a summer camp where I was teaching kids who are between about 10 and 15 how to make this exact game. This was kind of the final project they worked on at the end of the week. And I'll just say that they came up with some super creative and really interesting projects where they had like hundreds of lines of code, 20, 30, 40 different paths, and they absolutely loved it. It was super, super fun. So I know this is a simple, like relatively simple thing to do, but it makes really interesting games and something that's really cool that you can show to your friends, family, whatever, and you can see if they can actually get to the correct path. And obviously, the more complex and more interesting you make it, the better the game's going to be. So please make something like this, extend it. You even could do something crazy where like one of the paths requires you to play rock, paper, scissors. And if you lose, then you lose, right? And you have to go back and do it again. So all kinds of interesting stuff you can do. So what I'll do now is quickly demo each of the finished projects. If you want to fast forward to one of them, there will be timestamps in the video player as well as in the description. This is the order in which we'll complete them. I recommend if you're a complete beginner, then just go in this order as I'll build upon each project in the next one. Okay, first project, Color Flipper. Allows us to simply switch between some different colors for the background of the screen. And if I click on random, we will randomly generate a color. Pretty straightforward, but it's allowing us to see how we connect events to button presses and how we can randomly generate colors and set DOM properties. Next is a palindrome checker. A palindrome is something that's spelt the same forwards as backwards. This is actually a very famous algorithm style problem and something you might get asked in a very early stage interview. So a palindrome example is something like dad, because this is spelt the same forward as backwards. So if we type check, it says it is a palindrome. If we do something like madame, right, that's a palindrome because it's same forward backwards. If we do dog, this is not a palindrome. So just a simple check showing you how we can check for a palindrome. Next is a random quote generator. So what this will do is randomly give us a quote on the screen. There's lots of modifications you can make to this, but you'll notice that what I've done is made it so that we're going to go through all of the different quotes that exist before we start cycling back to one of the same ones. This means you're never going to see the same quote once or twice in a row, and you're going to get through all of the unique quotes before you end up seeing a repetitive one. Kind of an interesting feature that makes this a little bit more complicated and an interesting project. Next, we have a timer or a stopwatch. This is going to teach you about set intervals and how to handle timed events in JavaScript and with HTML. So we can, of course, start the stopwatch here. You'll see that it goes up. We can stop it, we can reset it, we can start it again. And this also teaches you how to handle some different edge cases. For example, what happens if I press start when it's already started? Well, in this case, we restart it from the beginning. What happens if I press stop a bunch of times? Well, stay stop. What if I keep resetting it, right? It works. And lastly, we have a persistent to-do list. Now, this is interesting because this will actually allow us to store items in between browser refreshes. Just to quickly demonstrate this to you, you'll notice that if I start the stopwatch here, but then I refresh the page, it's going to go back to the original state. Same with the random quote generator, right? If I refresh, just goes back to the original state. Now, watch what happens with this one. So I'm going to go add item here for hello world. And when I refresh, notice it's still here. So we can do, I don't know, item 2, add this in here, refresh, still here. If I delete one of the items and refresh, it stays here. So I'm going to show you how we can do some persistent storage using local storage in the browser, which is quite interesting. So again, feel free to fast forward to any of these projects. Now we're quickly going to go through the setup, which won't take us very long, and then we'll actually get into coding these out. All right, so I've popped over to Visual Studio Code. Now this is the editor I recommend that you use for working on these different projects, but you can use anything you want. What we need to do here is get in an environment where we're able to write both JavaScript and HTML code, and that's going to be easiest in Visual Studio Code. Now what we'll do is we'll start by creating a folder. So you'll notice I've already made one, but if I delete it, we can just remake it here. So let's go new folder, and I'm just going to call this 1 because this is where we're going to put project number 1. Inside of here, we're going to make 2 files. The first file is going to be our main.html file, and the second one here is going to be our index.js. Now this will be the structure for all of our different projects. So if you're going to do all 5 of them, you can just copy this directory and have 1, 2, 3, 4, 5 as the various different names. Once we've got these 2 files, I'm just going to show you a really useful extension in VS Code if you're using this editor that I recommend you install. Now this is called the live server. If you go here to the side in the extensions menu, which is this that I've clicked on here, kind of looks like the little puzzle pieces or a square with one of them removed, you'll see live server pops up here as the top result. It's got a bunch of downloads and I've already got it installed. What you'll do here is just click on install. It might make you relaunch VS Code. And I'm going to show you how we utilize this so that we don't have to keep refreshing the page whenever we make a change to our code. That's pretty much all you need. Once you've got that, you're good to go. And we're going to start working in our two different files. So at this point, we're going to begin project number 1. Make sure you install that live server extension if you don't already have one. Okay, so we're going to go into our main.html file and we're going to start by creating kind of the template or the user interface for our application. Now, in case you're unfamiliar, HTML is hypertext markup language, and this is something that allows us to actually create elements that exist on a web page. What's better though is that it allows us to actually interact with JavaScript or vice versa. JavaScript can interact with the HTML, which means if we say type something into an input box or we click on a button, JavaScript can handle that action for us and allow us to display different things on the screen or kind of determine what's going on. It gives us that dynamic behavior. So to begin our HTML document, there's a little shortcut you can use here in VS Code, which is HTML:5. Now, when you type that, you'll see this autocomplete shows you HTML:5, and if you click on it, it's going to give you this whole template document. Now, if for some reason that's not working, no worries. What you can do is go ahead and pause the video, and you can start typing this out. What we need is the following. We need this tag up here. Let me zoom in a little bit so it's easier to read. That says doc type HTML, and make sure you type it exactly like you see it. So you have the exclamation point, doc type, you have your angle brackets here, and then you have HTML. We specified the language at the top of the page. It's not necessary, but it's good practice to get into. So we do again our angle bracket, HTML language is equal to EN, standing for English. And then we specify our head tag. Now the head tag is where we put some metadata related to the application. If you're copying this out yourself, you don't need these two tags here. You can just leave it like this. So put head, and you'll notice that we have an enclosing tag here that it has this slash. So whenever we're working in HTML, you'll have an opening tag, and then you'll have a closing tag, and that'll denote kind of a section where we can put some different content. So in this case, we put a title tag. So we have our title opening tag and our title closing tag. And this is the title of our web page, which will appear kind of like this in the little heading or the kind of browser tab. So in this case, for project number 1, this is the color flipper. So we're going to name the title color flipper. We're then going to have our body tag. Now it's important that the body tag comes after the head tag. As I said, inside of this head tag here, you have metadata related to the application. Inside of the body tag is where you're going to put the content that will live on the page. Now notice that all of this is happening inside of these HTML tags. So we have an HTML opening tag and an HTML closing tag. Inside we have the head tag, and below that we have the body tag. If we add some indentation, it kind of looks like this. Okay, so just make sure you have this set up here. I know I'm spending a bit of time on this, but I just want to make sure none of you get kind of led astray right at the beginning. So it should look exactly how I have it here. The white spaces don't matter. You just want to make sure it looks just like this. Okay, now we've got this. It's time to start creating the basic user interface for our application. Now to do that, we're going to write a few tags here, which will represent physical elements that will exist inside of our HTML document. So what we'll do just to start and just to test things out is we'll create an H3 tag. Now for all these tags, with the exception of ones like the doc type tag, which we don't need to talk about right now, you always have your opening tag and your closing tag. And the closing tag always has a / denoting the end of a section or of an element, okay? So like the body tag has its closing body tag, the H3 tag has its closing H3 tag. Inside of here, we're gonna say color flipper. Okay, now when I save that, we're gonna get a bit of formatting. Don't worry too much about that. What I wanna do now is show you how we actually open this page up so we can see where our code's actually running and what it is that we built. So we have two options here. The first option is we can simply just double click and open our HTML file. So what you'll need to do, depending on your operating system, is you'll need to find the folder this exists in. Now in VS Code, you can simply right click on the file, and you can click Reveal in Finder or Show in Explorer. So if you're on Windows, there should be something that says like Show in Explorer or Show Location. And if you click that, it's gonna bring up a file kind of search menu for you here and show you where the file exists. So in this case, if we just double click it, you'll see that it will show up. And if I want, I can zoom in here by hitting Control Plus or just by zooming in Google Chrome. And you'll see that we've got our head tag appearing and we have the title, color flipper, kind of showing up here, okay? So I'll exit out of that for now, but that's the first way to open up your code. The second way is to use this live server extension. Once you've installed live server, you should see this go live button down here. So we're going to go ahead and click on it. And what that will actually do is create a little server for us that's going to run this HTML file. And now anytime I make any changes, let me just put this on the side of my screen and go like color flipper 1. As long as I save this main.html file here, very important that you save it, you'll see that it will just automatically adjust. So you can see up here, we're getting color flipper 1 in our title. Okay, so that way we don't have to constantly keep refreshing the page. If you don't have live server, you will need to refresh the page for the updates to appear. Okay, so from this point forward, we can kind of move our screen over a bit so that we can see what we're doing on the right-hand side. And on the left-hand side, we have our code. Okay, so we have color flipper, and then we have our H3 tag here of color flipper. Now again, just a reminder, if you're not seeing any updates here, just make sure you save the file. You can do that by hitting Control S or by going to File and then hitting Save at the top of the screen. So we're gonna now work inside of our body tag. That's where most of our work's gonna be because that's where we're actually creating the different elements that appear on the screen. For now, what I wanna do is create a few different buttons that are gonna sit here and allow us to click on them essentially to change the background color of the screen. So to make a button, you simply type button like this, and then again, you're gonna have your closing tag. So you have an opening tag and you have a closing tag. Then what you'll do inside of the button is you'll give a kind of name to the button or what you want the text to show as. So to start, I'll start with green. Now, when I save that, you'll see that this green button appears. I'll show you how to change the color in a second, but for now, we just have the green button. So now we're gonna copy this and we're gonna have a button, which is gonna be the red button. And we're gonna have another button, which is gonna be the blue button. Okay, we're then gonna add one more button. So we'll copy this down here and we'll call this the random button. Now I'll just make this a little bit smaller and you'll see that now it will fit all on the screen. I just have this zoomed in a lot. For you guys, it'll probably be quite a bit smaller. I'm just zooming it in so you can read it a bit easier. Okay, so now for all of our buttons, what we're gonna wanna do is actually change their background color, right? So rather than like the green button being gray, we want it to be green. So there's a few ways to do this, but the best way is to create some CSS or a kind of styling for this button. So to do that, we're gonna go up in the head tag now. So outside of the body, make sure we're in the head, and we're gonna write a set of style tags. Now the style tags is where we can specify styling properties for different elements in our HTML. Now, before we're able to actually kind of apply a style to these different buttons, we need to give them something to identify them with. Now we can give them a class, we can give them an ID. There's these different identifiers that we can have for HTML elements. Right now we're gonna use an ID and later on we can look at a class. So for our buttons, inside of the button tags here, we're gonna say ID is equal to, and then we're gonna put double quotation marks. And inside the double quotation marks, we're gonna specify the identifier for this button. Now this button is gonna be green. It's important that for all of your IDs, they're unique values and they're enclosed in double quotation marks. You also want to make sure you don't have any spaces or any weird characters like this or brackets, okay? You just want to have kind of a standard string or a standard set of characters. You can have numbers, that's fine, but you just want to have kind of a normal set of characters here, okay? So for the ID, we're going to go with green. And then for this ID, we're going to go with red. And for this ID, we're going to go with blue. So we now have a way to identify our various buttons. Now what we're gonna do is go in the style tag and we're gonna style them. Now to access what we wanna style, we have to specify the identifier. Now the identifier for using an ID is this pound sign. So when I put this pound sign and then I put the ID I wanna access, so in this case like green, I'm now accessing any element that has the ID equal to green. So what I'll now do is put a set of curly braces, and inside of these curly braces, I can put any styling properties that I want to apply to this button. So in this case, I can simply say the background color is equal to green. Now when I do that, it's going to change the background color of my button, so it's now green. Now we can go ahead and do the same thing for our other buttons. So we can say red, and then inside of here, we're going to have background color red. Okay, so now we have a red button. Same thing here for our blue button. We're going to say background color, and then blue. Okay, that's awesome. Now, if we want to make our buttons look just a little bit nicer, There's one more thing we can do that will actually apply a style to all of our buttons. So maybe I want to make my buttons a little bit round, want to make them a bit bigger. We can do whatever we want, right? But let's say I want to make them a little bit bigger and rounder. Well, to do that, I can actually just access the tag button, and now any button is going to get this property. So I can say button, and I can put two sets, or I can put a set, sorry, of curly braces. And now anything I put in here is going to apply to any of the elements that have this button tag. So here we're using the ID as the identifier. Here we're using the tag name as the identifier. And there's tons of different ones you can use inside of CSS. It's not meant to be a CSS tutorial, but I do want to teach you this. Okay, so for our button, we're going to set a border radius. And by the way, like, look how many properties there are. You don't need to memorize these, okay? I have a few of them memorized because I've used them before, but you can always just look up the styling properties if you want something unique. So I'm going to go border radius, and we're going to set this to be 5 pixels. When I do that, you'll notice we get some rounding on the corners. That's what border radius does. Next, we can set, say, the width. So I can say the width is 100 pixels. Make sure you have the pixels here. If you don't have the pixels, you're going to get an error. And then I'm going to set the height here of 40 pixels. Okay. Now you'll notice the buttons are a little bit close to each other. So what I can do is apply something known as a margin. The margin is the amount of space between the different elements. And I can say we're going to have a margin of 5 pixels. And when I do that, notice they kind of get spaced out a little bit nicer here, and they're separated on the screen. Okay, so at this point, we've got pretty much all we need for the actual user interface. What we want to do now is start working with our JavaScript, which is what this tutorial is supposed to be about. So what we're going to do is inside of this index.javascript file, so .js, we're going to link that to the HTML. Now to link this file, we go into our body tag, and at the bottom of the body tag, we specify a script, okay? And make sure, again, you have your closing script tag. And we say that the source for this script, which is src, is equal to index.javascript. Now this works because this index file is directly in the same directory as our HTML file. So we just want to make sure that this file is in the same directory so that we can reference it directly. So that means all we have to do here is just write this out. And assuming you have the name spelled correctly, just always double check your naming. It's going to link these files together. So now what we can do is we can start setting up some events so that when we click on the buttons, it does something in the JavaScript, which then modifies the code. So how should we do this? Well, there's a few ways that we could kind of get started here, but the first thing I want to do is access the kind of body component. So I want to access this body element so that I can show you how we change the background color of it programmatically in JavaScript. So to do that, we're going to create a variable. Now there's two types of variables in JavaScript that we can create. We can create them using the constant keyword or const. This means it's a variable that's not going to change. We're not going to modify it later on. Or we can use the let or the var keyword. And this is going to create a dynamic variable where its value can change. Now in our case, we're not going to change this variable. So we're going to say const and then body is equal to, and now we're going to use document. Now what document is going to access is the HTML document, and it's going to allow us to reference any element that exists inside of here. So in this case, I want to get the whole HTML document pretty much. So to do that, I'm going to say document.get element. And then notice that we have a bunch of options here, right? We have by tag name, by class name, etc. We're going to use tag name because we want to get the tag name of the body element. So let me zoom out a little bit here. Okay, so we're going to say const body equals document.get elements by tag name. And then we're going to get the body tag. Now what this is going to do is give us the body tag itself. However, there's a little thing we need to look at. So what we're doing is saying get elements by tag name. Notice this plural s. Now that means that this is actually going to return to us what's known as an array of the different elements that have this tag name. Because when you're getting a tag name, there could be multiple elements that have, say, the button tag or the paragraph tag or other HTML tags. Now in our case, we're getting the body tag, and we know there's only going to be one of those. However, in order for us to access that tag, we have to actually index it at index 0. The way you can think of this pretty much is that body here, like this variable, so this tag, sorry, is going to return to us a list. And this list is just going to have one element. And that's going to be the body tag we want to access. Now to access the first element in the list, we simply put these square brackets and we put 0. That's the index or the kind of pointer, I don't know what you want to say, identifier of this element, because 0 is always the first element in our list. So now this variable is going to get, well, the first element in our list, which is just the body tag, okay? I know it's a little bit confusing for a completely beginner tutorial, but I'm trying to go nice and slow. So now what we're gonna do is we're gonna say body.style.background color is equal to, and then we can set this to any color we want. So I could set it to say red. Now when I do that, notice that the whole thing changes, right? The background color changes to red. The reason that happens is because once we've kind of made all these UI elements here, we've linked our script tag, and inside of the script tag, what's happening now is we are getting that body component, that body element that I was talking about. We're then changing the style, and specifically, we're changing the background color to be red. Now we can change anything else we want. There's a bunch of other properties we can modify, but in this case, we just want to do the background color. Okay, so that's working really nicely now. The next thing that we want to do here is we want to make it so that when we click on these buttons, we change the color. So to do that, we're going to make a function. Now a function is just a block of code that we can call that's reusable. So I can say function, this is how you start defining one, and then I can give the function a name. In this case, I'm going to call it setColor. Make sure you don't have any spaces or any weird characters in your name. And then I'm going to give this something known as a parameter. Now, parameter is kind of a unique value that you can pass into the function so that it can do something different based on the value you give it. So now inside of this function, so I have these set of curly braces, by the way, make sure you don't forget this. You got to kind of type it exactly as I have it. What we're going to do is what we just did. We're going to say body.style. And this is going to be background color is equal to, and then name. Now name is going to represent the name of the color that we want to set the background to. So what we've just done is made a function. And when we call this function, we can give it a name, and whatever that name is, we'll set the background color to. So I can simply go here and I can call the function. The way you call the function is you write the name of the function, which is setColor, and then you pass to it any of the parameters that it specifies. In this case, the parameter value is name. So I can just pass it, say green. And when I save it, you'll notice that the background color goes to green. Now the thing is I can call the function multiple times. So I could say red. Now it's going to go to red because first we set it to green, then we immediately set it to red. Now if we want, we can change this and we can set it to blue. We could even go to something like purple, and you get the idea here. We're going to continue to change the background color using this function. So that's great. But the thing is, I want to call this function when I press on these buttons. So how do I do that? Well, I'm going to go to my HTML, and inside of my button tags here, I can actually register an event called onClick. Now what onClick will do is call a JavaScript function when the button is clicked. Now that's great for us because we have our function here that we can call. So we're going to go onClick is equal to, and inside of double quotation marks here, we're going to write the name of our function exactly as we have it in the JavaScript. Now in this case, it's setColor. But remember that we have to pass a parameter, which is the name of the color we want to set. So what we're going to do is put two sets of parentheses here, and make sure you put single quotation marks, okay? The reason we're using single quotation marks is because we have double quotation marks here, which is kind of, what do you call it? Giving us the ability to write this function in. Whenever you're working with these properties of these HTML tags, you need to kind of put them inside of double quotation marks. So in our case, we're saying, okay, onClick is equal to double quotation marks. And then inside of here, we're saying setColor, but now we need to pass a string value to our function. So in order to do that, we're now going to use single quotation marks so we don't get mixed up with the double quotation marks. So we're just using singles because it does the same thing as doubles, but it allows us to embed them inside of a set of double quotation marks. I know it's a little bit confusing, but please just use double quotation marks here. And then for this one, we're going to say green. Okay. And now what happens is when I click this button, it's going to call this setColor function with the parameter green and set the background color to green. So now all we need to do is copy this for all of our different values and change the parameter here to be the according color. So it's going to be red and blue. Okay, so now I can go red, green, blue, and I can set these colors on the screen. And the last thing that's left is to set the random color. Okay, so now to set the random color, we're going to need a different function because we're going to do something different. So we're going to say function random color. And same thing here, we're going to put a set of parentheses, but this time we don't need any parameters. We don't really care. We don't need to pass anything to the function. It's just going to do something when we call it. And inside of here, we're going to generate a random RGB value. Now, RGB stands for red, green, blue. these values go from 0 to 255, okay? And this allows us to create pretty much any color by using a combination of red, green, and blue. If we had 0 red, 0 green, and 0 blue, we'd have black. If we had 255, 255, 255, we have the full red, full green, and full blue, then we would have a white, okay? That's kind of how RGB works. So what we're going to do is start generating 3 random values, a random amount of red, a random amount of green, and a random amount of blue. So we're going to create a constant variable again, because these don't need to change. We just want to create them so we can store our value. And we're going to say const red, that's the name of our variable, is equal to math with a capital M dot random. And then we're going to multiply this by 255. Now, the multiplication operator is simply the asterisk here, which you can find on your keyboard above the 8 if you hold shift. Now, what math.random does is it generates a random value for us between 0 to 1. So you get this kind of random, multi-decimal value, like an example is like 0 point, something like this, okay? We now take that and multiply it by 255, and what that ends up giving us is some value that's between 0 and 255. Because if we generate a number between 0 and 1, and then we multiply that by 255, we get a random value in the range of 0 to 255. The issue is that random value is going to be a huge, decimal point value with a bunch of things. So what we need to do is round it off. So we're going to say math.round, and then we're going to put all of this inside of here. What we're actually doing is using the rounding function. We're passing in some random value we generated, and now it's going to round it to a whole number. So we can copy this and paste this and do the same thing for green and for blue. So now we have a random red value, random green value, and random blue value that are all in the range of 0 to 255. Now all we need to do is use those values to create a color that we set the background with. To do that, we're going to do a bit of a string manipulation. So we're going to say const color, again, creating a new variable, and this is going to be equal to, and we're going to use backticks. Now, you may not have seen this symbol before, but if you look at the tilde on your keyboard, which is the squiggly line typically below the escape key, or at least close to there, there's these symbols that kind of look like single quotation marks. They're not. They're called backticks, and you're going to find those on the keyboard, okay? You're going to put a set of backticks, and inside of here, you're going to type RGB. You're going to put a set of parentheses, and we're going to embed the variable red, green, and blue inside of here. Now to do that, we're going to put a $sign and a set of curly braces, and we're going to put red, and then we're going to repeat this for green and blue. Now what we're effectively doing here is creating a color that we'll be able to use to set the background color with. So to do that, we have to have the string RGB, and then we have to have 3 numbers, right? The amount of red, a comma, the amount of green, a comma, and the amount of blue. That all needs to be inside of a string, so we use this kind of neat string manipulation trick with these backticks to embed these number variables, because the data type of these variables is a number, not a string. Strings are in double quotation marks or single quotation marks. Numbers are just values like 67 or 255, and we embed them here inside of this variable. Now that we have the color, we can simply say body.style.background color, and rather than using the name of our color, we can use this RGB value. So we can say color like that. And now when we call the random color function, so let's do it down here, you'll see that we get a random color. So every time I save, you'll see we get a unique random color because it keeps refreshing the screen for us. Or every time you refresh, you'll get a different random color. So now what we need to do is make it so when we press this random button, it does that. So all we have to do here is for the random button, we just go on click is equal to random color. Make sure you put your set of parentheses here to call the function. And when we call random, we get a random color on the screen. All right, we're moving on to project number 2, which as you might recall is a palindrome checker. So we're just going to check if a string is the same forward as it is backwards. Okay, how do we do this? Well, let's begin by creating our files. So we're going to have our main.html file, and we're going to have our index.js file. Now I've already done this for project 1, so if you're confused at all, go back to project 1. I'm going to go a little bit faster now than I was before. So again, if it's too much, go back and watch project number 1. We're going to start by typing HTML:5, and then we get our autocomplete. If that doesn't work for you, go to project 1, and you can just copy the HTML, and you can remove what you don't need, or you can pause the video and you can type this out. You don't need these you can remove those from the screen. I'm going to zoom in a bit so it's a little bit easier to read. Okay, so now we're just going to change the title of our document. So rather than having this, we're going to have Palindrome checker. And for the interface for this one is going to be quite simple. We just want to have a title that says Palindrome checker. And then we want to have the ability for someone to type into a little box and then to press a button to check their string. So we're going to start inside of our body by having an h1 tag. And we'll just say Palindrome checker like that. And what we can do if we'd like here is we can rerun the live server, which will give us access to view this code as we're writing it. So what you'll notice here is that if you look at the bottom right-hand side of the screen, you'll see this thing that says port 5500. If that doesn't work, you can also just type live server. The way I open this, by the way, I know I went a bit faster, is I hit Control, Shift, and the character P on my keyboard. This opens the command palette in VS Code. So it's either Command Shift P or Control Shift P, depending on your operating system. And then I typed live server. When you do that, you'll see you have open with live server and stop live server. So first I'm going to stop the live server because I had that running before. So you saw that stopped it. I also could have just pressed the button down here. And now if I click on go live, or again, I have Control Shift P and then I go live server and then open with live server, it's going to open up that HTML document, which you saw right here. So what we'll do is we'll just leave this on the right-hand side of our screen. We'll move this over to the left so that we can kind of see what we are doing as we write the code. Now let's make this a little bit smaller so that we can actually see the full title. Okay, so now we have our title. The next thing we want to do is create an input box as well as a button for the user to type in. So in order to get an input box in HTML, you simply type input. Now this is what's known as a self-enclosing tag, meaning you can simply type a / and the closing angle bracket like this. You don't need to type like /input like we had before. In fact, that won't work if you do that. And here for the input, we're going to specify the type of the input, which is going to be text. And we can give this a placeholder and we can say type something. Okay, let's make this a little bit smaller. So now you'll see a little input box pops up here and I can type inside of this. That's the basic HTML tag. You can also use this for numbers, dates, all kinds of stuff. Now, as well as the input button or input box, sorry, we just want to have a button that you can click on. So we're going to say button. And then for the button, this is going to say check. You'll notice a button appears. And now nothing's happening because we don't have this linked up, but you could click on the button. Okay, lastly, we're going to link this to our HTML or to our JavaScript, sorry. To do that, we're going to create a script tag at the very bottom of the body of our HTML document. Then we're going to say source is equal to index.js. Again, recognizing that this only works because the index.js file is inside the same directory as our main.html file. Okay, so make sure you have that set up. All right, now we're just going to give an ID to our input. The reason for that is I need a way to actually get what the user typed into the input box. There's some other ways to do it, but the cleanest way is to simply give this an identifier. So we're going to say ID is equal to, you can call this whatever you want, but I will just call this the input, okay? Again, don't use any special characters, just use kind of a normal string like this. Okay, so that's pretty much it for our HTML. We've got our very simple interface here. And now what we want to do is start writing in our JavaScript. So let's open up our JavaScript file and we'll do the rest of the work from here, other than a few small things we'll add in the HTML. Okay, first thing we need to do is figure out how we can get what the user has typed in this box. Because before I can check if it's a palindrome, well, I need to know what it is that they typed, right? So to do that, we're going to say const input. We're declaring a constant variable, one that's not going to change. And this is going to be equal to document.get element by ID. Now, what this allows us to do is get one element by its identifier, right? Which is the ID that we set. Now, in this case, the ID is input. So what I do is I put input inside of double quotation marks. Just to quickly show you, we have ID equals input. If it was input 1, we would go here and we would change this to input 1, okay? I know it's confusing because I did the same thing, but just it's the ID, okay? It's not the name of the tag, it's the ID. We're doing it differently this time than we did in the first project. Okay, so now we've got the element. When we have the element, it gives us access to this whole input box. So we could change the styling, we could clear what's inside of it. We can also get what's inside of it, but that's not what this does. This just gives us the whole tag or the whole element itself. And then if we want to get the value, that's different. So let's write a function here called check. Okay. And inside of this function, all we're going to do is we're just going to output what the value is. So to do that, we'll say const value is equal to input dot, you guessed it, value. Now you might notice that I'm putting these semicolons. You don't need them in JavaScript, but they're what's known as a line terminator. This just means we're ending the current line and then moving to the next one. Again, you don't need them. Like, it's fine if you don't have them, but if you see me add one, it's just out of habit. Anyways, what this does is give us the value of the text input. So now if I'd like, I can use something known as an alert. An alert is a message that will pop up in the browser, and I can simply alert the value. So now all we need to do is make it so that when we hit check here, we call this function and it will tell us what the value is. So to do that, we go to our button here and we say on click is equal to check with two sets of parentheses. Okay, or sorry, one set of parentheses because we have the opening and we have the closing. So now when we click this button, it calls the check function. The check function gets the value of the text input and pops it up on the screen. Let's test it with test. Click on this and notice it shows us in the alert box test. Okay, so now we know how to get the value. Now what we need to do is figure out how to determine if this is a palindrome. Now recall that a palindrome is simply something spelt the same forwards as backwards. So if we have dad, that's a palindrome. If we have dog, not a palindrome, okay? So how do we check this? Well, there's a bunch of ways, and I challenge you at this point, if you know some basic JavaScript, try to see if you can figure this out, but I'm gonna walk you through it now. The easiest way to do this is for us to simply reverse the string and then just compare it to the original string and see if they're the same. So what I mean by that is, okay, we have the string dad, so let's now reverse it. Well, that gives us dad. We're gonna check if they're the same. They are the same, so they're a palindrome. Whereas if we have something like dog and we reverse this, we're gonna get God. Well, these are not the same, okay? So it's not a palindrome. So now we gotta figure out, okay, how do we reverse string? Now I'm gonna show you a fancy way to do this, and then we can go through a manual method as well. So I'm gonna write a function called reverse string. Now this is gonna have the parameter str. This is a value that will give us input to the function. A function is simply a reusable block of code that you can call as many times as you want. So what we're gonna do is we are going to first take this string. So a string is anything, again, in double or single quotation marks, and we're going to convert this into a list or to an array. Now an array is a collection of elements that are ordered. So we can have an array that has the values like this. Okay. Now the way you access the elements in an array are by using its position or its index. The first position in the array is always the 0th index. We always start counting at 0 in programming. So here, this is position 0 or index 0. This is index 1, index 2, oops, let's go here, index 3, and index 4, okay? Now the interesting thing with arrays is there's all kinds of what's known as methods, which are essentially operations or functions that we can call on the array that can manipulate them. So what we can do is we can take our string, which is a different type, right? It's just a set of text essentially. We can convert it into an array. We can then reverse the array, and then we can take the array and turn it back into a string. It's not the most optimal way to do this, but it is a way that we can kind of do this in a single line, and I'm gonna show you those operations. So what we can do is we can say return str dot split. Now what dot split does is it takes a string, again, anything in double or single quotation marks, and it splits it based on what's known as the delimiter, which is the value that we specify here. Now, oftentimes you would use this split operation to take a string and maybe get all of the words that exist. To do that, you would have a delimiter of a space, and that means that we're gonna look for all of the spaces, and as soon as we see one, we're gonna take whatever's on the left side and whatever's on the right side, and we're gonna add those as unique elements into an array. So if we were to split on hello world and we used the delimiter of a space, it will give us hello and world in an array. So now we have all of the words like that are in a sentence, right? Now, if we split on an empty string, all that means is take every single character and put it into an array. So in the case where we have hello, it just turns that into an array that has those 5 characters. So we're going to split. Now, after we split, we're going to reverse. Now, notice I'm using this dot notation. You can use this on certain data types, and it's like calling a function on that thing. So we're calling split on the string. Then we take all of this and we call reverse on it. So we're now reversing the array. Now that we've reversed the array, that's going to give us the reversed array. So in the case of dog, right, that would give us G, O, and D. And what we want to do is we want to compare this to the original input. But remember, the original input is simply the string dog, right, in this example that I'm using. So what we need to do is we need to now take this array, and we got to convert this into the string version of it that looks like this. How do we do that? Well, there's another method we can use, which is .join. And what .join does is it takes all of the different elements that are in our array, and it combines them together into a string with a separator or a delimiter. Now, in this case, if we use the empty string delimiter, we just get all of the characters smushed together. Join is kind of the opposite thing of splitting, right? It's taking the array elements and turning it into a string, whereas splitting is taking the string elements and turning it into an array. If I were to join with a space, then we would get this. But when I join with the empty string, we just get the string. Okay, so that was my long explanation of how these methods work. Again, I'm trying to be really thorough, especially with the beginner projects. Let me know what you think of this in the comments. Okay, so we have reverse string, so now we can reverse a string. So now let's just do a test, and let's say, okay, const reverse is equal to reverse string of value. All right, so what we're doing now is we're calling the reverse string function. We're passing in the original value. We're now returning a reversed version of that. So now let's simply alert reverse. Okay, now let's go here and go hello. And notice we get the reversed version. Now I need to make sure I remove the space here because you can see it's kind of spaced out. So let's run this again. Again, every time when I save this, it's going to automatically update. So just make sure you're saving it and you see we get it reversed. Okay. So now that we have it reversed, we're just going to check if it's the same as the original. So to do that, we're going to make an if statement. An if statement allows us to check a condition. A condition is something that evaluates to true or to false. And the way that we can do this condition is we can say value equals equals, so 2 equal signs to reverse. Now it's actually best practice to do 3 equal signs. I don't really want to get into all of that in this second, but either 2 or 3 equal signs doesn't matter for this example. And what this will do is it will compare these 2 values for equality. It's going to check, are these the same? That's what happens when you use multiple equal signs. Don't think you can use like 4 or 5 equal signs. It's just 2 or 3. They have different meanings, but in our instance, they'll do the same thing. So we're going to use 3 here. We're going to say if value is triple equal to reverse, then inside of a set of curly braces, we're going to alert. I will say Palindrome like that. Okay, I'm just making it a little bit excessive. So that's if this is the case, then we go inside of these curly braces and we do this. We have an alert. Otherwise, which is where this else statement comes in. So we're going to put an else and we're going to put a set of curly braces. We're going to alert and we're going to say not today, exclamation point. Okay, so that's it. This is a basic check. If statement, again, you have some condition. In this case, we're checking if these things are the same. This is going to give us either the true or false value. If they're the same, it's going to give us true. And if this thing is true, we do this. Otherwise, we do this, right? That's all how this works. So if I go here now and I type dog, we get not today. But if I type madame, I get palindrome, okay? So now the thing is, you might be noticed, when I click this, it keeps this input here. I don't really want that. It's going to be a little bit better if I actually remove this input after I press this button. So I can do that by simply going here and saying input. Remember, that's this variable here. Dot value is equal to an empty string. So rather than getting the value, we're actually setting the value here. So I'm setting the value to an empty string. So now you'll notice if I type hello and I click on check, it says not today. And then it gets removed, right? We changed the value to be nothing. This is just clearing the value from the input field. So now we are moving on to project number 3, which is our random quote generator. Let me first stop the live server here. So this is going to stop. And let's make a new folder here called 3. And let's go in here and make our files. So main.html and index.js. I'm going to go a little bit faster. Again, we're just going to progressively pick up the pace. If you're getting confused, go back to the previous project because that's where I really break it down in more detail. Okay, so for main.html, we have a random quote generator. We're going to begin by setting up our HTML document. So we can type HTML:5 and hit enter. Let's remove this so we can view it more. Again, if that doesn't work for you, then you can simply pause the video and type this out, or you can go and copy some of the other projects. Also, this code will be available on GitHub in case you want to copy it. You don't need this, so you can remove that if you want, although you can also keep it. And for the title, we're going to change this to be the random quote generator. Now I'm going to copy this and we're going to create a header tag here inside of our body. So we're going to say h1 random quote generator. And now we just need to simply make the interface. Now for the interface, we're simply going to have a paragraph tag, which is this p tag just for some standard text. We're going to say the ID is the quote, just so we have a way to identify this tag. And this is where we're actually going to put what the random quote is. So when we generate it from JavaScript, we're going to populate this paragraph tag with it. Now we're going to create a button. Now for this button, we're just going to say generate quote. And inside of the button properties, we're going to say onClick is equal to, and we're going to call a function called generate quote with our double parentheses like this. Again, if it's confusing, please go back to the other videos. I already explained how all of this stuff works. Now we haven't yet written this function in JavaScript. We're going to write it in a second. So now all we need to do for this interface is we need to make our script tag. So we're going to say script at the bottom of the body, make sure it's at the bottom. Source is equal to index.js, keeping in mind this only works because index.js is in the same directory as our main file. Okay, that's the HTML. Let's go live again this time. And now you can see that we have this generate quote, random quote generator. When we click this, nothing happens. That's fine. Okay. Quick thing, by the way, at this point, I guess I'll show you that if you're on Chrome, if you right click and click inspect, it's going to bring open this kind of developer view. If you click on console, you can see any errors that might be happening. So if you're getting some issues, you can see in the console what's going wrong. I should have showed that earlier, but I guess we didn't have any mistakes yet. So if I refresh, you see it gets cleared. And now if I press this button, it's telling us, oh, uncaught reference error because we haven't defined this function. Okay, just wanted to quickly show that to you. Anyways, let's now go into index.js. We're pretty much done with the HTML. And let's write our random quote generator. So first things first, we need some quotes. Now I'm just going to copy in a bunch of these. You guys can kind of find your own quotes. You can write them, or you can just stop and you can write these out, or you can go to the link in the description. There'll be a GitHub link where this finished project code is, and you can just download all of these quotes or kind of copy and paste the text and paste it in. Just to get started, if you want to just test this, you can just have quotes that are like 1, 2, 3, whatever. Okay, something super simple. Now what we're doing is we're putting this inside of an array. Now remember, I was talking about an array in the previous project where this is an ordered collection of elements where each one of these quotes here, even though they're quite long, they have an index or a number that allows us to access them. So this is index 0, this is index 1, this is index 2, index 3, index 4, etc. And that's how we'll grab our different quotes from our kind of collection of quotes here. So what I'm going to do is create a new data structure that we haven't seen yet with a variable called used indexes. Now this is going to be equal to a new, we're going to use this new keyword, which I'll discuss in a second, set. Now let's quickly discuss a set. So a set in JavaScript is a unique collection of elements. Now the set typically is denoted with the curly braces, although in JavaScript doesn't really have that type of notation. And inside the set, you can only have values that are unique. So I could have like 1, 3, 4, but I can't have 2 ones, okay? You just have a single instance. So the set doesn't keep track of order. It doesn't keep track of quantity. It just tells you if you have something or if you don't have something. So we know, okay, yeah, 4 exists in the set, and we know that 5 does not exist in the set. That's all a set is used for. Now you might be saying, well, Tim, can't I just use an array for that with all these elements? You can, but the thing with a set is it's actually more performant. So it's a faster data structure when all you care about is if an element exists or if it doesn't exist. In our case, when we're going to be generating these quotes, what we're going to do is we're going to put the index of quotes that we've already used inside of the set so that we can check really quickly if we've already used that quote or not. So that way we don't recycle the same quotes until we've gone through all of them. That's what makes this project a little bit more complex. We're introducing this set. Now in this case, I use this new keyword. Now you have to use this with some certain data structures in Python. Essentially what we're doing here is we're creating a new instance of the set class. You don't have to worry about all that terminology. It doesn't matter that much for a beginner, but it's just a bit different than creating something like an array where you can just define it like this. Okay, so for the set and for some other data structures, you need to actually use the new keyword. So I'm saying, okay, we're making a new set. All right, that's it. So now we have the two variables, quotes and sets. What we want to do now is we want to populate the paragraph tag with a quote. So we'll begin by simply randomly picking a quote, and then we'll start using this set to make sure that we're not recycling the same quotes. So we're going to say function generates quote. Okay. Now inside of here, the first thing we've got to do is we've got to get access to that paragraph tag. So this one right here, so that we can set its value. Now what I'll do is I'll create another variable here. And I'll say const, and this can be quote tag is equal to document dot get element by ID. And the ID of this, I believe, is simply quote. We can go back and reference that. And you see, yes, it is quote. Okay, so what we're doing is we're just grabbing access to that paragraph tag. Right now you don't see it because there's no text in it, but when we start using it, it will be. And I'm actually just going to call this quote element so it's a little bit more clear. Okay, inside of here, if we want to set the text of this paragraph tag, we can simply say quote element dot, and we have a few options. But the option I'm going to use here is inner HTML with all capitals for HTML. What this does is set what's in between the opening and the closing tag. You can use this on other tags as well, but for us, we'll just use inner HTML, and we can just make this equal to like hello world for now, just to test it out. So when I press this now, you should see that hello world appears in the tag. If I refresh and press it again, you see that we're populating the inside of the HTML of that paragraph tag with hello world. Okay, so that's kind of what we're going to use to actually set the quote. So now what we've got to do is we've got to randomly pick an index inside of our quotes array, select that quote, and then populate it inside of the paragraph tag. Now we've already kind of done this, but let's do it again. We're going to say const random idx is equal to math dot floor. And then inside of here, we're going to say math dot random, and we're going to multiply this by the quotes dot length. Okay, so we just used a few new pieces of syntax. Let's quickly talk about this. Math dot random, as we saw before, randomly generates a value between 0 and 1. Now, what we're doing is we're multiplying that by the length of our quotes. So you can use this dot length property. It tells you how many elements are inside of the array. And that's going to give us now a random value that's between 0 and whatever the length of the quotes are. In this case, I think we have like 10 quotes or 9 quotes or something like that. Okay, now what I'm doing is I'm saying math.floor. Now what floor will do is always round down. The reason I'm always going to round down is because the length of the quotes is actually going to be one index beyond what we can access. So let's say here, I don't know how many this actually is, but let's say we have 10 quotes, okay? If we have 10 quotes, this last quote has an index of 9, right? Not 10, 9. So if I try to access quotes at index 10, we're going to get an error. It's going to tell us that this index doesn't exist. So what I'm doing is I'm saying, okay, well, we'll generate a random number between, and this is going to be 0 and 1, and multiply it by the quotes.length. The thing is, it's never going to actually be 1. The most it will be is like 0.9999999, whatever, right? So when we take that and we multiply it by quotes.length, we might end up getting something like 9.9999999, okay? If that's the case, we simply take that value and we round it down to 9, and now we're getting the last quote, as opposed to if we were just to round it, it would round up to 10, and then we'd be trying to access an index that doesn't exist, okay? So that's why I'm using floor. There's also a seal that will round it up. Also, not sure if you guys can hear the supercar behind me, but I'm currently in Dubai, and that has proven to be a bit of an issue, that there's too many Ferraris and Lamborghinis driving around. So Kind of a fun fact, but yeah, that's where I'm recording. And if you heard that, well, there you go. Sorry, not much I can do about it. Okay, so we have random index. Now that we have the random index, we're going to use that to get one of our quotes. Okay, so to do that, we're going to say const quote is equal to, and this is going to be quotes, and this is going to be at index random index. Okay, so we've generated a random index. We've now used that to access the quote in our array. And can you guess what's next? Well, we're going to populate the paragraph tag. So we're going to say the quote element dot inner HTML is equal to the quote. Okay, so now let's run this, and it starts giving us random quotes. However, you'll see that sometimes we'll get the same quotes and like pretty close together because we don't have that other component that we're going to implement now. Okay, so let's make this a little bit larger. All right, now what we want to do is we want to make sure we're not using the same quotes. So to do that, we're going to keep generating a new random quote or a new random index until we haven't yet used that. So to do that, we're going to make a while loop, and we're going to say while true. Okay, and then we're inside of curly braces here. We're going to take all of this and we're going to paste it here. Now what we're going to do is we're going to generate this random index, and we're first going to check and make sure that we haven't used it yet. So we're going to go here and we're going to say if the used indexes dot has, okay? So this is how you check if the set has a value. We're going to say if it has the random index that we just generated, then what we're going to do is use this continue keyword. Now notice that I didn't actually have to write the, parentheses here, or these curly braces. The reason for that is because if you only have one thing you want to do with an if statement, you can just write it directly to the right or directly below the if state definition. You might not have known that in JavaScript, but it's kind of a nice shorthand syntax. Anyways, what I'm saying is, okay, if the used indexes has this random index, it means we've used this quote before. So we're just going to continue. And what continue will do is simply bring us to the top of this loop. Now this loop is going to continue looping while this condition is true. So I say while true, so while this is true, it's always going to be true. We keep going through here. And then if this is the case, we're going to continue. So it's just going to bring us up to the top of this loop. Now you might be asking, well, doesn't that mean we're never going to exit the loop? Well, as of right now, yes. However, I'm going to show you how we can do that. So if we are in a position where this does not have the random index, what will happen is we won't continue, which means we're going to continue down to these lines. Kind of a weird way to say that, but we'll essentially advance to these lines if this condition is not true, which then means down here, I can say break. And what break will do is break me out of this while loop. So as soon as the break keyword is encountered, you simply go to wherever the while loop is finished and you just continue there. That's all that does, okay? So it just gets you out of the loop. If you have while true, you're going to need a break to make sure you don't have an infinite loop. Now, the last thing we need to remember to do is to add the index we used to that set so we keep track of it. So we're going to say used indexes dot add, and we are going to add the random index. So what that's now doing is adding that to the set and telling us, okay, next time you try to generate a random index, don't use this one because we just used it before. All right, we're almost finished. There's one more thing, but I want to just show you that this is working. So if we run through here, it's still functioning. However, if we do this enough times, you're going to see that we will actually get an error and no more quotes will be generated. Notice no more generated. The reason why that's happening is because we've run out of quotes that we can pick from. And right now the browser, if I refresh, you'll see it's actually in an infinite loop. So I need to close this out. The reason it's in an infinite loop is because of something we implemented that I'm going to fix for us in a second. So let's just go live again and we'll see if we can figure out what's going wrong here. Okay. So let's have a look at this code. And before I kind of answer the question here, try to ask yourself or try to figure out, let's zoom out a bit, why did I just get that error where my browser was kind of frozen, like it wasn't generating any more quotes? Pause the video if you want to try to figure it out. I'm going to go into the answer now. So you'll notice what happens here is we have this while loop. We say while true, we generate this random index. We then check, okay, well, does it exist inside of the set? If it does exist, we're just going to try again. So we could be trying quite a few times, but eventually we're going to get an index that does not exist in the set, right? So then what happens is we will advance down here and we're going to grab the quote, set it, and then add it to the set. Now, at some point in time, what will happen is we will have exhausted all of the available indexes and we will have used all of them. So what will then continue happening is we're going to be in this while loop. We're going to try to generate a random value. We'll do that, but no matter which one we generate, it's always going to be inside of the set, which means we're just going to continue doing this portion right here a ton, right? That's what's going to happen. So how do we avoid that? Well, the way we avoid that is right here, before we go in the while loop, we make sure we do actually have a quote that we can pick from. So to do that, we can say if the used indexes dot size. For a set, you use size. For an array, you use length. We're going to say if that's greater than or equal to the quotes dot length. What that tells me is that we've used all of the quotes, right? If the number of elements, which are all unique, inside of the used indexes is equal to the length of my quotes, that means we've used all of them. So what do we do? Well, we simply reset and we say used indexes dot clear. Now dot clear will simply remove all of the values from the set, which now kind of sets this back at the beginning state and allows us to continually keep generating new quotes, but now kind of right back from the beginning. So now all of the quotes are available and we go through the exact same thing again. Once we use all of them, then we can start to recycle them. So this way you're only ever going to see the same quote in the number of quotes, which is equal to the number of quotes that exist here. I know that's a bit of a mouthful, but that's kind of how this works. So now if we start generating them, you'll see that we're never going to get the same quote until we've exhausted all of them, and then we'll get a random one, and then same thing, we won't get the same quote again until we've used all the other ones that exist. All right, we are continuing. Project number 4. Let's make a directory, and let's make our two files, main.html and index.js. Now, for HTML, you already know the drill. If you watch the previous projects, we're going to go a bit faster. HTML:5. That is going to create for us this kind of template HTML file. You do not need these two. If for some reason that shortcut does not work, you can simply type out what I have here. Let me zoom in a little bit. Let's set the document title. This is going to be our timer/stopwatch. It's actually really more of a stopwatch, so let's call it a stopwatch. Okay, and inside of our body tag, let's give an h3 that says stopwatch. And now let's run our live server. We're going to dispose of the old one and we're going to rerun this new one. And you're going to see that stopwatch appears in our browser. Okay, so we've got the basic setup. What we're going to do for the stopwatch is we're going to have some functionality that allows us to start, stop, and reset a timer that will appear on our screen. Now, I just want to be clear, I'm going, again, a bit faster in this one. If it's too fast for you or too complicated, go back and watch some of the previous projects because I'm much slower in project 1, 2, and 3. But as we go through, I assume you've watched those or you're already experienced enough that I don't need to explain like the really, really basic stuff. Okay, so now that we have stopwatch, what I need to do is start setting up the user interface. Now, for the interface, we are going to have something that shows us the time. And then we're going to have 3 buttons, start, stop, and reset. So let's begin with the time. I'm going to put this in an h1 tag. We're going to give this an ID of time. And we're going to start with 0000, okay? So this is just showing us the minutes and seconds. We can do with hours if we want, but for now, we'll just do minutes, seconds, and you'll see how you can adjust this to go as long as you want. Now we're going to have our buttons. For our buttons, we're going to have onClick. For our onClick, we're going to call a few functions, which we'll then write in the JavaScript, which will handle when we press these buttons, essentially. So right now, they're not written yet, but we'll write them in a second. So the first one's going to be start clock. And then inside of the button, we're going to have start. Okay, let's copy this and paste it twice and just adjust these now to be stop and reset. Okay, so now rather than start clock, it's going to be stop clock. And rather than start clock, it's going to be reset clock. Okay, so we've got 3 different functions that we're going to need to write: start, stop, reset. Now we need to link our JavaScript. So we're going to say script source is equal to index.javascript. And that's all we need. That is our HTML. So now you see we have start, stop, and reset. We have our 00, we have our stopwatch heading. And now we can go into index.js and we can do the fun stuff, which is the JavaScript. Okay. So for our JavaScript, we need those functions. So let's start by stubbing those functions out. When I say stub, that just means you write the function, but you don't actually write the logic for it, okay? So we're gonna say function start clock. We're gonna say function stop clock. We're gonna say function reset clock. Okay, so now we have our three functions that we're going to need to write in a second. Now, before we go any further, there's a few variables that we're going to need here, and I'll talk about how we'll actually do this timing component, which involves using something known as a set interval. Now, first, we need to keep track of how many seconds have elapsed, okay? So we're just going to track how many seconds have elapsed since we started the clock. And then if we stop the clock, we'll just stop counting the seconds pretty much. And if we reset, we'll reset them, right? Otherwise, we'll just keep adding 1 to it every second, which will allow us to, well, have a stopwatch. So let's begin by having our variable, and we're going to call this seconds elapsed, okay? Now, this is going to be equal to 0. Because when we start the clock, well, 0 seconds have been elapsed, and until you start it, well, 0 seconds have elapsed, right? We're then going to have something known as the interval. Now, for now, we're going to set this equal to null, which just means we're kind of defining a variable and we're saying, okay, we're going to change this later, but for now, we're going to make it null. Null just kind of means nothing, empty, right? Undefined. I mean, it's a different value, but in this case, null is fine, okay? So we're saying second elapsed, and notice we're using a let. When we use let, that means that we can actually change this value later on, as opposed to if we had const, then we wouldn't be able to change it. Okay, now we're gonna grab the actual time kind of paragraph tag here or header tag, so that we're able to modify it later. So we're gonna say const time is equal to document.get element by ID. The ID of this was time, and this is okay to be a constant because this doesn't change, just what's inside of it will change. Nice. So now what we need to do is figure out, well, what are we doing when we're starting the clock, stopping the clock, etc. So to start the clock, we'll go in here and we'll start writing this. We need to create an interval. Now, an interval is something that can run at any predefined kind of period of time. So every second, every 2 seconds, every hour, every 10 minutes, whatever you want. Okay, you can specify the time in milliseconds, which I'll show you. And what it will do is call a function whenever that increment hits. So every 1,000 milliseconds or 1 second, we will increment the clock, right? So we'll say second elapsed plus equals 1. So to do this, we're going to say interval is equal to set interval. This is a function that's built into JavaScript, so you can just write set interval. And then what we do is we call a function, which we'll write here in a second, and we put the number of milliseconds that we want to call this function in between. So in this case, I'm putting 1,000, and now we need a function to call. So we're going to make a function. We're going to say function timer like this. Okay. And inside of timer, all we're going to do is say second elapsed plus plus. Now plus plus simply means add 1. That's all it means. It's equivalent to plus equal 1. It's equivalent to this equals second elapsed plus 1. Okay, so we have second elapsed plus plus. And now what we do is we put timer, just the name of the function. Notice I don't call the function. I just put the name of the function here as the first argument to the set interval function. So what's going to happen now is when we start the clock, we're going to set this variable interval to be equal to the set interval, which calls this timer function every 1,000 milliseconds or every second. The thing is, if I do this now, if I refresh and I run and I click start, you'll notice that nothing's actually happening because we're not updating this. So what we need to do now is we need to update this every time we change the value of our timer or of the second elapsed, okay? So to do that, we're gonna make another function and we're gonna call this set time. Now the set time function is simply gonna be responsible for telling us how many seconds have elapsed and updating this value right here. So all we can do in here, just to keep this super simple for now, is we'll say time.innerHTML. So let's go here, is equal to, and then this is just going to be time, okay? Or sorry, not time. This is going to be seconds elapsed. And now inside of the timer, after we increment the seconds, we're going to call the set time function. So what happens now is, okay, we have the interval. Every second we call timer. It adds 1 to the number of seconds. We then call set time. Time goes here and it then changes this text to be equal to the number of seconds. You're going to see what happens, but let's run this out. And you'll notice that it starts simply counting up, right? 1, 2, 3, 4, 5. However, what will happen if we let this run long enough is it's going to start giving us 61, 62, 63. And it doesn't really look like that kind of stopwatch we're looking for. We want it to be in that hour or in that minute second notation. And also these buttons obviously don't work. And when I click start again, you'll notice it starts counting even faster because we now have multiple intervals that are running. So we got to fix all of that. I'm going to show you how that works. Okay, So first things first, let's make it so that when we adjust this, it actually looks proper. How do we do that? Well, we need to determine, first of all, based on how many seconds have elapsed, how many minutes have elapsed, and then how many seconds have elapsed. So to determine the number of minutes, we simply need to take the number of seconds, we need to divide it by 60, and we got to figure out the even division of that, right? So we don't want something like 2.3, we just want 2 minutes, and then the remainder we'll have as our seconds. So we're going to say const minutes is equal to, and this is going to be second elapsed divided by 60. However, again, we don't want to have a decimal value, which we're going to get, right? So we want to put math.floor. Now, we're not rounding, we're flooring, meaning we're going down to the nearest whole number, because even if we have something like 1.99999 minutes, we don't actually have 1.99 minutes. We have 1 minute and 59 seconds, right? Or whatever the remainder value is, which is what we'll calculate next. So we always round down. So next, we're going to have const seconds. Now, the number of seconds is simply equal to the second elapsed mod 60. Now, the modulus operator is the remainder operator. This is the percent sign. What this will do is give you the remainder after division by 60. So if we had something like 61 mod 60, it gives us 1. 62 mod 60 gives us 2. 59 mod 60 gives us 59 because you cannot divide 59 by 60 evenly, so you get 59 as the remainder, okay? So now we have the number of minutes and the number of seconds. What we need to do is format this into a nicely padded string that will appear here. So right now, naively, you might say, okay, well, Tim, I remember you showed me this backtick trick. If you look at the tilde on your keyboard, which is the squiggly line, it should be on the same key as that. Backticks kind of look like single quotation marks, but they aren't. They're typically in the top left-hand corner of your keyboard. What you can do is put a $sign and then 2 curly braces like this, or an open and closing one. And you can put minutes, colon, and then we can do the same thing here with seconds, okay? So we do minute, colon, seconds. And what this is gonna do now is take these numeric values and embed them inside of a string with a colon separating them when we call this setTime function. So now we're not quite done, but watch what happens. If I click start, you'll see we get 01, 02, 03. Again, still doesn't look great. We need that leading and trailing 0, which I'm gonna show you how to get, but this is a decent start. And now again, if we were to have this go up to 60, you'd see that it would start showing us the minutes. Now to prove that, let's just make this 61 and let's go with start. And then notice you get 1 minute, 3 seconds, 1 minute, 4 seconds, etc. Okay, let's make that back to 0. All right, now that we've got this, we've got to pad our values. So padding the values simply means, okay, well, we're going to look at the values, and if they're not 2 digits, then we're just going to add a leading 0, right? So if it's less than 9, pretty much, add a leading 0. We can do this in a function, so I didn't mean to do that, but I'm going to say function pad start. This takes in a value. And what we're going to do is actually return something from this function. This just means we get a value back when we call it. So we're going to say return. We're going to take our number because that's what's going to be passed inside of here. And we're going to convert this to a string. When we convert it to the string, that allows us to use this method called pad start. And for pad start, we specify how many characters we would like the string to be. In this case, I would like the string to be 2 characters. So I put 2. And then we put the character we would like to pad the string with. So now what happens is we take the numeric value, convert it to a string, and we pad it with a leading 0 if it is not 2 digits long. Hopefully that makes sense. So now for minutes and seconds, we can simply just call these with pad start, and that's going to return to us a string that has those padded zeros. So we're going to say pad start like that. So we're taking this as a value, passing this into the function. It's then returning to us a value that we will embed inside of here in the string. So if we go ahead and we can refresh this and we start, you'll see now that we get a stopwatch that's a little bit more familiar and what we're actually looking for. Now, the next thing we should look at this point is what happens when you press start multiple times, because you'll notice if I click it, it's just counting up really, really fast because it keeps making these new set intervals. Now, that's not what we want. What we would like to do instead is essentially clear the previous interval if we click start again, and we want to also reset the timer. So what we'll do is we'll say, okay, well, if we had this clock, right? So if we've already started it, so we're going to say if interval, then we're just going to reset the clock and we'll write the reset clock function. So sorry, let me just scroll down here. What I'm doing is I'm checking before I make this new interval. I say, okay, well, if the interval exists, reset the clock. Resetting the clock should reset everything for us. And then we will just redefine the interval here. Okay, that's pretty much all it's doing. Inside of the reset clock, what we're going to do is we're going to stop the clock. We're going to set the seconds elapsed equal to 0. And then we're going to set the time just so that it shows us 0, 0 again. And then inside of the stop clock, we're going to say clear interval, and we're going to clear this interval. Now I have some chaining of functions. That's actually intentional because I want to show that to you in this project. It's a bit of a learning thing, but you can see that what I'm doing again, if the interval, reset the clock. So now we go to this function. Inside of this function, when we reset the clock, the first thing we got to do is stop the clock. So when I click stop the clock, I clear the interval. Now when I clear the interval, all that does is just stop counting, okay? It doesn't change what's like being appeared here. It just stops making this go up by 1 every time. So that's what stopping does. Now, after I stop, I now reset the second elapsed to be 0. So that's resetting the clock value. And then I set the time. And the reason I set the time is so that we see that we've actually reset the clock back to 0, okay? Because if you don't call this, you're not going to see the update on the screen because that's what's updating the screen. So now if we just press stop clock, it doesn't actually show us anything different on the screen, right? It still stays at like 7 or 8 seconds or whatever's appearing. It just cleared the interval, which now means if we start the timer again, it doesn't reset, it just starts to count. So let's look at this. If I click start, it starts counting. If I click stop, it doesn't reset, just stops counting. I click start, then it starts counting from the beginning. Now actually that gives me reason to want to do something else. So let's remove inside of start clock if interval reset clock. And instead of that, for start, let's actually just clear the interval. So we can actually say, how do I want to do this here? Yeah, I'll say if interval stop clock, and then I'll just make the interval again. Now, I know this seems a little bit weird. I'm going to explain this, but this is actually something I just caught while I was doing it. So I'm starting, okay. I'm stopping, and when I start, it starts counting again. Okay, so the reason I did what I just did there is I don't want, when I click start, for it to reset and then start counting. I just want it to resume what it's at, and I only want the reset button to reset it back. So what I did instead is I said, okay, well, if an interval already exists, let's remove that interval. So we're saying clear interval, and then we'll just set it again. That way we never have like 2, 3, 4, 5 intervals going at the same time. We've just removed the previous one, and then we've reset it. So we've just kind of continued it on. That's what I'm doing when I'm start the clock. So whether I'm starting at 0 or whether I'm starting with an interval already, it doesn't matter, right? We just keep counting. So if you press start when it's already started, then it just keeps going. Now, when I click on stop, again, it's going to stop. If I click on start, it will start. I click reset, brings me back to 0. I can start and I can reset while I'm started. And you guys get the idea, okay? So let us now move on to project number 5. Now this is the most advanced project by far. I'd probably classify this more an intermediate project, but if you've made it through all the other ones, then this one is kind of a natural stepping stone. So I think you'll still be able to follow along with it quite fine. I just want to be clear that I'm going to go again even faster. So make sure you watch the other projects if you haven't, because anything I explained there, I'm not really going to recover here. So let's begin by making a folder for project 5. And inside of here, let's call this main.html, and let's make another file, and this will be index.javascript. So I've got 2 files, main.html, index.js. We're going to set up our HTML boilerplate at this point. I think you've heard me say this many times, so I don't need to repeat myself. Just get the HTML up and running. For the name, we are going to call this the to-do list. Remember, this is the persistent to-do list, which will remember the items that we had. We're going to stop the live server from our previous project, and we're going to restart it for this one, which will open a blank browser tab. Now, inside of our body, we're going to link our script. We'll just do this first, and we'll say source is equal to index.js to get that sorted out. We're going to have a h1 tag. This is going to be the to-do list. We're then going to have an h2 tag, And this is going to be the items list. So for the to-do list, we have two components. We have something that specifies all of the items in the list. And then we have kind of a place where we're able to actually add the item, right? So for our items, we're going to create a div. Div stands for division, and it's something where we can actually just place items inside of. So I can take all my items and kind of render them inside of this div. So we're going to say ID is items, so we're able to access that. And we're going to create a very basic input so that someone can add an item. So we're just going to say input like that. Remember, this is a self-enclosing tag. You don't need the separate closing tag. The ID is going to be the item input. The type is going to be the text, and the placeholder is going to be to add an item. Okay, save that. It should appear on the screen. Next, we're going to make a button, and the button is going to say add item. And then for the on click, we're going to call the function add item like that. Okay, that is all of our HTML. Zoom out so you can see all of it. Again, we have our header, we have the h2 tag for the items, we have the div. This is where we're actually going to render all of the dynamic items. So when we do something like hello and we click add item, it's going to appear inside of the items list. Okay, then we have the input so that we can add the item, and the button, obviously, which will take that and add it to the screen. So now let's go to our JavaScript and let's start. So let's start, first of all, understanding what it is that we need to do and then writing this out. This is going to be a little bit longer, so it's worth having a bit of a plan for what we want to do here. So what we need to understand, first of all, is that we want to store these items persistently. That means that we need to have the ability to, well, store them. We also need to have the ability to load them. Now, one thing to consider is that we're going to probably have an array of items, right? This is the order in which we have our individual items. We're going to have the ability to remove items, and we need to show the reflection of our items on the screen. So when we first load them all, we got to render them on the screen. It means we've got to actually put them there. And then when we remove them, we got to remove the correct item and then kind of re-render them onto the screen. So there's a few things we got to do, right? We got to save items, we got to load items, we got to render items, and we have to add and we have to remove items. So what we can do is start writing out some of the core function names so that we know those operations and we can tackle them one at a time. So we're going to say let items is equal to an empty array. We'll get into some other things in a second, but for now we understand that we're going to have items inside of an array. We now know we also need to load items, so we'll write a simple function so that we remember that that's something we need to do. We also know we need to render the items onto the screen, so we'll write a function for that. We know that we need to save the items, so let's do that. And we know we need to remove and add. So we're going to say function add item and function remove item. Okay, so that's kind of that. The first thing I think makes sense for us to do is to figure out how to display an item on the screen. Once we know how to display an item, then it's a little bit easier for us to understand loading, saving, adding, removing, etc. But we need to say, okay, well, let's say we had some items in here, right, that we wrote ourselves. How do we show them on the screen dynamically? Because we might have one item, we might have 5 items. We don't know. We're going to have to kind of loop over all of them and show them on the screen. So for render items, what we need to do, first of all, is understand where do we want to put the items? Well, I want to put them inside of this div. So I need to access that div. So we're going to say const items div is equal to document.get element by ID. And this is items. Now let's just take this and put this at the top of the screen. And let's start writing our render items function. So inside of render items, the first thing I'm going to do is I'm just going to clear this div to make sure that any other items that were in there I get rid of, because I'm just going to re-add them in. So kind of every time I'm rewriting all of the items, it's not the most optimal thing in the world, but it's totally fine for this example. So I'm going to say items div dot inner HTML is equal to null. And all that's doing is just removing everything that's inside of the items div. So now we've got a fresh slate and we can start adding our items. Now what I want to do is I want to loop through all of my items. So if I have one item, I want to add one item. If I have 10, I want to add 10, right? I want to loop over them. And I want to create what that item is going to look like and then put that inside of the div. So we start with a for loop. And a for loop is what you use when you know the number of times that you want to iterate. A while loop is what you use when you don't know the number of times you want to iterate. So in this case, we know the number of times it's equal to the number of items. So I'm going to say constant, and inside of square brackets, I'm going to say IDX, which stands for index and item of object dot entries. I'm going to explain this, don't worry. And then items, and I'm going to put a set of square brackets. Now what this does is it will take all of these items, it will essentially give us pairings. Now the pairings are going to look like this: 0, item 1, 1, item 2. What that means is that the index here is going to be equal to the index corresponding with the item, which will be stored in this item variable. So when you kind of do this object.entries here and you pass an array, it just allows you to loop through and to access both the index and the item at the same time, which is what we want. There's other ways to do this, but I wanted to show you this kind of neat syntax in case you haven't seen it. Now what I want to do here is, for now, we're just going to create some text, and this text will just be whatever the item actually is. And we'll just add that inside of the div. But later, we're actually going to add another div inside of the div that's going to contain the text content as well as a button. Okay, so let's look at how we do this. We're going to start by saying const text is equal to document.create element. Now we can create an element in JavaScript and then put that on the DOM. The DOM is essentially just the interface that you see over here. And by the way, oh yeah, the to-do list is already appearing. Okay, so that's good. So we're going to create this element P. Now we have this element though, that's like, it doesn't really have anything. It doesn't have any text, it doesn't have any styling. So what we're going to do is we're going to set the content. So we're going to say text.text content is equal to the item. Okay, so now we've created a paragraph tag. We've set the text content, and now what we want to do is add it into this div. So to do that, we say the items div dot append child, and then we just simply add the text. So what this does is it creates the text element, and then it just adds it inside of the div as a child, so we can keep adding different text elements. Now we'll use the other components of this later, but for now I just want you to see how this works. So I'm going to go hello world 1, 2, 3. I'm just going to call this function, and you'll see when I save that we get 2 items appearing inside of our div. Okay, so that's great. That's how we dynamically render items. Now the thing is, I want to actually render some more complex elements here because I want each item to have a button that says remove. So I need to kind of add inside of here not just the text, but also the button. In order for me to do that though, I need to have those inside of one element that I add to the div. So what I really want is something that looks like this, where I have a div that has a paragraph tag, and then I have a button like this, right, that says remove. So I need to create this programmatically and then add this whole thing, this whole div as a child inside of the items div. It also gives me some more flexibility with styling, which we'll see in a second. So we'll keep the text tag, but before we make the text tag, we have to make like a container that's going to be storing all of this stuff that we want to put on the screen. So I'm going to say const container is equal to document.create element, and we're going to create a div. Then we're going to say the container.style.margin bottom. This just means we're going to add a bit of space at the bottom, is going to be equal to 10 pixels as a string, just so that I separate these different containers a little bit. If you don't have this, you'll see they'll get really squished together. So we make our container, we make our text. Now we want to make our button. So we're going to say const button is equal to document.create element. We're going to create a button. And now for the button, we're going to say button.text content is equal to delete, okay? And now we want to set the on click for the button. Now the on click for the button is going to call this remove item function, which is going to remove the item from our list. However, in order to remove the item from the list, we need to know the position in the list where the item exists. So that's why we will have access to this index. So what we're going to do is for remove item, we're just going to specify that we want to take the index of the item that we want to remove. And that now means that when we want to call this function, we need to pass the index. So what I'm going to do is I'm going to say button.onClick is equal to, and then what I'm wanting to do here is I want to call the remove item function, and I want to pass the index of this specific element. It's very important that we have the index because we're dynamically rendering different elements. So for each one of these elements, we need to have something that identifies where it is on the screen, right? Or what position in the list it is, so we don't delete the wrong element. So that's why we're passing the index here to this function. The problem with this is when we see this line here, JavaScript will actually call this function for us. It's different than inside of here. So notice here when I have the onClick, I actually write the call, right, which is the parentheses. In this case, this only actually gets called when we click the button. Here, as soon as JavaScript encounters this statement, so even if the button has not been clicked, it calls this function which will automatically delete the item, which we don't want. So what we need to do instead is wrap this in a function that then calls this function. A little bit complicated, hence why I left this for the last project. We're going to use this arrow function notation. So what we do is we put a set of parentheses, we put this arrow, which is the equal sign and then the angle bracket, and then we call remove item. Now what this essentially is doing is wrapping the call to this function in another function. So it's a bit difficult for me to explain this entirely, but what we're essentially doing is we're saying, okay, we're gonna have a function that calls this function. So that means this whole thing here, right? When we call this, so if I were to do this, this is actually valid syntax, by the way, but if I did this, then it calls this function, which in turn calls this function. So the point of me doing that is that now when we have the onClick event, it calls this function, which then calls this function, so that we don't call this before we actually want to be calling it. I know it's a little bit confusing. I'm hoping it's clear. You guys can let me know in the comments if you have any questions about this kind of wrapper syntax, but this is a unique thing you should know about and that you're actually going to use quite a bit in JavaScript. Okay, so that removes the item for us. Now what we want to do is we want to take the button and take the text and we want to add that into the container, and then we add the container into the div. So we say container dot append child, and we're going to append the text, and then we're going to say container dot append child. Okay, and then we're going to append the button if I can type this correctly. And then rather than appending the text here, we're going to append the container into the div. So now let's refresh. And I guess we're getting some kind of error. Oh no, we just didn't call this function. So let's call render items. And you'll see now that we get our containers that contain the item and the button. Now when we press the button, it doesn't do anything, but that's fine. You get the idea. Okay, so that's render items. Now the thing is, we want this delete to be appearing to the right side or to the left side. We don't want it below. So in order to fix that, we're going to use a display property on our text. Now, you may not be aware of this, but every element in HTML is either a block or an inline element. A block element means that it will actually take up its own row inside of the document, and any element you put after it's going to be on the next row. So in this case, paragraph tags, p tags, are block elements, meaning that anything you render after them goes on the next line by default. Same with header tags, right? These are block elements, whereas something like an input tag or a div or a span, these are inline elements, okay? Which means anything you add just goes in the same row inline. Now we can actually change the display type of elements with their style property. So I can say text.style.display. And if I change this to inline, and we actually call render items, you'll see now that our delete goes after the text. Now it's not ideal because there's no spacing. I'll show you how we add that in a second, but you can see that I've changed it from inline, whereas before it was block. If we change it back to block, then we get what you saw before. So kind of an interesting thing you might not have known about. Now what we'll also just do here is we'll say text.style.margin right. And we'll just make this equal to 10 pixels. So we just add a bit of spacing between this and the button. We also, of course, could put the buttons on the left side if we want them to be lined up vertically. There's a bunch of things you could do here, but in this case, this is totally fine. Okay, so there you go. We have now everything we need to render our items. So now that we have the ability to render the items, we want to be able to add them and to delete them. Now, actually, let's start with delete because we already kind of have that hooked up. So to remove an item, all we have to do is remove it from the list or from the array, and then just re-render the items on the screen. So to do that, we say items.splice. Now splice will simply remove an element at a specific index. So what I can do is say splice idx and then 1. Now what this is saying is, okay, well, what element do you want to remove? I want to remove the element that exists at this particular index. And then 1 is saying, how many elements do you want to remove from this index? We just want to remove 1, okay? So you can see it says start and then the delete count. So we're deleting 1 element and we're doing it at this index. You could delete multiple if you want. So that's how you remove an item from the array. Now, what we're doing after this is updating the screen by rendering the items. So if we refresh this now and I click on delete, you can see we delete that item. Let's refresh, delete 1, 2, 3, we delete that item. Okay, so it deletes the correct item. Obviously this is not being persistently saved, but we're gonna get to that in a second. Okay, so we've now removed, now we want the ability to add. So let's get rid of the already existing items here. And for render items, we can now remove that and we can just do that when we add an item. So to add an item, we want to get whatever is inside of this input box and we just want to add it as an item. So we're again going to go to the top of our program. We're going to say const the input is equal to document.getElementById. This is going to be the input item input. What did I call this? Let's see, item input. Okay, so let's change this back to be item input. Okay, and now what we're gonna do for add item is we're gonna get the value of that. So we're gonna say const value is equal to the input dot value. What we're now gonna do is add that. So we're gonna say, first of all, if not value. So if you didn't give us any value, we're not gonna add an empty string to the list. So we'll just say alert. And then this is gonna say, you cannot add an empty item. And then we can just return. So when we return early from the function, we no longer will execute any lines beneath it. So this is called a naked return. Some people don't like it, but in JavaScript, it's fine. And this is essentially saying, okay, as soon as you hit this, just get out of the function. We don't need to give any value back, but we're just gonna exit the function as soon as this keyword is encountered. Then down here, we're gonna say items.push, and we're gonna push the value, which is whatever they typed into the input field. And we're going to re-render the items by calling the render items function. Then lastly, we're going to say the input.value is equal to an empty string so that we clear whatever they had typed. So let's go here and let's add item 1. And you can see it gets added. We can add item 2. And you can see that I can delete the items as I did before. If I refresh though, of course they go away. Okay, so now we need the ability to save the items and to load the items, and then we are pretty much done. So what we're gonna do here is use something known as local storage. So just to give you a bit of a primer on local storage, this is essentially storage inside of your browser. So it's stored on your computer, and a bunch of websites will use this to keep track of information that can make it more convenient for you as a user. Now you should never store any sensitive data in local storage because it can be accessed by pretty much anyone that's utilizing the computer. And there is ways that you can store data on the server side, but in our case, we're gonna be storing it on the client side, which is user facing, right? It's what you're using. So we're just gonna store all of the items that you had, and then we'll reload those every time you open up this website again, okay? Now, when we use local storage, we can't store anything. We can only store specific values. So we can store like strings, numbers, etc. In our case, we have a list or an array. So what we're gonna actually have to do is convert that into a string. And then once it's a string, we're able to store it. So we're just gonna go into save items, and I'm just gonna write this out and then I can kind of walk you through it. So what we're gonna do is say const string items is equal to JSON in all capitals dot stringify, and we're gonna stringify the items array. So it just means we're converting it to a string, okay? So we're just taking the list, converting it to a string. Now that it's a string, what we can do is we can store it in local storage. So we can say local storage, which is the built-in variable that you can write, dot set item. And we're gonna set an item, which is equal to a variable I'm gonna define here. So I'm gonna say const storage key is equal to, And then this is essentially what you're going to use to access the storage that you're using. So you can set as many keys as you want. You just make them unique. So I'm going to make a key called items. And I'm saying, okay, well, I'm going to set the key, which is the storage key. In this case, it's items. And I'm going to make it equal to the string items. Now, what this will also do is it will override any key that already existed. So if I already had something in local storage called items, I'm going to change what its value was to be this new value so that I'm always keeping the most up-to-date version of my items. Okay. Now, in terms of loading items, you kind of just do the same thing, but in reverse. So we're going to say const old items is equal to local storage. This time it's going to be .get item. And now what item are we getting? Well, we're getting whatever the item is associated with the storage key. However, this is a string. So what I need to do now is convert this into an array that I can then use in JavaScript. So I'm going to say, first of all, if we actually have anything, because it's possible that we don't have any items stored. So if I do have some items stored, which is what I'm checking here, then I'm going to say that my items, which is this variable right here, is equal to, and this is going to be JSON.parse, and then old items. Now what .parse is going to do is it's going to read through this and it's going to convert it to a JavaScript object. In this case, the JavaScript object is an array. It could be an object, it could be a different type, but it's just going to be an array. Okay, so it's going to give us an array that contains all of the different items from that string that we put in the storage. Then we're simply going to render the items. So what we want to do now is we just want to call load items as soon as the document has loaded, so that as soon as we kind of open up this website, we load the items, and then we'll call save items anytime we do something different to the item. So we can actually do that first. We'll go down here and we'll say save items. So we're going to save items after we add an item, and we're going to save items after we remove an item. So if we remove or add, the only two operations we can perform on the items, then we're just going to save it. Okay. Now though, we want to call load items. So we're going to say document.add event listener, and the listener is going to be the DOM content loaded. Okay. And then we're going to say load items. Now let me just explain what I did, because this might be a little bit confusing. So what we're doing here is we're adding an event listener to our HTML document, and we can listen for different types of events. In this case, the type of event we're listening for is the DOM content loaded, which means it's actually loaded all of the HTML onto the screen. As soon as it does that, we're going to call the load items function. So again, we don't actually call it, we just put the name of the function, and then this will automatically call it for us. Now you'll see that I have two items popping up because I already had them stored in local storage for this exact project, but we can delete them. And when I delete them now and I refresh, like, it'll be persistent. Okay. So that's it. This is the finished project, and I just want to show you it works. So we'll say hello world, we'll add that. Before, if we were to refresh, it would have gone away because it wasn't being persisted, but now it's being persisted, right? So if I refresh, it's still there. If I delete it and now I refresh, we get the updated version. So I just wanted to quickly show you how to use local storage. There's a lot more you can learn about it, but the basics is you can assign a string key to some kind of value. In this case, we're using a string, and that's how we can store our different items, and we can retrieve them whenever we rerun this code. Now, the first step here is going to be to set up our environment to write JavaScript code. Now, if you've already done this and you have an editor and you know how to run and execute your code, then skip forward to the timestamp I'll put on screen, or if it's not there, you can go down in the video player and you'll see where all of the different projects start. This section is for people that are really complete beginners that have never done this before and need to set up their computer. So in order to write JavaScript code, the first thing we need is a code editor. Now we're going to be using VS Code or Visual Studio Code. It goes by both names, and we're just going to download that. Now it's completely free, and you can do that by simply clicking the link in the description or going to code.visualstudio.com. You can see I'm on the page here. From here, you're just going to download it for the appropriate operating system and then run through the installer. Usually that will be in your downloads folder. Next, we're going to go and download Node.js. Now, there's multiple ways to run JavaScript code, but for this tutorial, I'm going to show you how to do this just plainly in your terminal. So you don't need to know HTML, you don't need to deal with CSS, and you can just very simply run your JavaScript code from the terminal. So to do that, we need Node.js. So again, go to this website and just download the latest version of Node.js. Again, run through that installer, and if in the installation process it asks you if you want to add this to the path, then go ahead and press yes. So again, if it asks you to add to path, then press yes. Okay, that's it. Visual Studio Code and Node.js. The next step is going to be to open VS Code. So you can do that from the Spotlight search up here, just typing VS Code or Visual Studio Code. Then on Windows, you could do that from like the Windows search bar. Okay, so let's open up VS Code. Let me zoom in a little bit so you guys can actually see this. And your window might look a little bit different than this, but what we want to do is we want to open up a folder. So you can actually close this welcome tab if you see that. And this is now the code editor where we're going to write and execute our code. So just like we would write something in Microsoft Word if we were writing an essay, for code, we're going to do that in VS Code. Okay, so we need to open up a folder. Now there's many ways to do this. The first is to click on these documents up on the top left-hand corner, which is your Explorer. When you do that, you should see something that says open folder. If you don't see that, you can go up to the top bar here. It might be hidden for you, and then file, open folder. Okay, so we're gonna go to open folder, and this is the first step I usually do whenever I'm working on a project. So I'm gonna go new folder, and I'm gonna make a new folder called JavaScript tutorial. Now you can name this whatever you want, but just make a new folder and press on create, and then go ahead and click on open. So at this point, you're probably going to see something that looks similar to this. Again, it might be a little bit different because I have some extensions and stuff in VS Code. We're going to click on the X here from the welcome, and we're going to press on this new file button. So now that we've opened the folder, you can kind of see the name of the folders right here. We can make a new file by pressing on this button, or we can go to file and then new file. So we're going to make a new file here, and we're just going to call this tutorial and then .js. Okay, so you can name this anything that you want, but I recommend that you don't include any spaces in the name and make sure that it ends in .js. .js stands for JavaScript, and you'll notice we're getting the little JavaScript logo popping up here, indicating that we are writing in JavaScript. Okay, so we're going to go ahead and press enter and make that new file. To open the file, you can just double press on it here, but it should open by default. If you close the file, you can open it again by just clicking on it. Okay, so here is where we're going to write our JavaScript code. Now we're going to write a really simple kind of a test line of code per se, just to see if we can execute this before we move on to the next step. So we're going to write the following: console.log, and then just hello or hello world. This is usually the first thing you write whenever you're learning a new programming language, and it's just kind of a test like output so you can make sure that your code is actually working. Okay, so we're going to do console.log hello world, and notice that I get this little white dot appearing near my file name. Now what that actually tells me is I haven't yet saved the file. So what we need to do if we want to run the code is we need to save it. So anytime you make a change, you need to save the file, and then when you execute it, the new change will kind of be applied. So if you're wondering like, why am I writing stuff and nothing's happening? It's probably because you forgot to save the file. It's the most common error that almost every beginner runs into. Now there's a lot of ways to save the file. You can go up here to the file menu and press on save, or you can hit Control S or Command S on your keyboard, which is what you'll see me doing all the time. So Control S or Command S depending on your operating system. Okay, so now we've saved the file. We don't see that little white dot. And what we're going to do is open up the terminal. Now, if you just put your mouse down to the bottom of the screen here, you'll see that you get a little up arrow, and you can drag a terminal like this. Now, another way to open that is to use Command and then the back tick, but you probably don't know where that is, so you can just open it like this, okay? So you're going to open up the terminal. Now, from here, this is where we can execute our JavaScript code. So in order to do that, we're going to type node and then the name of our file. Now, the name of our file should be this, right? So we're going to say tutorial.js, and we're going to try to execute the code. Okay, now when I do that, notice that we get the output hello world. Now, obviously change this file to be whatever you named your file. Make sure that this looks exactly as you see it here and that you're typing it like this. If you're getting some weird errors, you can destroy the terminal by hitting on the trash and then just drag this up again, and it will give you a new terminal instance. Okay. Hopefully that's clear. I know I'm going really slow, but a lot of people have issues with this, and I want to make sure that this is covered for everyone and you know how to execute the code. Just for reference, if I were to make a file like 1.js and I wanted to execute that, I would now need to change this to say node and then 1.js. Now notice when I execute this, nothing happens though, because I haven't done anything in my file, so it's executing it, but we just don't see any output, okay? If you want to delete a file, you can click on it and press on delete. Okay, so that's pretty much it in terms of running your code. Now that we've done that, we're going to move on to project number 1, which is our choose your own adventure game. All right, so we're diving into the first project here, which is a choose your own adventure game. Now, a choose your own adventure game allows the users to kind of direct themselves through kind of a maze or a puzzle. And you might have seen this before if you've read certain books where it's like, if you want to go left, turn to page 73. And then it says, if you decide to swim across the river, turn to page 35. And there's just all these different decisions and kind of like a branching route or path that you can go down. That's what we're going to build here. So the idea is you might start by saying, hey, do you want to choose a sword or an axe? Do you want to go left or right? Do you want to cross the bridge? Do you want to go across the water? And there's one path that's correct and will lead you to kind of win the game. And the rest of them will eventually terminate because you chose the wrong option. Okay, so let's build that. However, there is a few things we need to learn kind of to start, because if you don't know anything about coding or JavaScript, well, there's a bit of a foundation we need before we can build that project. Okay, so whenever we write code, you saw that we have the ability to actually output something to the terminal. Now that's what this is right here, console.log. In other languages, in Python, for example, it's print. In some languages, it's system.out, but in JavaScript, it's console.log. So whenever you want something to go to the terminal, you actually want to see some results or some output, you use console.log, and then you put these two sets of parentheses. And inside of these sets of parentheses, you put a double quotation mark, so a set of them, so an opening one and a closing one, and then anything that you want to type out. Now you already saw this, but I'm just going through it slowly because it's really important. Now notice that we can't have like extra spaces here. I can't have, missing the period. Like if you do anything wrong at all, even having like a capital here for log, you're gonna get an error in your code. So you wanna make sure that you do everything exactly as I show you in this video, because especially when we're coding, all of the characters are very particular. And I know it seems silly, especially if you come from something like Microsoft Word or when you're writing an essay where you can have different capitalization, etc. Here, it's really, really specific. Now, just to show you what happens, let's say I do something like console dot and then I accidentally put 2 L's. So I make a mistake. Then I save my code and I decide to run it. So again, I can bring up my terminal and I can type node and then tutorial.js. You're going to see that I get this kind of error message. It says console.lllog is not a function. Now you might not know exactly what these mean, but always try to kind of read through the result that you're seeing here. All of this is gibberish, but mostly like the main line underneath here that's in white, because it can sometimes give you a hint to what you've done wrong. So if you're getting an issue, kind of check through this response here, and you'll see that it actually tells me JS line 1, so the colon, and then the number here is what line this issue occurred on. So that kind of helps you. Line 1, and then you can see that I have 2 L's. So it's kind of pointing to the mistake, and then you should be able to figure out, oh, I put 2 L's, I just need 1. So let's fix that, and then let's run it again, and there we go, we get hello world. Okay, I'm just going slowly here, just trying to help you get through this, because if you're a beginner, there's a lot of errors you potentially will run into, and that's totally fine. That's going to happen even for me. I just want to help you be able to solve them. Okay, so that's logging something to the terminal. Now, the next thing we need to cover is something known as data types. Now, whenever we write code, we're dealing with different pieces of data. And that data has classifications or types. And there's a few important ones you need to understand in JavaScript. So the first type that we have is a string. And that's anything surrounded in double or single quotation marks. So something like hello or hello. All of these are strings, okay? And a string, again, is anything in double or single quotation marks. There's a few more advanced types as well, but these are the ones you need to be aware of. And you can type literally anything you want inside of these quotation marks. So whenever you see a set of double or single quotes, that means you're working with a string, which again is just a set of a bunch of different characters. And that's what we use here when we want to log something, we put a string. Even the number like 1 here, this is a string because it's surrounded by quotation marks. Now, the next type that we have in JavaScript is the number type. Now, the number type is anything that is a number. So something like 23. Notice it's highlighting in purple. That's a number. Something like 23.5, 23.58, something like -9, 0, 0 point, a bunch of different values. All of these are numbers, okay? So that's another important type to understand. The next type we have is Boolean. Now, Boolean is simply true or false. That's it. And notice that it's typed exactly like this. Okay, so with a lowercase t and a lowercase f, this is true or false, or the Boolean values. If you're familiar with computers and binary, true would be 1 and false would be 0. If that means nothing to you, ignore that I said that. Okay, and there's a few other types we want to be aware of. Another type that we have is undefined. Again, notice it kind of highlights in a certain color here because this is a reserved keyword in JavaScript, which means it's like a type, okay? So we have undefined. This is a type of itself, and it means when something is undefined, when we don't yet know what it is. And then we have null. Now, null is a different type, and this is used when you explicitly want to set something to be kind of empty or non-existent. So undefined means we don't know what it is, doesn't exist, and null is indicating, hey, this thing is empty, it's, non-existent. We are just explicitly, like, we're making sure that it's known that we're setting this to nothing. I know it seems a little bit weird, but those are types that you might see, so you just want to be aware of them. Now, we also have another type, which is known as an object. We can look at that later, but yeah, just something to be aware of. Okay, so main types for now, just a quick recap. We have strings, anything in single or double quotes. Then we have our numbers, so anything like this is a number. Then we have our Booleans, which are true or false. Then we have our, what was next, our undefined type. So undefined is just simply undefined itself, like the type of undefined is undefined. I know that's a bit confusing, but that's what it is. And then null, same thing, like the type of null is null. So just that one keyword. Okay, so now that we've looked at our data types, let's look at how we store this data and how we interact with it in our program. So just like in math class, when we program, we have variables. And variables, you can really just think of them like buckets that store some value. So in order to make a variable in JavaScript, we have 3 different options. The first and most flexible option is to use the var keyword. So what I can do is say var, and then I can give my variable a name. So just something like maybe variable, or x, or Tim, or name, or whatever you want to call it. But usually it's a good idea to name your variable something that kind of makes sense with what it's storing. So let's go with var name. Now what we can do is put an equal sign here, and then we can assign a value to this variable. That just means that we'll give this variable something to hold or to store. So I'm going to say var name is equal to Tim. Now when I do this, all I'm saying is I'm making a new variable indicated by this var keyword. The name of the variable is name, so maybe let's just change this to x so it's a bit more clear. So the name of this variable is x. We're using an equal sign which says, hey, we're going to assign something to this, and then we indicate Tim here, which is saying, hey, the variable x is going to be equal to Tim. Now what that also means is that this variable here, we can say that it's of type string. So notice when I hover over it, it's kind of giving me this little line here, and it's indicating that x is holding a string, and that's because the type that's inside of it, the data that we're storing, well, its data type is a string. Okay, so that's the first way that we declare a variable, and if we wanted to access the variable and use it, we could write something like console.log, and then we can just put x here. Now, when I use x, I'm referencing this variable that I just created. And since this variable stores Tim, if we run our code, we'll see that this will print out Tim. Okay, so that is the first little thing that we can understand. We have var x equals Tim. This is how we create a variable. And by the way, now that I've defined this variable, it's been created. If I want to change it later on, I don't need to use the var keyword again. I can just say x is equal to, and then I can go with something like John. And if we run this now, you'll see that now the variable has been changed to John. Okay, so this here is known as our initialization. We've initialized the variable, we've given it a value, in this case it's Tim. Now that this variable exists, if we want to change it, we can just do something like x equals John, and if we want to use it or access it, we can just refer to it by its name. Now if I tried to access a variable like y, which doesn't yet exist because we haven't created this, if I go here and I print out, you'll see that we get an issue. It says reference error, y is not defined. Now it's saying that because there's no variable with the name y. Okay, just wanted to quickly show that to you because that's something that you might get. Okay, so that's variables. There's a few more things to go over there. Now, when you name a variable, there's a few rules. For example, it's not okay to have something like a space. So if I have name space 2, or let's just go with 2 like this, you'll notice that it's giving us an error with this kind of red underline. The reason for that is you can't use a space in a variable name. If you wanted to have a variable that was multiple words, you would need to use an underscore. Okay, so an underscore is a valid character, and you're also allowed to use numbers in your variable name. So if I wanted to, I could do name underscore 2, or I could do name 2 like that. But really, when we write code in JavaScript, the way that we typically separate multiple words is using something known as camel case. So if I wanted it to be name 2, I would do name, and then I put a capital for this, so name 2 like this. Just kind of a common convention. Doesn't really matter if you use an underscore or not, but a lot of people in JavaScript, you'll notice they kind of write their variables like this. Now, a few more rules. You can't have all these special characters. If you try to add, parentheses or ampersands or $signs and stuff, that's not going to work. And you also can't start the variable with a number. So if I do something like to name, that's going to be an issue. We can use a number, but it just can't be the first character. Okay, so keep that in mind with your variable names. Now, another thing that's important is that our variable names are case sensitive. That means that the variable name2 is different than the variable name2. Okay, so make sure you're checking your capitalization because it is case sensitive and you need to make sure you have the same capitalization when you're using variables. Okay, so that is the first way to make a variable. Now, really what's typically preferred in JavaScript is actually rather than using the var keyword to use the let keyword. Now, when you use the let keyword, you're doing the exact same thing that you just did with var, except you're indicating that this variable here can be changed later on in the program. Now, I don't really want to explain the difference between var and let because that's a bit more advanced than we need to get into in this video, but just know that there is this let keyword. This is the way we'll typically define variables. And when we let something be equal to some value, we're indicating that it can change later on. Okay, now there's another one that we can use here, and this is known as const. Now, const here stands for constant. And when we define a variable using constant, by the way, all three things you just saw here, they're all variables, just different types of variables. That means that we can't change this variable later on. So if I try to do something like name2 is equal to 5, I try to change its value, and I go up here and I run the code, you see that we get an error and it says assignment to a constant variable because we can't change that. That's what const means. So whenever you're defining something that's not going to change, which can happen quite a bit, you use const or constant. And if you're defining something that will change later on, you can use let. Okay, there's a lot more things with variables, but that is really all you need to know in order for us to get started with the project here. Okay, so now that we understand variables, we understand data types, it's time to talk about collecting user input. So sure, it's great to be able to print things out like, hi, how are you, whatever, hello world, but oftentimes we want to respond to what the user's saying. Now, unfortunately, in JavaScript, it's a little bit tricky to grab user input, but I'm going to show you kind of a trick that can allow us to get it a bit easier. So what we're going to do is open up our terminal here, and we're going to write the following command. So bear with me here. So the command we're going to type here is npm install and then prompt-sync, okay? Now this will install the code that we need in order to collect user input. Just bear with me, I understand it's a bit confusing, but this is what we need to do. Okay, so that's going to install the package for us. By the way, if you want to get rid of whatever's in the terminal, you can type clear, or if you're on Windows, you can type CLS, and that'll get rid of all that. So I'm going to remove that from now and just make that a bit smaller. And now we're going to start using this. Now to use this, I'm going to say const prompt is equal to require, and then prompt-sync, and then we're going to put another set of parentheses. Now I know I'm going fast, but you can pause the video if you want to type it all out. I'm also going to explain what this is doing. So we're saying const, which means constant, right? So we're defining a variable called prompt. Now prompt is going to be equal to require prompt sync, and then we have to call this. I know it seems weird, but this is just how you bring in this code, okay? So this is code someone else has written that's going to allow us to really easily collect input from the user. Now we want to test this out to make sure it's working. So we can type prompt, a set of parentheses, and then we can type a question that we want to ask the user. So something like, what is your name, question mark. Okay, then I'm going to do a space. Now, what I'm able to do now is I'm able to have this printed to the terminal, so down here, and then afterwards, so after this string here, it's going to allow the user to start typing. Now, that's why I've put this space here, so that there's what they type is not going to be kind of squished in with this, and prompt itself is just the name of the variable that we define. So if we called this something like, HE, then we would have to change this to HE. Okay, so that's how we're using this. Hopefully that's makes sense a bit or isn't too confusing. I hate how it's so complicated in Node.js and Python to collect user input, but it's just how it is. Okay, so now what I'm going to do is run the code to test this. We're going to do node tutorial.js. Now notice it says, what's your name? And it hasn't finished the program yet. We actually get our cursor here. And now that I can start typing, so I'm going to type Tim and then hit enter. Okay, perfect. So prompt is working. Now, obviously that's great, but we probably want to be able to store what the user types so that we can maybe print it out or we can use it in some meaningful way. So let's do that. We're going to say const name is equal to, and then this right here. Now, what's going to happen now is whatever the user types in is going to get stored in this variable name. So I'm going to save that, and then we're able to use the variable. So if I wanted to, I could say console.log and then name. Okay, so now I'm going to run my code. So let's clear and run. And we're going to go with Tim, and it says Tim. Okay, so now we've collected what they typed, and now we're printing it out. Perfect. Now, the next step after this is we probably want to say something like, hello, whatever their name is. Like give them some kind of greeting that's customized with what they typed in. So let me show you how that works. What I can do here is I can put something like hello, and then I can put a comma, and then I can put the name, and I can say, how are you, ? Now, what I'm able to do is I'm able to print multiple messages or multiple strings. So I can say console.log, and then I'm going to print out hello. Then I've put a comma, and then I put the next thing I want to print, which is Tim, or whatever the name is that the user types in. Then I put another comma, and then I put how are you. Now, it's going to print all of these things that I've separated with commas, and it's going to separate them with a space. So if I run this now and we type in, let's go with something different like Joey, it says, hello, Joey, how are you? Okay, so you can print multiple things using the comma to separate them inside of a console.log. Now, another option is we can actually what's known as concatenate these strings together. So let's say maybe we didn't want to have the space. I can use a plus sign instead. And when we use the plus sign with different strings, because remember, this is a string, the name, whatever the user typed in, is going to be a string. And then this is a string. We just squish the strings together. So if I run this and I go Tim, it says, hello, Tim, how are you? And actually, you know what? This is a good learning moment. Notice that we're getting the same result as before, and it's not squishing the values together. The reason for that is I see this white dot here, and I forgot to save my file before I ran it. So let me save this and run it again. And now you'll see if I type in Tim, we get the results squished together. So if you're ever you're not getting, whatever change you made, just check if you saved the file or not. Even me, all the time, I forget to do that. Okay, so now we're able to greet the user. So let's just change this back. So we're using the commas, so there's a bit of space. And the next thing we want to do is we want to start working on our game. So we're going to say, hello, how are you? And maybe rather than how are you, you can say something like, do you want to play? Or maybe actually, let's welcome them to the game. Hello, Tim. Welcome to our game. Okay. So now that we've done that, let's ask them another question. So I'm going to say, const should we play is equal to prompt. And then we're going to ask the user if they want to play. So we're going to say, do you want to play? ? Okay, so now I'm going to ask them, and I'm going to put a space here so they can type something. And what we'll do after this is we'll check if they typed yes or no. And if they typed yes, then we'll start the game. If they type no, then we will obviously not start the game. Now, I know I'm going really slow, guys, but I'm just trying to make this really accessible for everyone. So if it's too slow for you, feel free to fast forward in the video or to increase the playback speed. And don't worry, for the future projects, it will be a lot faster. And all the stuff we already covered, I'm just going to quickly go over. Okay. So now we're asking them if we should play. So what I'm going to do now is I'm going to run the code and test this out. Okay, so let's run this, and we're going to type in Tim, and we get, what is your name? Hello, Tim. Welcome to our game. Do you want to play? And then we can type something like yes. Okay, so that's great, but obviously now we need to check what they typed in. And if they type yes, we need to start playing. Otherwise, we need to, stop playing or tell them, too bad, you missed out on the opportunity. So to do that, we're now gonna learn about conditions. Now, whenever we're working with code, we have ways that we can compare different values together. Now, in this case, we wanna check if what the user typed in is equal to, in this case, yes, but we could check anything that we want. And we do that using some comparison operators. Now in JavaScript, we have the following operators. We have double equal sign, a triple equal sign, a not equal to, a not, and then double equal sign. We have a less than, a greater than, a less than or equal to, and a greater than or equal to. There's a few other ones that are kind of, less used, but these are the common ones. Now you'll notice we're getting kind of all of these red lines. So what I'm going to do now is introduce a comment. Now, a comment is simply a way that we can write something in our code that the execution will ignore. So right now, if I were to try to run the code, we'd get an error because I have all of these symbols that just don't make sense to kind of what's known as the compiler or the interpreter. We don't need to get into that, but that's what's running the code. But if I want it to ignore that, I can simply do a double slash. Now, when I do a double slash, it's going to make this line gray or comment out the line. And that means that now when we run the code, whatever's on this line will be ignored. So I could just do this on all of these lines, right? So that I have this comment and now the red line goes away and we're going to ignore these lines. Or I can do what's known as a multi-line comment. Now, a multi-line comment is a slash, an asterisk, and then you can end this with an asterisk and a slash. Now, when we do this, we can comment out multiple lines at once. So this whole part right here now is a comment which will be ignored when we run our code. Anyways, that's a comment. Okay, so let's go through these different operators and I'll show you quickly how they work. Now, the double equal sign is what's known as a loose comparison. And this means we're going to check two values and see if they're equal to the same thing, but we're not going to look at their type. So it's a little bit weird, but that means that we could do something like 7 is equal to 7. And now we're going to actually just check if these things kind of equate to the same value, but we're not going to be concerned with if their types are different. So in this case, the string 7 is different than the number 7, but since if we were to convert this here to this type, they're both the same, that means that this is actually going to return to us the value true. So whenever we use these different operators here, the result of an expression, so if we write something like this, is either going to be true or false. It's going to be Boolean, okay? Now this is referred to as a condition. So when we use an operator, so a conditional operator, and we use an operand, that's what these are called here, a left and right operand, this is going to give us a result or evaluate to true or false. Okay, so the double equal sign is a loose comparison, and I recommend that you don't use this because it can give you some weird results that you're not expecting. Now, I don't want to get into it too much, but again, remember, this will actually not really concern itself with the types and just check if these things are equal to each other without looking at the type. Okay, that's not a completely accurate explanation, but for you right now, that's what you need to know. You can look into it more if you continue learning JavaScript. Now, the next is the triple equal sign. This is the strict equality operator, and this will make sure that two things are exactly the same and the type does matter. So if I do something like Tim, or actually let's go back to the other example, something like 1 is equal to 1, whereas if we use two equal signs, this would be true. When we do this, we're going to get the result false. And that's because, yes, these are the same, but they are different types, so they're not the exact same, so we get false because this is a strict equality operator. There's some more examples I could go through here, but pretty much always use the triple equal sign unless you have a really good reason to use the double equal sign. Now, the not equal to works the same way, but in reverse. So if we do exclamation point and then equals to, this is the loose not equal to. Now, this checks if two things are not the same, and if they are not the same, it returns true. If they are the same, it returns false. Now, in this case, this will actually give us false. The reason for that is that these two things, if we checked them with the double equal sign, would be true. They would be the same. So when we do not equal to, it gives us false because it's the reverse of that. Whereas if we did not equal equal, then this would be true because these things are not the exact same when we consider their types, because one is a string and one is a number. Okay, so that's those 4 operators covered. We then have the less than sign. Now you can actually use this with mismatched types. So we have like a string versus a number, but it's a bit confusing, so we don't need to look at that. But it pretty much just tells you if something is less than the other thing. So in this case, this would give you false because 4 is not less than 1. Whereas if we swap this to greater than, well, 4 is greater than 1, so we would get true. Then we have greater than or equal to. So if we did, 4 greater than or equal to 4, that would be true. If it was strictly greater than, this would be false because they're the same, okay? Then we have the less than or equal to. If I go 4 less than or equal to 5, of course, that would be true. If we change this to 6, then that would be false, okay? So those are our comparison operators. Now let's see how we can use those to see if we should play the game. So first, let's do the following. We're going to say const condition is equal to, and then I'm going to go with should we play is equal to, notice I'm using 3 equal signs, and then I'm going to say yes. Then I'm going to console.log the condition. Okay, now when I save my code and run, what's going to happen is we're going to print out true if we should play the game, and we're going to print out false if we should not. And we're going to do that by looking at what the user typed in, and we're going to take whatever they typed in, and we're going to compare that to the string yes. Now, if it's the exact same, then this will be true and we'll play. If it's anything different, it's going to be false. So let's go here and run our code. We're going to say, what is your name? Tim. Do you want to play? Yes, and we get true. Run this again. What is your name? Tim. Do you want to play? No, and we get false. And just for one more example, Tim, and if I type something like yes with a capital Y, it actually says false. And the reason for that is capitalization matters. So a yes with a lowercase y and a yes with an uppercase Y are different, so it gives us false. Now, if we wanted to avoid that, what we can actually do is we can take whatever the user typed in and we can convert this to a lowercase string. So I can say dot to and then lowercase and then put a set of parentheses. What this is known as is a method. You don't need to worry too much about the exact kind of naming here, but what that's going to do is it's going to act on this string and it's going to kind of turn this string into a lowercase version and put that right here. So it won't actually change the string itself, but it will get whatever the lowercase version of that string is and kind of put that in place of the line you see right here. So if we type in something with uppercases, it will just convert them all to lowercases and then compare that to yes. So that way, if they type something that's yes, but with different capitalization, it will still work. So if I do this and I type Tim and then I type like Y-E-S, it says false, and that's because I forgot to save. So if I fix this and run it again and we go Tim and we go Y-E-S like that, it still says true. Okay, so sorry about that before, I just forgot to save, but you can see now it is working when we convert this to lowercase. Okay, so all of that is great, but now what we want to do is we want to say something to the user if they want to play the game. So how are we going to do that? Well, I've kind of hinted at it the way that I said that, but we're going to use something known as an if statement. Now, an if statement allows us to check if something is true. So that's where the conditions come in. So the syntax for an if statement, which is the way in which we write it, is the following. We write if, we write a set of parentheses, and we write a set of curly braces. Now, the parentheses here is where we put something that is true or false. So in this case, if I put my condition, this is going to be equal to true or false. So if this is true, we're going to do whatever's inside of these curly braces. So if I do something like console.log, okay, we will play, then what's going to happen is only if this condition evaluates to true will we print this out. Otherwise, we just won't print anything. So let's look at this now. We're going to go clear and run. We're going to go Tim and then yes. And notice it says, okay, we will play. If we run again, Tim and no, it doesn't say anything because this did not run. Okay, so that's it. That's the if statement. It's pretty straightforward. We say, if this thing is true, do whatever is inside of here. Now, there's one line here, but we could put multiple lines, and we will in fact do that in a minute. Now, one thing to note is that we don't need to kind of write it how we've written it like this. I can take this line and I could paste that here and remove this. And this is perfectly valid. As long as whatever you have inside of here ends up being true or false, then it's going to allow us to kind of get inside of the if statement. Okay, so let's run it one more time and go Tim and then yes, and notice it still works, okay? So you can do it in a variable or you can do it like this, how I've just done it. Now that's great, but we probably want to say something to the user if they don't want to play. So if they don't want to play, I'm going to put an else statement here. And an else statement is something that only comes after an if statement or as a part of kind of an if statement block. I can't just go down here and write an else statement. It needs to be associated with an if. Now the else is just the other side of the if. So if this thing is true, do this. Otherwise, or else, do this. It's pretty easy, but if I just go here and go console.log and then, okay, sad face. Now, if they don't type yes, then we're going to print this out. So if this is not true, go in here and do that. That's all that is. So let's look at this now. We're going to go Tim and then no. And it says, okay, sad face. Whereas if I type Tim and then yes, it says, okay, we will play. Okay, so that's the else. Now this is the basics on the if else statement, but there's one more thing we need to look at, which is the else if. Okay. Now the else if works the exact same way as an if, but we only check it if this is not true. So it's kind of like a chain. We say, if this thing is true, do this, and then skip the rest. Otherwise, check this thing. Otherwise, do this, okay? Now we can actually have multiple else ifs, but let's just look at an example of this. So let's say we have, should we play? Let's just copy this and put this here. And let's say that it's equal to no. Maybe we'll take the okay here and we'll put that inside of here. And then we'll change this to say invalid input, ... Okay, so we have console.log, okay, we'll play, okay, sad face, and invalid input. Now, the way this is going to work, is we're going to ask the user if they want to play. If they type in yes, we're going to execute this, and we're going to skip the rest of this. If they type in no, which I'm checking here, so if they didn't type in yes, we're going to check if this is the case. If they type in no, we're going to print this out, and we're going to skip this. Otherwise, so if none of this is true, we're going to print invalid input. I know I explained that a little bit weird. Also, it doesn't matter if you have a space or if you put this on the same line. It's valid either way. But let's run it and just test this out. Okay, so node, Tim, let's type in no, and notice we get okay. Let's type in maybe invalid or something like that, and it says invalid input. Okay, so again, if this thing is true, skip the rest of this. If it's not, check this next if statement. If that's not true, do this. And if we wanted to, we could have another else if. We can have as many else ifs as we want, but they just have to come after an if statement, okay? So in order to use the else if or the else, you need to start the block with an if statement. Now, as soon as we see the else, that kind of terminates this if statement block, which means I can't come here and do like else if now. That's invalid because the else was already placed. It always goes at the end of the statement, okay? Last thing, if I want to do another if statement, that's fine. I can do that down here and start a different block. Okay, so that's it. This is our if, and else. And now we actually want to start the game. We know enough to build this out now. So as a reminder, the way this game works is we're going to ask users questions, and based on the answer to their question, we're going to move down a different path, and eventually the user will either reach the end of the game or they'll reach a path where they're not able to complete the game or they lose. So this is the first thing we ask them, right? Do you want to play? Okay, yes, they want to play. Now, if they say yes, what we're going to do is remove this. And inside of this if statement is where we're going to write the logic for the game. So I'm going to say game logic here. Okay, because only if they typed yes are we going to execute kind of like the game code. Otherwise, we're going to handle this. Okay, so we're going to go inside of the game logic. And the first thing we're going to do is kind of think of what we want to ask the user to start. Now, I like a simple question like, do you want to go left or do you want to go right? And you can be as creative as you want with this, which is why I love this game. But I'm going to make it basic so you guys can extend it and make it really cool. So what we're going to do is the following. We're going to say const, and we're going to say left or right is equal to prompt. I'm going to say you enter a maze. Do you want to go left or right? Question mark. Okay, now let's make this a little bit smaller so you guys can read this. So now inside of here, I need to check what they typed in. So I'm going to say if left or right is equal to left, then I'm going to do something here. Otherwise, so if they didn't type left, I'm going to do something here. So you can see that we're going to kind of branch in here with multiple if statements. So I'm saying if left or right is equal to left, then maybe this was the right decision. So if it's the right decision, we can do something like console.log, you go left and see a bridge, ... Okay, and then we can ask them another question. So I could say const something like cross is equal to prompt, and I'm going to say, do you want to cross the bridge, ? And then same thing, I'm going to say if cross is equal to yes, do this, if not, equal this. We'll keep going in a sec. I just want to slow down a little bit because I know I'm going a little bit fast. So again, if they want to play, we're going to ask them another question. Then for this question, well, we need to check what they answered. So if they said left, then this is like the correct choice. So we're saying, okay, you go left and you see a bridge. Otherwise, we're going to say console.log. We're going to say you go right and fall off a cliff. Okay, so a little bit aggressive, but you can see we're saying, okay, well, if you go left, well, you lose the game. That's the wrong decision. So you don't want to do that. So then they'd have to run the game again and try to go down the correct path. So here now, if they go left, we're going to continue going because this is the correct decision. So we're going to say if cross is equal to, and again, you guys can make this whatever you want. I'm just showing you the layout of the game, is equal to yes. Then we can do something like console.log. And we're going to say you cross, but the bridge was weak and broke and you fell. My great English there. And we'll say you lost ... Okay. Otherwise, so if they don't want to cross, so if they type anything else pretty much, then we could continue the game. Or we could say something like console.log, good choice, ... you win. Let me just make this a bit larger so you can see. Now, obviously, you want to keep going and make this more creative. And you don't have to allow people to, die or lose at every avenue. If you wanted to, you could have both paths be valid paths. You also could get even more creative here and you could have multiple options. So maybe you enter the maze. Do you want to go left, right, or straight? And then rather than left or right here, you would just have another else. So you do like this, else if. And then here you'd say else if left or right is equal to straight, then you would do something else here. So you can have multiple different options, right? So look at this code, kind of study it a little bit. I know it's a bit difficult to read, but the point is we have these branching paths and the paths can get quite large and you can have quite a complex game. I'm just showing you the basic layout of it for this tutorial. And I know I wrote a lot of code here, but all of the code you see on screen now you already understand because we already went through it. And we're just kind of laying this code out in different sections and different paths to create this game. So let's just run this one right now, just to kind of make sure this is working. So we're gonna say, what is your name? Tim. Hello, Tim, do you want to play? Yes. You enter a maze. Let's go left. You go left and see a bridge. Do you want to cross? No. Good choice. You win. Okay, let's do a different path this time. Let's go Tim. Yes. Let's go right. If we go right, you go right and fall off a cliff, right? So you can see based on prior decisions that we've made, that affects the game. So we can go Tim. Yes. Let's go left this time. And then let's cross the bridge this time. And it says you want to cross the bridge, cross, good choice, you win. Let's see, maybe I did this wrong. Oh, if cross equals yes, that's why. So if cross equals cross, that's what we should be checking. Do you want to cross the bridge? Oh, what did I type? Okay, no, this is correct. I just typed cross rather than yes. I don't know why I did that. And you get the point, okay? So this can continue working. I'm even confusing myself here because I've now been recording for an hour straight with no breaks. Okay. Few more things to cover here. If you want, you can convert these to lowercase as well. So if they type something like, yes, this will work. So to do that, we can say dot to lowercase, right? And now if we do that, after what the user types in, we'll convert that to lowercase and then we'll store that in the variable. So now it doesn't matter the capitalization they type in, this will just work. But obviously if you convert this to lowercase, make sure the string you're checking is lowercase, because if you do something like yes, then that's never going to work because we're always converting this to lowercase. Okay, last thing we're going to cover here is checking multiple strings in one of the options here. So maybe we want the user to be able to type in yes, or we want them to be able to type in Y. Well, how do we check that? Well, now we're going to quickly cover the and, or, and not, which are the logical operators in JavaScript. So let me zoom in a little bit here. Okay, so we have three operators you need to be aware of. The first is a double ampersand, which is and. The second is a double pipe, which is or. And the last is an exclamation point, which is not. Okay, let me just get my slashes correct. Now the not is really simple. The not simply reverses something from true to false. So if I do not true, this is valid by the way, this gives me false. If I do not false, this gives me true. So sometimes what you'll see is something like, x is equal to 2, whatever, and then there's a not sign here. Now when you do that, you're just saying, okay, whatever's inside of here, if it's true, I want it to be false. If it's false, I want it to be true. So the not just flips it, okay, from true to false. That's that. Now the and is how we can check if two things are true. So true and true is going to give you true. True and false is going to give you false. If you have false and true, this is going to give you false. Essentially what it's doing is it's checking both the left and the right and making sure both those things are true. So if both of them are true, you get true. If any of them are false or all of them are false, you get false, okay? Now, it doesn't really make much sense when you're just writing false and true, but oftentimes you'll see things like, x is less than 2 and x is maybe not equal to -1. Maybe that's something you're going to check. I don't know. But the point is, if you do that, now if both these things are true, this whole thing here is going to give you true. Otherwise, it's going to give you false. Okay? That's the and operator. Both the left and the right need to be true. The next operator we can look at is the or operator. Now, the or operator just checks if the left or the right is true. And it could be both of them are true. That's fine. That will give you true. It could be one of them is true. Then it's going to give you true. But if both of them are false, it will give you false. So quick example, true or false is equal to true. Okay, false or true is equal to true. True or true is equal to true. And the only situation where you're going to get false is you have false or false is equal to false. Okay, so these are what are known as the logical operators, and they allow us to combine multiple conditions together to check more complex things. So for example, if we go here, when they're typing, crossing the road, we're going to say if, or crossing the bridge, sorry, if cross is equal to yes, or cross is equal to y, then we'll let them cross, okay? So that's what we're doing here. We're saying, okay, let's check multiple things. If they typed in yes, or they typed in y, then we're going to go down this path, right? Now, if you wanted to, you could check multiple. So we could do another or. We could say or cross is equal to okay, whatever you want to check, right? You can check multiple things, then this will work as well. So you can combine ands and ors and multiple ors. We don't need to get into all of that in this video, but I just want to quickly show those to you because they are pretty important and can allow you to make a more advanced game. Okay, so there you go, guys. That is the Choose Your Own Adventure game. I know I really just built kind of a basic version now, but I really want you to extend this and make it more complicated and mess around with it before proceeding. So I just gave you kind of the base, and now you can make something really cool. Now this is going to be a text-based calculator. That means that we're going to get the user to type in two numbers, so the left side operand and the right side operand, and then some kind of operators like a plus, minus, multiplication, division, etc. So let's go ahead and dive in. We're going to start by using prompt. So in order to do that, we're going to say const prompt is equal to require, and then this is going to be prompt dash sync, and then we are going to call that with the parentheses. Okay, then we're going to ask for two numbers. Let me just zoom in a little bit here. So we're going to say const number1 is equal to prompt, and then this will be please enter number1, or we can just say enter number1, and then let's copy this, and actually let's fix this first and put number2, and then change this to number2, and then lastly we're just going to call this operator, and we're going to say enter sign. Okay, Cool. So it's going to ask them for the first number, the second number, and the sign, and then we're going to perform that math. Now, what I want to do here is essentially check the sign and see if the sign is a plus or a minus or a division or a multiplication or all the different arithmetic operators that we have, which actually I should go through now. And based on what they enter, we're going to perform that arithmetic. So as you saw, we have plus, minus, division, multiplication. We also have the modulus operator. This gives you the remainder after division, but we're not going to go through that right now. And these are kind of the core arithmetic operators we can use. There's a few more, but these are the most popular ones. Now this allows us to add values, subtract values, and essentially perform operations with numbers. So what we're going to do here is actually learn about a new feature in JavaScript called the switch statement. Now the switch statement looks like this, and it's very similar to how the if statement works, except it's just checking the value of a single variable. So if I say switch on my operator, what I can do now is write some different cases, and we're going to check essentially to see what the operator is equal to. So rather than having a bunch of if statements and saying if operator is equal to plus, if operator is equal to minus, if operator is equal to, etc., we can just switch on the operator and then write the cases that correspond with what we want the operator to be equal to. Don't worry, this will make sense in a second. So we're going to say case, and then we can go plus, and then colon. Now, what we'll do is after the colon, in an indented block here, we write anything that we want to run if operator is a plus. So in this case, what we want to do is something like result is equal to number 1. So let's type this correctly, plus number 2. Then we can say console.log the result, and we can break. Okay, so this is a simple case in a switch statement. Now you need to have case, you have what the value is that you're checking. So again, it's for the value of this variable. Then after the colon, you can write anything that you want to happen in this case. So here, we're going to say result is equal to number 1 plus number 2, and then we're going to console.log the result and break. However, what we're actually going to do is first define this variable. So we're going to say let result. Now you may not have seen this before, but we can actually define a variable without initializing it or giving it a value. So that's what I'm doing here. And then I can say result is equal to, and I can kind of assign a value to this variable. So right now result will be equal to undefined. That's fine, but it's just something that you can do. So you can kind of say, hey, I want to have a variable called result. I don't want to give it a value quite yet, but later I will give it a value. Okay, so that's the first case. And then what I can do is copy this and paste it. And notice we have this break keyword. Now the break keyword ends the case, and it's very important that you have this. A lot of people miss the break, and then they get errors in their code. So you need to make sure you have the break. This is what separates the cases. So now I'm going to have a minus. Now for the minus, we're just going to change this to be a subtraction. Now you get the idea. We're going to copy this for the other operators that we want to have. So we can have a division, and then change this to division. And then we can have an exclamation point and change this to, sorry, an exclamation point, asterisk, which is multiplication, and then an asterisk for multiplication. Okay, let me make this a little bit smaller so it's easier to read. Okay, so these are the 4 different cases that we have: plus, minus, division, and multiplication. And essentially we just check if the operator is equal to any of them, and then we go into that case. Now we start by checking the first case, and then we move down in sequential order. So let's just run the code and see what we're getting right now. So we can go here and clear and go node and then project2.js and enter number 1. So let's go with 8, enter number 2. Let's go with 9. We'll do a plus, and notice that we actually get 89. Okay, that's a bit weird. Let's try a different case. Let's go 9, 2, and minus, and that time we get 7. Okay, and what happens if we go 3, 4, and then a asterisk? We get 12. So the reason why we got 89 here, when we added 8 and 9, is that when we use this prompt function here, this actually gives us back strings. Now, JavaScript is a really weird language, and when you try to do operations with strings, And when you try to do arithmetic operations like plus, minus, division, multiplication, etc. using strings, you can get some wonky results. Now in this case, you saw that when we added these two numbers together, since they were both strings, we actually got a string concatenation. So 8 plus 9 was equal to 89 because these were strings and we simply squished or concatenated them together. Now it works properly with our other cases because of some weird ways that JavaScript works, but what we need to do to ensure that we get the correct result is first convert these strings into numbers. So to do that, we're going to use the function parse float. So what I can do is simply surround my prompt with this parse float, and what it's going to do is simply grab whatever the number is that we type in and convert it to a floating point value or the number type. So that way, when we get a number, we convert it to the number type rather than the string type. So when we perform this operation, everything works properly. So let's go ahead and do that. We're going to clear and run, and let's go 9, 9, and plus, and notice this time we get the correct answer, which is 18. Okay, so that's good. Now, you might have noticed down here that when I do this console.log, I'm pretty much just doing the same thing 4 times. So rather than me actually doing this inside of the switch statement, because it's very repetitive, what I'm going to do is take it and move it outside of the switch statement. So I'm going to go down here and put console.log result. Okay, so now let's run the code and just make sure that this works. Let's just go 4, 5, and division, and you see that we get 0.8. Okay, very good. However, what happens if I try to type in a sign that doesn't exist? Well, that's where we're actually going to implement a new case here called the default case. Now, the default case is kind of like the else statement in the if-else block, and this will execute if none of the cases above it were the case. So inside of default, I can do something like console.log, and then invalid, and then I can break out of this default case. Okay, very good. So now if you type anything other than one of these cases, we're going to go into the default block. Again, this is like the else statement, and we'll print out invalid. But what does that mean for our results? Well, let's try it out. We can always just test things and mess around. So if I go here and go with 8 and maybe 9 and like go with something weird like a colon, you can see that we get invalid and then we get undefined. Now, really, we don't want to print anything out unless we actually have a valid result. So why don't we do something to make sure that we have a valid result before we print this? Well, what I can do is actually set up something known as a flag. I'm going to say let valid equal true. Now, the idea is I'm going to have this variable, which is a Boolean. We've set it equal to true, and we're going to assume that we have a valid result. However, if we reach this default case, then we can say valid is equal to false, because if we didn't go inside of any of these cases here and exit the switch statement, then we know that we had an invalid operator. So we'll say valid equals false. So then I can go here and say if valid, then we'll print out the result. And notice that I did something weird here. I didn't write the curly braces for my if statement. Now, when you just have a single line that you're using after the if statement, you actually don't need to use the curly braces. It only works like this if you just have a single line that you're executing, which is what I'm doing right here. And I can write the code like this, as you see here. And this is perfectly valid, or I could even do it like this if I wanted to. So I'm going to do that just to show you the shorthand. Now, for the result, what I'm going to do here is the following. I'm just going to print out a little bit of a better kind of output. I'm going to print number 1, and then I'm going to print operator, and then I'm going to print number 2, and then I'm going to do a comma, an equal sign, and then the result. So this way we just print out the whole expression so we can see exactly what we got. Let's zoom out again to make it a little bit easier to read. Okay, so let's run this now. 8, 9 plus, and now it says 9 plus 8 equals 17. Okay, so I just wanted to get the kind of nice output here. Very good. So there you go. We have our switch statement, but what happens if we enter a number that's not valid? Let's try that out. So if I go here and run my code and try to enter something like hello and 1, and maybe I add these together, notice I get nan. I get not a number. Now, why am I getting that? Well, when I use this function right here, parse float, if I accept something in here that's not a number, so a string like hello, then it simply returns to me the type nan, which stands for not a number. So what we need to do ideally is we want to ask the user to keep giving us input until they give us a valid number. So if it's NaN, we got to say, hey, no, that's not valid. You got to give us something else. So how can we do that? Well, let's write some code that can handle that for us. But in order to do that, we need to learn about something known as the while loop. Now, the while loop is something that can keep repeating code until a certain condition is met. So what I can do is something like while, and then condition, and then we'll go here, do this. So this is kind of the syntax of a while loop. We say while this thing is true, so whatever we put inside of the parentheses, while that's true, keep doing whatever's inside of the loop. So just keep repeating it over and over and over. Now this is really good for when we're collecting something like user input, because we can say, while we don't have valid user input, keep asking them to give us input. But let me show you a few examples of how the while loop works. So we're going to say let I equal 0, and we're going to say while I is less than 10. I'm then going to say I plus plus. This is actually a way that you can add 1 to a variable. So plus plus adds 1, minus minus subtracts 1, plus equals 1 adds 1, plus equals 1 adds 2, minus equals 1 or minus equals 2 subtracts 2. I'm just showing you a few ways you can do this here. So I'm going to say I plus plus, and before that I'm going to say console.log I. Now if you want to pause the video and take a guess at what the output of this code is going to be, go ahead. I'm going to explain it now. So this is a while loop. We have a variable I, and I tracks how many times this loop has ran. So we say while I is less than 10, we print out the value of I, and then we add 1 to I. So at the first iteration, I is 0, so we print out 0. Then we add 1 to I now becomes 1. We then check if 1 is less than 10, and it is, so we keep looping. So we print out I, so we print out 1. We add 1 to I, so I is now 2, and we repeat this process until eventually I is 10. When I is 10, this condition now is false, so we stop looping. Okay, so let me show you how this works. I'm just going to comment out the rest of the code so I can run this. And so let's go here, bring up our terminal, and notice we get 0 through 9. If we wanted to get 10, we need to make this less than or equal to 10 in order for that to work. Okay. So that is the basics on the while loop, but there's a few keywords in the while loop that we need to understand. The first keyword we want to look at is the continue keyword. So what I'm going to do down here is say if I is equal to 5, then continue. Now what continue will do is simply go up to the top of the loop, and I just need to change this a little bit so that it makes a bit more sense. Okay. So continue just simply stops the while loop where it is and goes back to the beginning. It doesn't change anything, just goes back to the beginning of the loop. So as soon as continue is hit, we skip whatever's beneath us and we just go back to the top of the loop. So what I'm implementing here is essentially a skip on 5. So I'm not going to print out 5 if I is equal to 5. That's what I'm doing here when I run this code. And I've adjusted this slightly, but you'll see that when I run this now, we get 1, 2, 3, 4. Notice we skip 5 because I had the continue here. And then we get 6, 7, 8, 9, 10. Okay, there you go. Now the next keyword is the break keyword. So if we rewrite this loop, we can actually do it like this. We can say while true, we can say console.log I, we can say I plus plus, and we can say if I is equal to 10, then break. Okay, now what I've done is just written the same loop that we looked at before, except rather than having a condition up here, I've used a different pattern or a different way of writing this where I implement a break. Now what the break does is simply exit the while loop. As soon as you see the break keyword, you just escape the loop. So we say while true, console.log I, add 1 to it, but if I is 10, break out. So now if we run this, you see that we get the same thing, 0 through 9. Okay, perfect. So that is the while loop. And now we're going to use it to actually validate our input. So what we're going to do is the following. We're going to say while true, and we're going to put this number inside of here. Okay, next we're going to say if, and then is NaN number 1, then we need to console.log invalid input. Okay, otherwise we are going to break. So this is NaN function here simply checks if something is not a number. So if when we try to convert this to a number, it gives us is NaN, then that means this is invalid. So we just print invalid and then we ask them for a number again. Otherwise, we break out of the loop. It's as easy as that. So I wrote a simple while loop. I said while true. So this means loop forever. Now, by the way, if you fail to have a break keyword and you have a loop that has while true here, then you're going to have something known as an infinite loop, which means you're just going to be running forever and it's never going to stop unless you manually close the program. So you want to avoid infinite loops and make sure you always have a way to exit them. Okay, so we have while true, ask for the number, convert it to a float. If it's NaN, that means it's invalid, so we print out invalid and we ask them to try again. So let's test this out. We're going to go here and we're going to say, hello, invalid number. Okay, this, invalid, -9, and you see that that works, okay? Perfect, so let's just get out of this. Now I want to do the same thing for number 2. So we can just copy this and paste this here, but change this to say number 2, and then say enter number 2, and then change this to be number 2. Okay, so let's run the code now and just make sure it works for both operators. So we're going to say 9, okay, invalid, and then it works. We can do our plus, and we get an issue here, which I'm going to talk about in 1 second. Okay, so let's fix this problem. So this problem here that we're seeing is it's saying that number 1 is not defined. And the reason it's saying number 1 is not defined is because I've defined this inside of the while loop. Now, when we use this const definition, this means that this variable that we've defined is local to where we defined it. So in this case, it's defined inside of the while loop. Now, I don't want to get too far into something known as scope here, but essentially to fix this issue, what we can do is say let number 1 like this, and we can also just go let number 2 while we're at it. And now rather than using this const, we can just remove that and say number 1 and number 2. So now these variables are defined in this what's known as the global scope, because it's like the furthest left in the program. It's not inside of any blocks. So that means that this switch statement now will be able to access number 1 and number 2. Okay, so let's run this and test this out. Okay, 1, 2 plus, and we see that we get the result we're looking for. Okay, now any of you that are being kind of, vigilant here, I guess, would notice that we have pretty much the exact same code 2 times in a row. Now, if you know anything about programmers, they're lazy. They don't like writing the same thing multiple times. There must be a way to optimize this or make it better. And in fact, there is using something known as a function. Now, a function is a way that we can write reusable code. I'm going to go down to the bottom of my program and introduce a basic function, and then we'll show you a more complex one. So a function works like this. You just say function, you give the function a name, and by the way, the name of the function follows the same rules as the naming for variables. So it can't start with a number, you can use underscores. If you have multiple words, you can't use spaces, for example. So I'm going to do function, and let's go maybe get number is what we want. And I'm going to write a set of parentheses and a set of curly braces. Now, this function is something that's callable and can contain reusable code that we can call whenever we need it. So pretty much the way that this will work is you have this function named here. So the way this function will work is you have a name, you have a set of parentheses, and inside of the parentheses, you can take what is known as a parameter. Now, a parameter is input to the function that you can then use within the function. It's like a variable you pass to the function. Now, within the function, you can do something. And if you want, you don't have to, you can return a value. Okay, so we've actually already seen functions and we've been using them a ton. In fact, parse float, this is a function. This is a parameter or a value we pass to the function. And the float function here returns a value to us. It returns a number. Okay, so we're going to write our own function that does this. So let me show you here. I'm going to say get number, and I'm going to take in just some number. Okay, now this will be like what number we want. So it'll be like number 1, number 2, like the number of the number we want. I know it's a little bit confusing, but that's the parameter that I'm going to take in. And in fact, let's just call this number string maybe to make it a little bit more clear. Then what we can do inside of this function is we can copy what we have here. So let's copy this. And I'll show you how we write the code in a function. So rather than saying number 1 is equal to parse float, we're just going to say const number is equal to parse float. And then same thing with isNaN, because this function is going to be reused multiple times. Now, rather than having enter number and then 1, what I'm going to do is write a string concatenation. So I'm going to say enter number plus the number string plus and then this is going to be a colon and a space. Now, the reason I need to do this is inside of the prompt function, I cannot pass commas or different values, so I just need to pass one string. So I'm going to create one large string. Now, number string is going to be like this, like first, second. So it's going to say enter number one, or sorry, number string is going to be 1 or 2 or 3, how I have it here. So it's going to say enter number 1, enter number 2, enter number 3, etc. That's what I'm kind of trying to get at here with this input. So now we check all the same stuff that we did before, except this time, what I can do is rather than having the break here, I can say return, and then I can return the number that we got. Now, this return keyword allows us to give a value back to whatever called the function. So the way you call a function is you write the name of it, you put a set of parentheses, and then any parameters that it needs, you pass them. So I could say get number, and then, we could say 1 or 2. And then what will happen is this is going to return to us whatever the number is that the user typed in. That's how the function works. But the great thing is I can call the function multiple times and reuse this code in as many places as I need and really write some cleaner, easier to understand code. Okay, there's a lot of other benefits of functions, but that's how it works. Now, this return keyword can be used multiple times. However, as soon as this keyword is encountered, the function immediately exits. So the reason I removed the break keyword here is that we don't need it, because the return acts as a natural break for this while loop, where as soon as we see return, anything that's happening in this function stops and we go back to wherever this function was called. I know it's a little bit confusing, but I'm just going to take this now and show you how we use it. So let's remove this and this, okay? And we're going to go to the top of our program because typically we write our functions at the top, and we're going to put get number. And now we're just going to use it. So we're going to say const number1 is equal to get number, and we're just going to put 1. And then we're going to do the same thing for number 2. So let's copy this and paste it and go with 2 and then number 2. Okay? So now we're doing the exact same thing we had before, except we're reusing this code inside of a function, so we're not writing the same thing multiple times. Now, one thing to note, you can take in multiple parameters. So if you wanted to, you could write another variable here that's required for the function, and then you would have to pass it like this. We're going to look at more functions later on, so don't worry too much about them, but this is a way to write reusable code, and it's very important, and we use it a lot. Okay, so now we have this function that gets a number for us. We handle a lot of the stuff that's going on here with the arithmetic. So let's run the code. Let's enter a number like this. Okay, invalid input. Let's go 98. Let's enter something invalid. Okay, invalid because we're using that function. Let's go -9 and let's divide them. And there you go. We get 10.888889. Great. Now we can try this as many times as we want, but let's see what happens if we do something like this. 89, 0, and then division. Now notice that gives us infinity. Now we probably don't want infinity. Instead, we probably want to give like a 0 division error. So let's see how we can fix that. I'm going to go to my division here, and I'm just going to add a check. I'm going to say if, and we're going to go with, what is this going to be? If number 2, which is the one that's at the bottom, is equal to 0, then I am going to do the following. I'm going to say valid equals false, and console.log 0 division error. Okay, otherwise, actually, we can still set the result because it doesn't matter, but then down here, we just won't print out the result because, well, it will be invalid because valid is equal to false. Okay, so I just want to check that this works. So let's run this, enter some number, 0, divide, and we get 0 division error. Okay, so that's pretty much it for project 2. All of this code will be available from the link in the description, by the way, in case you want to paste any of this in. But I just wanted to show you, for example, the while loop, the switch statement, how you do things like convert strings to numbers, different errors that can pop up, how we write a function. So hopefully you learned a lot from this project. In the next one, we're going to learn even more. The idea here is I want to build a simple application that allows me to manage my contacts. So something like a contacts app in your phone. A contact is just going to have a name and an email, but technically we could add as many values to it as we want. Now, this contact app is going to have some different functionality. We're going to have the ability to add a contact, delete a contact, search for a contact, view the contacts, and then exit the application. So I want to start by just defining what that functionality is and kind of setting up some routing in my application, because this will be a little bit larger, and showing you how you create something slightly more complex. Anyways, let's get into it. So let's start by importing prompt. We're going to say const prompt is equal to require prompt dash sync. And then we're going to call this. And I just want to print out an informational message here that kind of displays the functionality. So let's make a function. And to do that, we're going to say function, and we'll just say print info. This doesn't need to take in any parameters, and it doesn't need to return anything. And we can just kind of log some information about the system. So we can say contact management system, like that. We can go console.log, and we can print out some of these. We can say console.log, and then I'm going to define the different operations we could perform. So the first operation is going to be add a contact. Okay. Then we're going to go to delete a contact. Then we're going to go with 3, which will be view contacts. Then we're going to go with 4, which will be search contacts. And then lastly, we're going to go with 5, which will be exit. Okay, so let's test this out. Let's call the function print info. When we call the function, it will just run this, and we should get some information. So let's go clear and run. And oops, I'm running the wrong app. So let's just go through this. Okay, and let's change this to be project3.js. And you see that we get some information. All right, so now that we've got this, what we're gonna do is start setting up kind of some routing in our application. So what I'm gonna do is make a switch statement, and that switch statement will handle the different operations that the user could potentially enter. So let's start with print info, that's fine. And then let's do kind of a prompt here. So we're gonna say const, and this is gonna be number is equal to prompt. And we're gonna say enter an operation. Okay, and that could be 1, 2, 3, or 5. And we can kind of give them some hint here by saying, it's 1 through 5. Okay. Then here, we're going to set up the switch. So we're going to say switch on number. Okay. And remember that number is a string. So what I'm going to do is set up some cases. So I'm going to say case 1 and then break. And then I'm going to say case 2 and then break. Now I'm just kind of setting up what we'll handle in these different cases. And then we're going to say case 3. And then break, case 4, and then break, not broadcast channel, and case 5. Oops, what's going on here? Okay, come on, case 5, and then break. And then lastly, we're gonna do a default case. So I'm gonna say default, and then I'm gonna go console.log. Maybe we'll go unknown, and then we will break. Okay, now let's actually, I don't know why I added these spaces. Let's remove them so it's easier to read for now at least. But the point is we now have 5 different cases. Now for each of these cases, we're gonna handle the different operations. And what I actually wanna do ideally is just ask the user to keep entering these different operations. So what I can do is simply set up a while loop here. I can say while true, and then I can put the switch inside of this. Okay, so if we want, we can kind of indent this in so it's a little bit cleaner. And let's make this a little bit larger. Okay, so while true, we're gonna do this. We're just gonna keep asking them to enter operations. Now, the first thing I wanna do is I wanna allow the user to get out of this loop. So actually we'll set up a variable and we'll just say, let keep going equal to true. And then we're gonna use keep going here. So I'm gonna say while keep going, and I'm gonna go to case 5. And what I'm gonna do is say keep going is equal to false. So all I'm doing in case 5 is saying, hey, if we type in 5, that means we want to exit, right? That's the operation we have here. So we're just going to set this variable equal to false, which means we'll stop looping. So we'll stop kind of handling the routing of what it is that we want to do. Now for the rest of the cases, I want to set up a function that allows us to kind of handle what we need to do. So I'm just going to write 5 functions here. So I'm going to say function add contact. Okay. I'm going to say function delete contact. I'm going to say function search contact, and I'm going to say function list contacts. And for this, I'm going to take in the contacts that I want to list. Okay, we'll talk about that in a second, but here are the 4 functions that we need. So now I'm just going to call these functions. So from 1, I'm going to say add contact. From 2, I'm going to say delete contact. From 3, I'm going to say search contact. And from 4, I'm going to say, what was this one? List. I think actually I have it in the wrong order. So this is going to be search contact, and this I believe is going to be list contact. Okay, and this is list contacts. So I think that's what we have. Yes, looks good. And then we have to remember pass contacts here. Okay, so now this is like the router, if you want to think of it like that. So what happens if you type in 1, we go to this function and we do whatever we're going to put here. If you type in 2, we do this. And this is how I like to start writing my programs, because it gives me really clear kind of separation and allows me to write one of these functions at a time, which just makes my life so much easier when I'm programming. So you can kind of see, like, I'm writing this from scratch. I haven't written this before. So I'm just planning things out by kind of making these different functions, some different areas in my code. So now I just need to tackle one function at a time. But before we can do that, we need to learn about arrays, because arrays are how we're going to handle storing our different contacts. Now, an array looks like this. Const arr is equal to a set of square brackets. It's essentially a way to store multiple elements that have a position or an index, okay? So we can say const array is equal to a set of square brackets. This is an empty array, but I can put some values in here, like 1, 2, 3, 4, 5. Now, each one of these values is accessible using their position or their index, and their index starts at 0. So let me just go to the comment here. So number 1 or value 1 is actually at position 0 or index 0. 2 is at position 1, 3 is at position 2, and 4 is at position 3. Okay, so you always start counting at 0 when we're talking about the index or the position in the array. Now, the reason that's important is with this array, I can modify a value by using its position. So I can say array, use these square brackets, at 0 is equal to something like 9. If I do this, now the value here will change, and we can prove that by printing out our array. Let me just comment out the rest of this code. So when I run it, we just get this. Okay, so if we look here and we run, you see we get 9, 2, 3, 4. Okay, so you can access values using their index or their position, and you can change them as well. Now, if I wanted to, I could just maybe print out the value of array at index 1, and that's going to give me 2 because I'm accessing this, which is the second position, right, which is the first index. So I know it's a little bit weird, but we start 0, 1, 2, 3. Now, a few more things about arrays you need to know about. You can access their length using .length. So if you want to see the length, you can do it like that. And there's a bunch of methods you can use on arrays. So one of the reasons arrays are useful is that you can actually add values to them. So I can say array.push, and I can push, for example, the value 10, and then print out the array. And you'll see now when I run this, that 10 gets added to the end of the array. So the size has increased. Now, just like we can push values into the array, we can pop them or remove them. Now, when we pop, this simply removes the last element from the array. So when I run this, now we get 1, 2, 3. Now we also have the ability to splice. So splice can remove an element based on its index. So if I wanted to remove 3, I would go splice 2 and then comma 1. Now the 1 here specifies the number of elements after the index that I've specified that I want to remove. So when I do 2, 1, that means just remove this element. But if I were to make this 2, that means we're going to remove 3 and 4. So you can see here, if I go and run my code, I get 1, 2, 4. Okay, so that's arrays, but next we're going to talk about objects. Now objects are a way that we can group information together. So here's an example of an object. I can say something like const contact is equal to, I use a set of curly braces, and then I can do something like name is equal to Tim, and maybe email, I need to do a comma here though, is equal to tim@gmail.com. Now an object is like a key value pair. We have a key, which is known as a property. So that's this right here. We do a colon, and then we can assign some value to it. Now in this case, I'm assigning a value like a string, but I could assign a list. I could assign another object. And sorry, when I say a list, I mean array. I could assign another object, I could assign a number, I could assign a Boolean. It doesn't matter. We can put anything that we want here. Now, these properties can be accessed in the following way. We can say contact dot, and then we can use the name of the property, so like name or email if we wanted to access it. If we want to change it, we can do contact.email is equal to something like this. That's perfectly valid. And we can also add additional properties, or we can do something like contact name is equal to Tim, and we can use this kind of square bracket syntax. So you can see how this would be useful for us to store, for example, a contact, because we can group a name and an email together, and we can have additional information if we wanted to. Okay, so that's how that works. Now, a quick note here. You might have noticed that I defined my array using a constant, yet I'm changing the array afterwards. Now, the reason why this works is an array and also an object, many types in JavaScript, are what's known as mutable. Mutable means that once they're defined, they can be modified. So it's different from creating a new array. We're modifying this array here. So the array itself is like the same array, but the contents of it are changing. So that's why const is allowed, because I'm not adding a new array here. I'm just modifying the existing one because it's referred to as mutable. Mutable meaning changeable. Now, if I tried to do like array is equal to this wouldn't work because now I'm trying to take a new array and assign that to a constant variable. Okay, so hopefully that makes a little bit of sense, but that's a concept known as mutable or mutability. So let's remove this now, and let's now create a array. So I'm going to scroll up here, and I'm going to say const contacts is equal to an array. This is what we're going to use now to store our different contacts, and it can grow larger and larger as we add new contacts. Now I'm also going to go to list contacts, and I'm just going to pass this array now so that when we pass or we call list contacts, it will show it. And we're going to go in list contacts and just really quickly write out console.log and then contacts. We're going to make this look better later, but for now, we'll just print out the different contacts. Okay, great. So now after that, we're going to go to add contact. And now we have the ability to add a contact. So when we add a contact, what we want to do is ask for the name and the email. We're then going to create an object that stores that information and add that to our contacts array. So I'm going to say const name is equal to prompt, and then this is going to be name : like that. I'm then going to say const email is equal to prompt, and then I'm going to take in the email. Then what I'm going to do is create my contact. So I'm going to say const contact is equal to name, and email. Okay, so we've just created an object. And then we can just say contacts dot push, and we can push the contact. Perfect. So now we have the add contact function, and we can test it out and see if it's working. So let's run this, and we're going to go add a contact. We're going to go Tim, and then tim@gmail.com. Then we can list the contact. So actually, let's add another one. Let's go Joe, and then joe@gmail.com. And now we're going to do operation 3. And you see that we get our 2 contacts and that we can exit with 5. Okay, perfect. So that is a good start. Let me make this a little bit smaller so it's easier to read. So now we have the ability to list the contacts and to add them. However, we probably want the list to look a little bit nicer and to do something like kind of, print them out in a nicer formatted way. So to do that, we're now going to learn about a new feature known as a for loop. Now, anything that you can do in a for loop, you can do in a while loop. Now, a for loop is typically used when you know the number of times that you want to loop. And usually you use it when you're interacting with some kind of structure like an array. You don't have to, but it's very common to use it with arrays. So what I'm going to show you is a basic for loop. It looks like this, just bear with me. We say for let, and then we create some kind of variable. This variable is going to track the number of iterations that this for loop has gone through. So this will look familiar to the while loop, but I'm going to say for let I equals 0. I'm going to say I is less than 10. This is my condition for looping. And notice I have a semicolon here. It's important that you have that to separate these. And then I'm going to have my increment or my change. So I'm going to do I plus plus. What I'm saying is I want to start I at 0. I want to loop while I is less than 10, and every iteration of this loop, so as soon as one of it finishes, I want to add 1 to I. Now I could add 2 to I. I could start in the reverse direction, like let I equal 10. I is, greater than 0 and I minus minus. If you want to pause the video and see how that would work, feel free. But you can do any kind of combination you want here. But what's common is to loop up to, some number, for example. And notice I know how many times the loop's going to run here. So what I could do now is say console.log I, and if we kind of comment out all of this, let me just do it like this, and I run my code, you'll see that we're going to count up to 10. So we go 0 through 9, okay? Similar to what we did with the while loop previously. Now, that's useful, but a lot of times we actually use this to iterate through an array. So for example, if I have an array like this, and I have, constant array is equal to 1, 2, 3, or let's do something else. Let's go like apple, peach, pear. Okay, so we have some fruits. What I might do is something like let I equal 0, I is less than ARR dot length, and then I might print out ARR at index I. Now what I'm doing is I'm using this for loop to loop through all of the values in the array. So what I'm doing is saying, okay, I'm going to treat I like the index. So what I'm accessing in the array. I'm going to start it at 0 because that's the first one. And I'm going to go up to the array.length, but I'm not going to include that one. Then I'm going to add 1 to I every iteration, and I'm going to access the array at index I. So if I do this now, you'll see that when I run the code, we get apple, peach, pear, because I'm looking at each index in this array and printing it out. Now, if I were to maybe make a mistake and do less than or equal to, meaning we're going to go up to 3, index 3, which actually doesn't exist here, you'll see that what happens is we get undefined. So no crash or error occurs in our program, but we try to access an index that doesn't exist because array.length is not an index that's valid. It's only one less than the length of the array. So we got undefined. Okay, that's our for loop. So we're going to use the for loop now inside of list contacts, but we're going to use a variation of it that's a little bit cleaner. So we're going to say for, and we're going to say let contact of contacts. So you saw previously that what I did is I accessed the values by their index, but we don't actually need to do that. What we can do instead is we can just use the structure itself and get all of the elements. So what you looked at before is iterating by index. This time we're going to iterate by item. So you can say let contact of contacts. This variable can be anything that you want. You just need to use let. And then you can say of something like an array. And when you do this, now JavaScript is going to give contact each of the values inside of the contacts array. So rather than having to access the index manually, this will just be equal to each contact in the order in which they exist in the array. And then we can print them out. So I can say console.log, and I'm going to say contact.name and console.log contact.email. Because remember, contacts are objects. Each object will have a name and an email. So once I access the object from my contacts list, then or from the array, sorry, I'm going to keep using list because I'm used to Python, then I can access its name and its email. And we can just add a little bit of formatting here and just go kind of name like this. And we'll go email like this. Okay. And what else do we want to do? We're just going to add something like this, print, and then a bit of separation. So let's just do some number signs so it's a bit easier to see. Okay. So I just want to print out or test out my listing contacts. So let's go here. Let's go add a contact, Tim at gmail.com, and let's list this with option 3, and we got an error. What is the error here? It says print is not a function. Okay, my apologies. Where did I put print? Believe we might have put that. Where did we put print? Okay, so I found it here. My apologies. This needs to be console.log. So let's test that again. Okay, run 1. Tim at gmail.com, and then we'll go 3, and you can see that it prints out this contact. Now if we want to add another one, we can do that. So let's go Joey, and then Joey at gmail.com, and we'll go 3, and you can see that we now get both of our contacts. Awesome. Now we probably want to just add a little bit of separation here to make this look a bit cleaner. So what I'm going to do is after the operation, I'm going to say console.log, and I'm just going to log an empty line here. Now that's one way to do it. Okay, so now that we have that, I'm also just going to go to my add contact here. And after we add the contact, I'm just going to say console.log and then added. Okay, nice. So now we're going to move on to the delete contact. Now to delete the contact, what we're going to do is list each of the contacts, but this time we're going to list them with a number beside their name. Now we're going to do that so that we can delete the contact by simply referencing the number of the contact. So the idea is we'll print out all the contacts with 1, 2, 3, etc. beside their name, and then we can just delete the one with what number we select. So if we select number 2, we'll delete contact number 2. So to do that, we're going to use a for loop. And we're going to say for, and this is going to be let I equal 0, I is less than contacts dot length, and then I plus plus. Now the reason I'm using this style of for loop now is because I want to know what number contact I'm on. I want to know the index associated with it so that I'm able to delete it later. Whereas here, I don't care what contact I'm on, so I just do it like this. But if I want to know the index or the position, then I need to use this style of for loop. There's actually other styles as well, but these are the two most common ones. So now I'm going to say contact is equal to, and this is going to be contacts at index I. Then I'm going to say console.log, and I'm going to log, and we're going to go with I plus 1. And then, actually, we're going to do something different so that you guys can see how this works. We're going to go I plus 1 dot to string plus a colon, and then this is going to be comma contact dot name. Okay, so I know this is a bit confusing, but what I'm doing is I'm taking I, which will start out equal to 0, and I'm adding 1 to it. That way we don't start with contact number 0, we start by displaying contact number 1. We then convert this to a string, and the reason I'm converting this to a string is so that I can add a colon to it without having a space. So I take this expression, which is I plus 1, which is a number, I surround it in parentheses. And then that way I can take that whole thing and convert that whole thing to a string. That's how you do that, by the way, using .toString. And then now that it's a string, I can add it to this colon. And now that I can add it to this colon, I can then print out contact name after that using the comma separation so that I have a space in between. So let's just quickly test this first before we go any further. So let's go here and run this and add a contact and go name Tim at gmail.com. Let's go now to delete a contact, and you can see that it starts listing our contacts. So we have 1, Tim. Perfect. So what we'll do now is we'll just add maybe a console.log here, and we'll say contact numbers or contact IDs maybe. Okay. Then we're going to do a prompt here. So we're going to say const number is equal to prompt, and we're going to say enter an ID. Okay. Now we're just going to parse this as an int. So we're going to imagine that they do give us a valid number. I'm not going to check for that input. And we're just going to make sure that this is within the range of our contacts. So we're going to say if number is greater than contacts dot length, then what I'm going to do is what's known as a naked or a bare return, and I'm just going to return. So I'm going to say is, okay, you know what, if you gave us something that's not valid, we're not even going to give you any error message. We're just going to return and exit the program. Now we could give them an error message if we want to, now that I think of it. So we can just say maybe like this, console.log invalid. Otherwise, we can remove the contact. So to remove the contact, we can do the following. We can say contacts.splice, and we can splice at whatever the number is they gave us, -1, and then 1, and then console.log. So let's go back here, removed. Okay, and let's add a capital R. Perfect. So pretty much what I'm doing here is saying, okay, we're going to grab this ID that they want to delete and convert it to an integer. If it is greater than contacts.length, and I guess I supposedly can do this too, if it's nan, so if it's not a number, or it is greater than contacts.length, then it's invalid and we can return. Otherwise, we're simply going to remove it by using .splice. And the reason why I'm doing number -1 is because they're going to give me ID 1. or ID 2 or ID 3. They're not going to give me ID 0. So I need to subtract 1 from whatever they typed in to convert what they're typing in to the corresponding index that we want to remove from our contacts list or from our contacts array. Sorry if I keep saying list. In Python it's list, in JavaScript it's array, and I usually work in Python, so I keep mixing it up. Anyways, point is, this should work and it should remove the contact from our array. So let's try this now. I'm going to go to add a contact. I'm going to go tim@gmail.com. Okay, let's list it and we can see that we have that. And now let's try to remove it. So let's go here. And what is the issue this time? We got a problem saying parse int is not defined because I spelled parse incorrectly. So let's spell parse correctly this time. So parse like that. Okay, that looks better. Let's clear, rerun, whiz through this quickly. Okay, and then delete, and we're gonna enter ID maybe 2, invalid. Okay, so let's try again. Enter ID 1, removed, print it out, and we don't have any contacts, and then we can quit with 5. Okay, amazing. So now we have the ability to add contacts, to delete contacts, to list the contacts, and the last thing we need to do is search for contacts. So to search for contacts, what we're gonna do is create kind of a results array. And we're going to put contacts in there where the name that the user typed is contained in that contact. You'll see what I mean, but let's start here. So we're going to say const search string is equal to prompt, and we're going to say search colon like that. Now they're going to enter some kind of name. And what I want to do is check if that name exists in any of my contacts. So for example, I might have contacts like Tim, Timothy, and John. And the user might type in something like TI. Now, since TI is contained within both Tim and Timothy, like this substring exists inside of these, that means that I would return these two contacts. Whereas if I type something like, OHN, well, OHN exists inside of John, so I would return John. So that's the basic search kind of algorithm we're going to write. You can make it more complex if you want, but that's what we're going to do. Now, I'm also going to convert this to lowercase. So we're going to take whatever they type in and just immediately convert it to lowercase. Okay, now we're going to use a for loop, and we're going to say const results is equal to an empty array. And we're going to store our results in that array. And we're going to say for, and this is going to be, we'll go const contact of contacts, and this should be a let, my bad. And what we will do is we will say if the search string, or if the contact dot name dot includes the search string, don't worry, I'll explain what that does in a second, then we're going to say results dot push, and we're going to push in the contact. Okay, so what I'm doing is I'm getting the contact's name, and I'm using this dot includes. Now dot includes simply checks if whatever string I put here exists inside of this name string here. So it's doing exactly what I explained before. If it does, we're going to say results.push, and we're going to push this contact into the results. And then lastly, we're going to say list contacts, and we're going to list the results. So I'm using this function again, but this time rather than using all of my contacts, I'm just passing the results so that I can reuse this code. Okay, amazing. So let's test this out and see if that works. So we're going to say add tim@gmail.com. Okay, one, we're going to go Timothy, timo@gmail.com. And let's go one, John at gmail.com. Okay, and then let's go 3. Okay, we're listing them out. Let's go with 4 to search, and let's search for TI. And for some reason, we didn't get any results. And the reason we didn't get any results is because we've converted this to lowercase, but we haven't converted the name to lowercase. So what we're going to do is we're going to add a dot to lowercase like this. And by the way, this is valid even though it's not super clean. We can go contact.name to lowercase, and then we can check if this whole thing, which is the name converted to lowercase, includes this string, and hopefully that should work for us. So let's quit this and try again. Okay, we're gonna go one, tim@gmail.com, one, timothy timo@gmail.com. Okay, 1 John, and then John at hotmail.com. And then we're going to go and list and then search, and we're going to search for TI. And you can see that we get Tim and Timothy. Now let's try searching again with maybe TIMO, and we just get Timothy. Let's try searching with JO, and we get John. Okay, amazing. Now for this project, we're just going to start by creating kind of a board where we'll store the X's and O's, and this will allow me to explain the project a bit better. So what I'm going to do is make an array, and I'm going to call this my board, and I'll just start with a simple array like this. Now what we're actually going to do is we're going to learn about a concept here known as nested arrays or multi-dimensional arrays. Now when we talk about a board, the idea is we're going to have certain rows and columns, right? For example, maybe we have an X, we have an O, we have an X, right? Maybe we have a blank, an X, an O, but you get the idea, right? This is kind of what our board could potentially look like. Now in this case, we have 3 rows and we have 3 columns. And each one of the positions here, we can kind of represent by their row and column position. So for example, we could say, this is column 0, 1, 2. And then we could have, let's do it on this side. This is row 0, row 1, and row 2. So if I want to access the middle position, that would be position 1, 1, or we could say 1, 1, doesn't matter what way we want to read it. If we want to access this position, we could say that's at 2, 2. Okay, so we want to find a way to do this or represent this in code, and that's where our multi-dimensional array is going to come in. So what I'm going to do is inside of this array, I'm going to create 3 new arrays. Now each one of these arrays is going to represent one of the rows inside of our board. Now, by the way, this is perfectly valid. You can have arrays inside of arrays, and we can go to any level of nesting that we want. And what we'll do is we'll create some strings here, and we're just going to make them empty strings for now. Okay, so we'll have a space inside of them, and we'll do that 3 times. Now, these are going to be the positions in our board. And don't worry, this will make a bit more sense in a minute, but I just want to kind of set this up. Okay, so now we have 3 rows, and inside of each of these rows, we have 3 strings, and these will represent the different positions in our board. So eventually what we'll do is we'll place maybe an X here, we'll place an O here. You get the idea, okay? That's what we're going to end up doing. Now let's talk about how we use this array, because this is probably something you haven't seen before. Now this is again known as a multi-dimensional array or a nested array, and the way that I access the elements here is like this. So if I do board and then I access index 0, that gives me the first element in my array, which is simply this array. So it accesses this entire array. So again, that would go to this array. Now, if I wanted to access an individual position within the array, I would need to index it again. So I could do, for example, 0, 0. And when I do that, this portion accesses this array. And then we have this array, and I'm accessing the 0th index on that, which is the first position here, or the top left-hand corner. If I wanted to access this, then I would do 2. Okay, so we can kind of access which row we want, and then what column within the row we want to see. Now, that's the same if we want to change it. So I could do, is equal to X or whatever I want. That's perfectly valid. So that's how a multi-dimensional array works, and that's what we're going to be using here to represent our X's and O's. So the first thing that I want to do here is I want to write a function that allows me to insert an element inside of this board. So what I need to do is I need to get a row and a column that I want to insert this inside of, and then I need to know whether I'm inserting an X or an O. So I'm going to say function, and we're going to call this maybe make move. And what we're going to do is take in the turn and the board that we want to insert this move into. So the turn is going to be whether or not it's an X that we're placing or an O that we're placing, and the board will simply be this array that we're going to insert inside of. Now what we'll do is we'll start by collecting some input from the user. So we're going to say const row is equal to prompt. We'll write that in 1 second, and we're going to say enter row. Okay, so the user is going to give us the row, and then they're also going to give us the column. So let's put that here. I'm going to say const call and then enter call. Now, because we're using prompt, I do need to import that. So I'm going to say const prompt is equal to require and then prompt dash sync. And then we're going to call this. So now we're able to use that. Okay, so we're going to grab the row and the column, and just like before, what I want to do is convert these into numbers. So we're going to wrap this in the parseInt function. Now we're just going to assume that they give us valid numbers here. Although actually we can handle if they give us not a number. We'll look at that in a second. And again, remember, I haven't already written this, so I might change some things around. I'm trying to kind of show you my thought process as we build this out. So I have my board, and I want to just start by being able to insert X's and O's inside of here. So my idea is I'll ask the user to enter a row and a column that they want to insert their X or O into, so where they want to make their move. Okay. So we have the row and the column, but we need to check and make sure there's not already an element there that they give us a valid row and column. For example, if they say the row is 7 or something, well, we only have 3 rows, so that doesn't make sense, right? Same thing if they give us a row and column where there's already an element, like they can't place something there, override it. So what we're gonna do is we're gonna make sure, first of all, that the row and the column are within the range of the board. So we're gonna say, if the row is less than 1, or the row is greater than 3, then we can say console.log invalid row, okay? Otherwise, we can say else if, and then we can check the column. We can say if the column is less than 1, or the column is greater than 3, then we can say console.log invalid column. And also, while we're at it, we can check if these are nan. So I can say if is nan row or this, and I can say if is nan col or this. And let me just move this over. Okay, so what I'm doing is I'm setting up some if statements, right? So I'm going to say if it's not a number, or the row is less than 1, or the row is greater than 3, because we're going to get them to enter either 1, 2, or 3, right, for the valid rows, then we say it's invalid. And same thing with the column. And then otherwise, what we'd do here is we would insert the correct X or O into the correct position. Now, like before, we want to keep asking them to enter a row and column until they give us a valid row and column. So what we can do is set up a while loop here, and we can say while true, if I can get the indentation here correct, and then I can put all of this inside of here. Okay, so we're going to say while true, do all of this, and then in the else statement, we're going to break out. Okay, so what will happen now is we're going to check, all right, is the row valid? If it's not, then we're just going to print out invalid row, and then we would just ask them again to enter another row and column. Now, same thing for the column. We're going to check, okay, is the column valid? If it's not, then we're going to ask them again to enter a row and a column. Otherwise, we're going to break, but before we break, I'm going to insert into the board whatever the user's turn is. So I'm going to say board row -1, and then col -1 is equal to, and then this is going to be the turn. But I also need to make sure that there's not already something in the board. So let's check that as well. So let's make another else if, and we're going to say else if the board at row -1, col -1 does not equal the space, then we're going to say console.log invalid position. Okay, and we're going to fix our indentation. Okay, so I know I'm kind of doing a lot here, but we're checking if the row is valid, we're checking if the column's valid, and then we're looking inside the board at the row -1 and the column -1. The reason I'm subtracting 1 is because we start at the 0 index, but we're going to have them enter like 1 through 3. So if they enter row 1, really we want to use the row at index 0, so we need to subtract 1 from what they've entered. So I look at the board, at the row and the column position, and I make sure that it's equal to a empty string or a space. If it's not equal to that, then that means that there's something else there. So we say invalid position. Otherwise, we're okay to go ahead and enter in whatever their turn is to the board and then break. Okay, so what I want to do now is I want to say make move. I'm going to do a turn of X and pass my board, and then I'm going to console.log my board. Now I'm just going to repeat this 2 times, and I'm going to make this with an O, just so that I can test this out and see if it's working. Okay, so let's run our code and give this a test. So this is going to be project4.js, and it says enter a row. So let's try maybe -1 and 5. And you can see it says invalid row. Okay, so we need to enter another row. So let's go row to column 4. Okay, invalid column, that's working. Let's go to 2. Okay, now notice we enter now in the middle position our X. Now it's working for the O, so let's do maybe 2, 2, an invalid position because the X is already there. But if I do 1, 1, you can see that we enter O at position 1, 1. Okay, amazing. So that's working. Now what I want to do is I want to make it so that our turns alternate. So the first player is X, then the O player goes, and we keep alternating until the board is full. So let's remove this, and let's set up a variable to keep track of whose turn it is. So we're going to say let turn equal X, and then we'll kind of toggle the turn from X to O as we go through here. I'm then also going to create a variable called turn count, and we're going to make this equal to 0. And this is just going to keep track of how many turns have occurred. We're then going to say, while the turn count is less than, and this is going to be 9 because the maximum number of turns that we could do is 9, right? Because we have 9 positions we can enter in the board. And then I'm going to enter this while loop. Now the first thing I'll do is I'll just increment my turn count. So I'll just say turn count plus plus to add 1 to it so that we know we're kind of on the first turn. Now, actually, yeah, let's leave that there, but we're going to put that at the end of the while loop. I just like to add some kind of increment to make sure that I'm not going to get that infinite loop. Now what we'll do is we'll ask the user to make a move. So we're going to say make move, and then we're going to put the turn and the board. Okay, perfect. Then we're going to cycle the turn. So we're going to say if the turn is equal to X, then what we want to do is say turn is equal to O. And I think that's an O, not a 0. Let me just make sure because they kind of look the same. Okay. And then we'll say else turn is equal to X. So all this is doing is just swapping the turn between X and O. So if the turn is equal to X, switch it to O. If it's O, we switch it to X. Okay. And then we increment our turn count down here. Perfect. Now we also want to print out the board. So let's go and say console.log, and then we'll log the board. We're going to write a function that will make this look a little bit nicer for us, but that's the basics. Okay, so we have our making move. We're kind of cycling between the 2 turns, and let's see now if we can enter kind of 9 positions. So let's go 1, 1. Okay, let's go 1, 2. Let's go 1, 3. Let's go 2, 1, 2, 2. And you can see we're kind of switching between X and O. 2, 3, 3, 1. Okay, that's invalid. So we're going to go 3, 2, 3, 3. And you can see we have our X's and our O's being entered in the board. Amazing. So now let's make it so we print out our board a little bit nicer, because obviously this is kind of difficult to see and it doesn't look very nice. So let's make a new function and let's call this just print board. Okay, so if I can type correctly here, function print board. Okay, I'm really struggling here. All right, we're back. Function print board. We're going to take in the board and we're going to print it out. So in order to print the board, what I want to do is print kind of each symbol and then have like a separator like this so we can kind of see the rows and the columns. Now, in order to do that, I need to actually loop through my board. So I need to loop through each row and each column or each element inside of that. And that's going to involve using something known as a nested for loop. So we're going to do one for loop to print the row. So we're going to say for, and I'm going to say let, and we're going to go row equal 0. Or actually, let's go with I. Let I equal 0. We're going to say I is less than the board dot length. And then we're going to say I plus plus. Okay. Now what this is going to do is loop through all of the different rows that we have in our board. So we can say the const row is equal to board at index I, and that's going to give us this whole array. But now that we have this whole array, we want to print out each individual element in this row. So what we're going to do is make another for loop inside of here that now is going to loop through the row that we have. So now what we can do is we can say for, and we're going to use a different variable this time. So not I, I'm going to use J so that I can keep track of the row index as well as the column index. And we're going to say that's equal to 0. We're going to say J is less than, and then this is going to be board I dot length. And then we're going to say J plus plus. Now the reason why I did board I dot length here is because we're looping through this row. So actually we can just say row dot length to make that a little bit more clear. And we're just seeing, okay, how many elements are inside of this row. Now we know it's 3, but just to make it a bit more dynamic, we're going to use the actual length of the row we're looking at, and that's how we'll iterate through j. So now we have one variable I, and for every single time we iterate through our row, and for every single time we do this loop here, we're going to do this loop 3 times, or however many rows or how many columns, we have inside of the row. So this for loop inside of here is going to end up running 9 times because this for loop runs 3 times, and then this exterior for loop runs 3 times. So because this happens 3 times for each one of this, it ends up running 9 times. This is a concept a lot of people get confused with. I feel like I didn't explain that the best, but the point is this runs 3 times, right? Every single time this runs, what's inside of here is running. And since this for loop runs 3 times, whatever's inside of here ends up running 9 times because it's 3 times for 3 times. So you multiply them by each other and you get 9. Now you could keep going with multiple layers of for loops inside of each other, but this is how this works when we iterate through our board or a multi-dimensional array. Okay, now inside of here, what we need to do is print out the different symbols, but we want them all to be on the same line. So what we're actually going to do is create a string, and then once we finish creating that string, we're going to print it out. So what I'm going to do is say let, and we're going to say row string equal to an empty string. Then what we're going to do is the following. We are going to say row string, and we're going to say plus equals because we're just going to add a string to this, and we're going to add our row at index j. Now what this will do is add whatever element we have, so either it's a space or something like an x, it's going to add that to our string. However, we don't just want to add this, we actually want to add a little bit of spacing. So what we're going to say is the following. If, so we're going to put an if statement here, if j does not equal row.length minus 1, then we're going to say the row string plus equals, and we're going to add a space and a pipe. And then we're going to add another space as well. Now what this effectively is going to do is it's going to add a separator between the symbol that we just added and the next symbol that we'll add. Now the reason why I've done this if statement here is I only want to add this separator if we're not on the last element. The idea here is that if I'm on this position, right, so the last column, I don't want to add a separator after it. I only want to add separators in between. So that's why I'm checking to make sure that I'm not in that last position when I add this separator. So what we're doing is creating a string, and the string will look something like this. Okay, that's what we're going to get. So whatever's in the row, maybe it's a space, it'll look like this. If it's an element, it will look like this. Okay, so that's the string we're going to create. So then once we create the string after this for loop, we can just simply log it. So we can console.log the row string, and then we can console.log a separator for the row. So we're going to do this. Okay, but same thing here. I only want to log this separator if I'm not on the last row, because I don't want to have a separator like this, right? I only want to have one in between the different rows. So same thing as before, but this time we're going to use the I variable because this keeps track of the row and this keeps track of the column. And we're going to say if I does not equal, and then this is going to be the length of the board. So board.length minus 1. The reason why I use this dot length minus 1 is that's the last possible element that we have inside of our board. Now the reason I do board.length minus 1 is that this will give me the last index that I have inside of my board or inside of the array that I'm looping through. So if in theory we made this larger in the future, then this code would still work. So it's better practice than writing, for example, 2, because if you do 2, then this only works when the board has 3 elements inside of it. Now we know that's going to be the case, but here I like to use the dot length minus 1 because that dynamically gives me access to the last element. Okay, so now let's use this print board function and see if this works. Maybe I made a mistake. Let's see. So rather than console.logging the board, I'm going to print the board, and we'll just pass the board that we want to print. So now I can go up here and I can run, and we're going to say enter row, and let's go maybe 2, 1. And you see that we get our board actually looks pretty good. So now let's go maybe 3, 3, and you see that the O gets entered. Perfect. Now I'm just going to clean this up a little bit so it's a bit easier to read. To do that, I'm going to add a console.log, and we'll do that, I guess, after we print the board. So you'll make a move, it will then print the board, and I also just want to print the board one time and have a console.log before we start, just so you can see an empty board. You can make your move, then we'll print out the board, and then we'll add some space before the next person goes. Okay, another thing I want to do really quickly is I just want to add a few more of these. So I'm going to add one more dash just so that we get a little bit of a nicer formatted board. Okay, so let's run this again and make sure it looks a bit better. Okay, so you can see now we have a space, so it's a little bit easier to read. We can go 3, 3. Okay, that gets entered. 2, 1. Okay, 3, 2. You get the idea. Perfect. Okay, so that works nicely. And one more thing I'll add now is I'll just say whose turn it is. So I'm going to console.log an empty string, and then I'm going to say console.log. And actually, let's do that at the top of the program here. We'll say, maybe, how should we do this? We'll say it is the, and then turn, player's turn. So this will just print out whatever the turn is, whether it's X or O, so we know whose turn it is. And actually, we can just go turn, player's turn, like this, just so that it's not super long. Okay, so that is it in terms of printing the board and making a move. But obviously, we need to check if someone wins. So how do we know if someone wins? Well, we need to check all of the lines that potentially exist here. So we need to see if any of the rows are filled. We need to see if any of the columns are filled, and we need to check the 2 diagonals. Now, there's multiple ways that we can go about writing this, but I like to implement something that looks like this. So I'm going to write a function and kind of show you one way to do this. Again, there's multiple ways that we can do it. So I'm going to say function check win. Now, when we check the win, we're just going to take in the board. Now, inside of check win, what I'm going to do is write an array that contains all of the positions of lines that could potentially win. So you'll see what I mean here, but I'm going to make an array. I'm going to call this lines. Now, inside of this array, I'm going to have arrays, and inside of those arrays, I'm going to have more arrays, just so I can kind of show you how this works. Now, what we'll start by checking is row 0, and what we're going to do is we're going to put the positions of all of the elements that would need to be the same in order for a user to win. So we're going to say lines is equal to, we have an array, and the first array inside of here is one line, and that array is going to be 0, 0, 0, 1, and 0, 2. Now, what this is representing is these 3 positions, which is one line that could make you win. So hopefully you get the idea, but I'm going to write all of the lines that could allow you to win, and then I'm going to check all of these lines and see if they're all filled with the same thing, because if they are, that means you win. Okay, so we have this first line. That's row 0. Now let's write the second line. So for the second line, we're going to check row 1. So it's going to be the same thing, but now we're going to have row 1. Okay, so again, like 1, 0 is this, 1, 1 is this, 1, 2 is this, so it's the 3 positions that need to be the same in order for a win. We're going to call this row 1. Now, you don't have to add the comment. I'm just trying to make it more clear for you. So we're going to go 2, 0, 2, 1, and we have 8 lines in total that we need to write out. Keep in mind, there's many ways to do this, but this is just one way that I want to show you because it's common in certain programs. So now that we do the rows, we're going to do the columns. So now we're just going to switch it a little bit. It's going to go 0, 0. And then we need to do this one. So we're going to have 1, 0, and then 2, 0. Okay, that's going to be column 0. Now we need to make sure that we have our commas, because if we don't have our commas, we're going to get an error. So let's add those. And now we are going to have the next one, which is going to be 1, 1, or sorry, 1, is it 1, 1? No, it's going to be 0, 1. And then it's going to be 1, 1. And then it's going to be 2, 1. I think that's correct. Yeah, because we're changing, or we're keeping the column the same, but the rows are being changed. Okay. Column 1 requires a little bit of thinking here to write all of these out. Next, this is going to be 0, 2, 1, 2, and 2, 2. Okay. And that's going to be our column 2. Now we need to do the diagonals. So for the first diagonal, we can go from up to down. So up to down will look like this: 0, 0, 1, 1, and 2, 2. Okay, so that's going to be, I guess, left to right, diagonal. Okay, I mean, I guess both of them you could say are left to right. Let's just go diagonal 1. Okay, and now let's add the other diagonal. So for the other diagonal, we're going to start here. So that's going to be at 0, 2. and then 1, 1. And then we're going to be in row 2, position 0. I think that makes sense. So yeah, that's 0, 2, 1, 1, 2, 0. Okay, and this will be diagonal 2. So now we have all of the lines that we could potentially win on. So I'm just going to take in one more parameter here, which is whatever the current turn is. And what I'm going to do is I'm going to essentially check if they fulfill any of this line. So I'm going to say for, and this is going to be let line of lines. So I'm looping through each of the lines. Now for each line, I'm going to check all of the positions that we have, and I'm going to see if they're equal to the turn. So we're going to make a variable, and we're going to say let win equal true. I'm then going to say for, and we're going to go position. So let position of line. Now, what that's going to do is it's going to loop through all of these arrays that are inside of this array, which is the line that we're currently looking at. So again, kind of a nested for loop, right? The first for loop is looping through all of the lines, and the second for loop is looping through all of our positions. So now we need to get the position. So we're going to say const, and I'm going to do something you probably haven't seen before. I'm going to do row call is equal to pause. Now, what this will do is it will simply assign the first element to row and the second element to call. So this is kind of a shorthand you can use when you want to extract the elements from an array, because here we have an array with 2 elements, and we know that corresponds with the row and the column. So what we're going to do is we're going to say if the, and this is going to be a line, or sorry, not line, if the board at the row column does not equal our turn, then we're going to say win equals false. And we're going to put this inside of a set of square brackets or curly braces, sorry. And we're going to break out of this for loop. So what I'm doing is I'm saying, okay, we're going to assume that we've fulfilled the current line. Then we're going to go and look through each position in the line. We're going to grab the row and the column, and we're going to check if the row and the column, so if the element that's in the board at that position is equal to the player's current turn. If it's not, that means that this line is not fulfilled. So we're going to say win is equal to false, and we're going to break out. Now what we can do here is we can say if win, and notice this is outside of this for loop, and here, if win, we can just return true, okay? Otherwise, we're going to return false. Now let's look at this return. The reason why I can do this is because if this win variable is still true after I checked the line, it means that I've fulfilled one of the lines because we didn't set it to false. So it means that all of these elements were correct. They were the player's turn. So we've fulfilled a line, we've completed a line, so we can just return true. Now, if it's not true, we just go and we check the next line. We just continue checking. Now, if we get to the end of this for loop and we've checked every single line and none of them are fulfilled, so win never is true, it always gets set to false, that means that we haven't yet won and we simply return false. So now this will check the win for the board and for a player's turn. So what I can do is call this after the player makes a move. So we can print the board, we can console.log, and then we can say const win equals check win. And then we can pass the board and we can pass the current turn. Now, if the player wins at this point, if win is true, then the game is over and we can print that out. So we're going to say if win, then we can say console.log, and we're going to say turn has won, and then we're going to break. Okay, so if they win, we just break out of the for loop. And that should actually be it. Let's kind of take a quick look at this, and we can run the code and test it out. So we have a make move function. We know how that works. We simply check if the move is valid, and we insert this into the board. We then have a print board where we're doing some, I wouldn't say fancy, but at least some more complex stuff to create this row string, and then print out a string that looks nice for the board. And then we have our check win function, which checks all of the lines and sees if all of the values in the line is equal to the player's turn. If that's the case, they won. Now, what we're doing is we're checking if we win after every single move. So after we make the move, we check if the player, when they insert in that position, has won. If they won, then we can go ahead and break. Okay, the only thing we're not handling is a tie, but we'll do that in 1 second. So let's go to project 4 and let's try to win. So it's the X player's turn. Let's go in the middle, so 2-2. Okay, O player's turn. Let's go maybe in the top corner, so 1-1. Okay, for X, let's go in maybe 1-2. Okay, for O, I'm not going to block because I want to win. So let's go in maybe row 2, column 1. Okay, and then let's go in, what is this, 3 and 2. And there we go, it says X has 1 because we fulfilled this line. Now we could test all of the lines if we want to, but for now I'm just gonna leave it as is because we know that this is working and I just know that the code is gonna work properly. But really, if you're writing this on your own, you should test all of the lines to make sure it works. Now the only thing we haven't handled is a tie. So let's see what happens if we tie. So let's go 1, 1, let's go 2, 2, let's go, what do we wanna do here? Maybe 1, 3. Let's go in the middle. So this is going to be 1, 2. Why is this difficult to figure out? Okay, I need to block that position. So it's going to be 3, 2. Then let's go down here. So we're going to go into 1. Okay, we need to block that. So let's go into 3. Okay, we need to block now. So we're going to go in 3, 3. And then we're going to go in 3, 1. Okay, so at this point we tied, so we didn't get any player winning. So what I can do if I want to show that is I can just say console.log tie game. Okay, now the reason why tie game works here is because if we get to the end of 9 turns and we haven't yet won, then we must have tied, right? That's just the logic. So we must have tied, so we can just print tie game if we exit the while loop. However, actually, I need to think about something here. We only want to do this if the turn count was equal to 9. So we're going to say if the turn count is equal to 9, then we can print out the tie game. And the reason why we'll do that is because we only want to show tie game if all 9 turns were completed and no one won. And actually that makes me think this might not necessarily work because what's going to happen is someone could win on the 9th turn. So this is me kind of thinking through and, making some mistakes. But what I can do is make a variable. I can say, let's do it up here, let 1 like this. And what we'll do is just change this to say win. Let's make this win. So now I have this variable win, which I've defined, and we can just make this equal to false to start. Okay, so we're going to say currently no one's won. Now we're going to keep updating this variable, and eventually at some point, if someone wins, it will become equal to true. Notice I removed the const because now I'm using this one here. Then we say, well, if someone's won, let's print this out. Otherwise, we'll go down here. Almost set. Then we say if someone's won, okay, go ahead and print this out and then break. And then down here, I can just say if not win, like that. So if we haven't won, so if 1 is still equal to false, once we get out of this loop, then we can just log tie game. Okay, so that should work for us. So let's see if this works for the tie game. So let's go 1, 1, let's go 2, 1, let's go 3, 1. Okay, let's go 2, 2. We need to block here, so it's going to be 2, 3. Okay, let's go. I think I've set it up so that I win no matter what. Maybe. Whose player is it? Okay, let's go 1, 3. All right, let's go with 3, 2. Okay, we need to block, so 3, 3. And then we're going to go 1, 2. Okay, and then it says tie game. Perfect. So that is working. What we're going to do is have a large bank of quiz questions, which we're going to store in a file. Specifically, we're going to use something called JSON, which I'll show you in a second. Now, what we'll do is we'll randomly select a bunch of questions from that file and then display them. Then what we'll do is we'll present them to the user and we'll time how long it takes for the user to answer all of the questions, and we'll give them their score to see how many they got correct. So let's start building this out. And the first thing I want to do is get a bunch of quiz questions. Now, what we're going to do is make a new file. And this file is going to be questions.json. Now, JSON stands for JavaScript Object Notation. And inside of here, we can write an object pretty much just like we did in JavaScript. So what I'm going to do is paste in a bunch of questions here, and I'll show you what the format looks like and how you can do the same. So you can see I have this large file here, and notice that what I've done is I've made a key called questions. Now, when we're using JSON rather than in JavaScript, we need to have double quotation marks around all of our property values. So we have questions, this is a property, and then what I have is a big list or an array, and inside of the array, I have a bunch of objects. Now, these objects have the question, so you can see the question is here. It then has different options, so these are the kind of multiple choice answers, or I guess options or choices. And then you have the answer, which in this case here for this question is Jupiter. And I have a bunch of questions. If you want these questions, you can simply download them from the link in the description. You can go to GitHub and find this file, or you can use something like ChatGPT to generate this sample questions bank. Now that's exactly what I've done. I just went to ChatGPT, I gave it something that looked like this, and I said, hey, generate a bunch of questions in this format that I could save in a JSON file. It then gave me this. So again, JSON, JavaScript object notation. Works the exact same as in JavaScript, except you need double quotation marks on all of your property values. You can't use single quotes, it needs to be double quotes. So that's what I've done. I have my opening brace, my closing brace, I have a key, which is questions, associated with an array. And then in the array, I have a bunch of questions that follow this format. So we're going to start with that, and I'm going to show you how we can load this content into our project so that we can store all of the questions here, and then we just need to change this file if we want to add new questions. Okay, so let's go over to project 5. Now I've made this new file, and what we're going to do here is start by kind of importing prompt sync. So we're going to say that's Python. We're going to say const prompt is equal to require, and let's go here, and this is going to be prompt dash sync, and then we're going to call this. Then we're going to import something known as the file system. So we're going to say const fs, standing for file system, is equal to require, and we're going to bring in fs. Now this allows us to actually load in files, so I'm going to show you how we do that. So we're going to make a function called load questions. Now what we're going to do inside of here is we're going to use a kind of new block that we haven't seen yet, which is a try except block or a try catch block. So we're going to say try and then catch, and I'm going to discuss what this does. So the try catch here is something that we can use to attempt to run a block of code, and if it fails, we can handle any exception that occurs. So what we're going to do is attempt to load a file, but if an error happens when we're loading that file, rather than crashing our program and showing an error message, we can handle that error. So what we can do is any code we want to attempt, and if we're not sure if it's going to work or not, we put it inside of this try block. Then we can have this catch block afterwards, and this catch block will be triggered only if an error occurs. So if an error happens in here, then the error will be handled here inside of the catch, and we can do something to take care of it. Now this will actually be whatever the error is that occurred, so we can check the error, look for something specific, or we could just print it out. So for example, I could say console, let me do this, if I can find the O, console.log, error occurred, loading file, and then I can simply print out E like this, and that's just going to show me what the error message is, but it's not going to crash my program. Okay, then from here, I'm just going to return an empty array, because if we couldn't load the questions, we're just going to return an empty array. So we have this try catch. Okay, again, the catch is kind of what happens if something goes wrong inside of the try, and inside of the try now, what we'll do is we'll attempt to load our file. So we're going to say const data is equal to fs.read file sync. Okay, this is going to read in a file, and what we can do is say questions.json, and then we can specify the encoding format, which is UTF-8. Don't worry too much about this, but this is just the essentially way that this file is encoded so that JavaScript knows how to read it in. Okay, so we put the name of the file, and it's important that this file is in the same directory where our project file is. So for example, if this was on our desktop or something, not inside of the same directory, we wouldn't be able to read it. Well, we could, but we'd have to change this code. So we need to have it in the same directory. So we have project 5, and then questions.json is in that same directory or folder, which is why we're able to read it. Okay, so we're going to attempt to read it, but this could potentially break. Like something could go wrong here if the file doesn't exist or it's corrupted, and that's why we have the catch statement so we can handle an error that occurs. Okay, then we're going to say const questions is equal to, and this is going to be JSON.parse, and we're going to parse the data and attempt to grab the questions. Now, like I said, this is JSON, which stands for JavaScript Object Notation. So what we need to do is we need to take this JSON file and convert this into a JavaScript object. So that's exactly what this does. It takes what is a string, which is our data when we read the file, and then it uses JSON.parse to convert this to a JavaScript object. Now that it's a JavaScript object, I can use it just like any other JavaScript object, and I can access this questions property, which gives me the array containing all of my questions. Then I can simply go here and return questions. Okay, perfect. So that's how I load my questions. So now we're going to test this out by saying const questions is equal to load questions, and we're going to go console.log and then questions like that. Okay, so now let's test our code and make sure this works. So we're going to say node, and then this is project5.js, and you can see that it prints out all of my different questions. Amazing. Now the next thing that I want to do is I want to randomize the order of my questions. So rather than having them in the same order, I want to randomly select a few of them. So what we're going to do is make a function called getRandomQuestions. Okay, now what this is going to take in is our questions and the num of questions that we want. Okay, number of questions, sorry. So maybe we're going to get 3 questions, 5 questions, 7 questions, 10 questions, doesn't matter, but we want to randomly collect a certain amount of them. Okay, so in order to do this, the first thing we need to check is to make sure the number of questions passed is not greater than the number of questions that we have. So we're going to say if the num questions is greater than questions.length, then what we're going to do is say the number of questions is equal to questions.length. Okay, the reason why we're doing this is that if you try to get more questions than we have, well, we don't have that many, so we just need to set this equal to however many questions we actually do have. Okay, then what we're going to do is we're going to shuffle this array, and shuffling the array, what that will do is essentially randomize the order. Now to do that, we're going to say const, and this is shuffled, is going to be equal to our questions dot, and this is going to be sort. Now inside of sort, I'm going to pass something that we haven't yet seen, which is called an arrow function. Now an arrow function looks like this. We have a set of parentheses, we have an arrow, so an equal sign and then a greater than sign, and then we have a set of curly braces. Now the curly braces is the body of the function, so like this is here, like, you know, what we want to do this is inside of the curly braces, and the set of parentheses here is where we accept our different parameters. So again, it's literally the exact same thing as writing a function like this. There's a few minor differences, but it's kind of a nice way to embed a function when we need to pass that as an argument to a function. I know that's a little bit weird and kind of some jargon that I threw out there, but the way the dot sort works is it takes a function that defines how we're going to sort the array. Okay, so we say questions.sort, and then we pass what's known as a sorting function. So for the sorting function, what we take is, for the sorting function, what we can do is simply say return 0.5, and then this is going to be minus math.random. Now, this involves understanding how sort works. So sort in JavaScript is a bit different than in other languages. Typically, what you accept in sort is 2 parameters, a parameter A and a parameter B. Now, the way that this works is it will compare different values in the array, and it will store them as A and B in this function. So pretty much what will happen is if we have like a big array and we have, A, B, C, D, etc., what will happen is A will get compared to B, B will get compared to C, C will get compared to D, and all of the elements will get compared against each other. In some order. I don't want to explain exactly how the sorting algorithm works, but the idea is that we're going to write how we should compare these elements against each other. So A and B are 2 elements that we're comparing. Now, if we return a positive number from this function, that means that A is greater than B. If we return a negative number, that means that B is greater than A. And if we return 0, it means that they're the same. I know it seems a little bit weird, but the sort will take that positive, negative, or 0 and use that to sort the array in ascending order. We can also have it sort in descending order based on how we write this. So what I'm doing right now is I'm going to return randomly a positive or a negative number. So I don't need to accept A or B because I'm not actually going to use them. And what I'm going to do is I'm simply going to take 0.5 and I'm going to subtract that from math.random. Now math.random is going to be equal to a number between 0 and 1. So if the number is greater than 0.5, I'm going to get a negative number. If it's less than 0.5, I'm going to get a positive number. Now what this effectively will do for me is randomly sort the values, because I don't care about what the values actually are. For every single value, I simply return a random number that's positive or negative. So I understand it's a little bit confusing, but this is a simple way to do like a randomized sort. Again, I don't want to get too far into the sort algorithm and arrow functions and some more complex stuff, but it is somewhat required to understand what's going on. Anyways, the point is this is shuffling and sorting the array for us. So now that we have the sorted array, what we want to do is just take however many number of questions from that array. So what we can do is say return, and then we're going to say shuffled, and we're going to say dot slice, which is a new method we haven't seen, and we're going to slice from 0 to the number of questions. Now the way the dot slice works is it gives us a slice or a portion of the array. It starts at this index and it goes to this index but does not include it. So if I slice 0 to, for example, 3, that gives me the first 3 elements: index 0, index 1, and index 2. Okay, if I sliced from like 2 to the number of questions, then that gives me index 2, and then whatever the number of question is. So it goes like 2, 3. If the number of questions was 4, then it would just return index 2 and index 3. So it does not include the number of questions index, but when we go 0 to number of questions, that effectively gives us the first number of questions element in the array. Let me do a better example because I know it's a bit confusing. Let's say that we do a slice of 0 to 2 on this. If we do that, we get 1 and 2. If we do a slice of 1 to 4, then we're going to get index 1, 2, and 3, and we're going to stop at but not include 4. Okay, so that's how the slicing works. So let's go back to what we had, which is 0 and number of questions. So that gives us the number of questions from our randomized array. Okay, so now let's test this out. So we're going to say const random questions is equal to, and this is going to be get random questions, and then we're going to pass the questions, and let's just pass maybe 4, and then we can console.log the random questions. Okay, so let's test this, and you see that we get 1, 2, 3, 4 random questions. If we change this to just be maybe 2, and we run this now, you'll see that we just get 2 random questions. And if we keep running this, you'll see we get different questions because it's randomized. Okay, amazing. So that is that. We now have the questions, we have the random questions, but we need a way to display the questions and see if the user got them correct. So let's write a function that asks the user a question. We're going to say function ask question, and we're going to take in a question. Okay, now what we're going to do is display the question and then display the different options for the question and ask the user to enter a valid option. So we're going to say console.log, and what we'll do is say question dot question. Okay, because again, we have each question, which is one of these objects, and then we have the question, which is some text. So we're going to display that question, and then we're going to display the options. So we're going to say for, and we're going to go with let option of question dot options. Okay, now actually we're not going to do that because I need to know the number so that we can have the index of each question. So I'm going to say for let I equal 0, I is less than question dot options, and then I plus plus. We're going to say const option is equal to question dot options at index I, and then we're going to print out the index and then the option so that we can see we have, option 1, option 2, option 3, etc. Okay, so how are we going to do that? Well, I'm going to show you something new that we haven't yet seen. So I'm going to say console.log, and this time I'm going to use my backticks. So rather than using the single quotes, the double quotes, I'm using backticks, which are on the same key as the tilde, typically on the top left-hand side of your keyboard underneath the escape key. Now, when we use these backticks, it allows us to embed variables inside of a string. So what I can do is put a $sign and put a set of curly braces. When I do this, this denotes that I'm going to put a variable directly inside of here. So this means I don't need to use kind of the plus sign notation or string concatenation. I can instead directly embed variables inside of the string. So I'm going to say I plus 1, and I'm adding 1 because I don't want to show option 0. I want to start by listing option 1. I'm then going to do a dot, and then I'm going to embed another variable, and this is going to be the option. Okay, so I get the option, and then I have the index associated with that option. I'm just adding 1 to it, and I'm going to list it and display that out. Okay, so before we go any further, let's just test this. We're going to say const ask, or sorry, not const, we're going to say ask question. Okay, and we're going to pass random questions at index 0 just to see if this works properly. Okay, so let's go here and run, and it says, what is the hardest natural substance on Earth? Okay, and what is the issue here? Question.options. For some reason, this didn't actually run. That's weird to me. So maybe we called this something else. Options, and we have question.options. Okay, so what could be the issue here? Let's try to debug this together. So we have random questions 0. We ask the question by printing out console.log question.question. And then we say let I equal 0. I is less than question.options, I plus plus. We then get the option and we print it. But for some reason, this for loop's not running because it's not showing us any options. Let's run this one more time. And yeah, same thing, we're getting this issue here. So I is less than question.options. Aha, that's because we need to add dot length. So I forgot to add the dot length. So we're comparing I to question.options, which is kind of weird, and that didn't work. So if we add the length, then we get the number of options that we have, and that should fix the problem. So let's try this now. And there you go. We can see now that we get the question, and we can ask multiple questions. Perfect. So now let's try to get the user's answer. So we're going to get some input. So we're going to say const, and we'll say choice is equal to prompt, and we'll say enter the number maybe. Okay, so we're going to ask the user to enter the number, and we're just going to check if it's equal to the correct option. So the correct option is going to be found in the answer. So we need to essentially take whatever the user's index is that they inputted, check what choice it was, and then compare that to the answer. So we're going to say const choice value is equal to, and we need to first parse this as an int. Okay, so we're going to parse this as an int, and then we're going to say that this is going to be question dot options, and then we're going to find the choice minus 1. Okay, so question dot options and then choice minus 1. That looks good. And then we need to compare that to the correct answer. So we're going to say const correct is equal to the choice value. And this is going to be equal to the question dot answer. Okay, so there's a few more things that we need to add, but for now, if the user gives us a valid number, so 1 through 4, what we do is convert that to an int, and then we take whatever the number is that they give us, so whether it's 4, 3, whatever, and we subtract 1 to change the choice that they selected to the correct corresponding index. Because since we're adding 1 here, we need to subtract 1 when the user types in a value. Then we actually get whatever that option is, so the value of it, and we compare that to the correct answer. Okay, the only thing we need to add here is we need to make sure they do give us a valid number, because if they don't, then this line will give us an issue. So what we're going to do is the following. We're going to say if is nan choice, or choice is less than 1, or choice is greater than, and this will be the question. So let's do this. If we can type this correctly, dot options dot length, then that means that this was invalid. So we are going to say console.log, and we'll say invalid, incorrect choice. And then we are going to return false. So my idea is from this function, we'll return false if the user got the answer wrong and true if they got it correct. So now what I can do is rather than having just correct here, I can simply return this expression, which will either be true or false, depending on if they get it right or wrong. And then down here, what I can do is keep track of the number of correct answers. Okay, so now we've asked the question, and I'm just going to say const correct is equal to this. And I'm going to say console.log correct, just so we can see if they got it right or wrong. Okay, so we're printing out the question, we're printing out the options, we're converting the user's choice to a number, we're making sure that number is valid so that it's within the bounds of the choices and it's not a number. And if it's wrong, we're just gonna say, okay, it's invalid choice and return false. Otherwise, we're gonna check if it's correct. So we're gonna get the choice value, compare that to the answer. If it's correct, we return true. If it's false, or if it's incorrect, we return false. Okay, so let's run this now and let's enter the year. I think it's 1912, and we get false. Okay, so I guess it wasn't 1912. Let's go. Oh, I entered 1912 when I needed to enter the correct choice. What does it say? Which planet is close to the sun? I don't know this. Let's go with 2. Okay, false. Let's try to get one correct. Which is the largest planet? Jupiter, right? True. Okay, and then we got that one correct. Great. You're going to see I'm quite bad at these quiz questions, but that's okay. All right, so this is working. We have our 3 functions. We load the question, we get random questions, and then we ask the question. And we just tested that out down here with a few lines of code. Now what we want to do is we want to actually kind of play the game. So we need like a while loop that's going to go through and run through all of our questions. So let's do that. Let's get rid of these lines and let's remove the number here. And let's actually start by asking the user to enter a number of questions. So we're going to say const, and we'll say num questions is equal to a prompt, and we'll say enter the number of questions. Okay, now we're just going to assume that they give us valid input here. Okay, so we're going to say parse int, and then what we're going to do is pass that to our random questions. Now we could validate this if we want, but I'm not going to do that because I've showed you how to do that many times now. Okay, so we have random questions now generated based on what the user gives us. Now what I want to do is track how many they get correct. So I'm going to say let correct equal 0. What I also want to do is track how long it takes them to answer this. So I'm going to start a timer. Now to start a timer, I'm going to say const start time is equal to, and I'm going to grab the current date. To do that, I can say date dot now. Now this is going to give me the current time, and what I can do is simply check when they finish and subtract it from this, and it will give me the number of seconds that have elapsed. Okay, so we have that, we have the start time, we have the number of correct, and now we need to loop through all of their questions. So we're going to say for, and we'll say let question of random questions, because we're going to loop through all of the questions that they have, and we're going to start asking it to them. So we're going to say correct, or const is correct, is equal to, and then this is going to be ask question, and then we'll pass the question. Okay, then we're going to say if is correct, then what we will do is we'll say correct plus plus. So if they got this question correct, add 1 to the number of correct questions. Then at the bottom here, we're going to calculate the time. So we're going to say const finish time is equal to, or we can say, I guess, total time is equal to the date dot now, which will be greater than the start date minus the start time. So what this will do is take the current time and subtract that from when we started, and then that will give us the total amount of time elapsed. So now we can say console.log, and we can say correct colon, and then show the correct count. We could say console.log time, and we can show the total time. And then if we want, we can show maybe their average. So we can say console.log, maybe score, and then we can show a percent. So if we want to show a percent, what we can do is we can take the correct, we can divide that by the number of questions, and then we can multiply that by 100. Okay, so let's do this. And then let's take all of this and let's round it so that we get a nice even value. So we'll say math.round like that. And we'll just round this to 2 decimal places. So I know this looks weird, but what I have is correct over number of questions. We're taking that and multiplying it by 100. We're rounding that as the first argument to math.round. And then we're rounding this to 2 decimal places. I believe that's how round works. Actually, no, sorry, I need to remove this. That's how it works in Python, but we just take this number and we'll round it. And then we can add a percent sign. So if we want to add a percent sign, we can just say plus the string percent, and that should work. Okay, there's probably some things that I'm missing here, but I think that's okay for now. And let's just do something and add a console.log here, just so there's a bit of space when we ask the question. Okay, so all I did here is write these lines of code. We're tracking how many are correct. We're tracking the start time. We're looping through all of the random questions that we have. For each question, we're going to ask it and check if it's correct. We're then going to place like kind of a separator so that we can separate the questions, and we are going to check if it's correct and then increment the correct variable. Okay, so let's try this. Enter number of questions. Let's go with 4. Which planet is closest to the sun? I don't know if, did we get this one correct? What did I put? Mercury? Okay. In which year did the Titanic sink? Let's go 2. What is the hardest natural substance? Diamonds. Who wrote To Kill a Mockingbird? I have no idea who wrote this. Let's go 4. And it says we got 3 correct. The time was this, which is in milliseconds. So I'm going to show you how we convert that to seconds. And we scored 75%. Cool. Okay, so let's convert this, which is in milliseconds, to be seconds. It should be 18.3 seconds. To do that, we can divide it by 1,000. So we can take the total time and divide it by 1,000. And same thing, we can round this. So we can say math.round the total time over 1,000. And let's run this again. Okay, let's just go 2 questions this time. What is the chemical symbol for O? Pretty sure that's oxygen. The planet closest to the sun, did we get that right? I don't know. Let's go Mercury. And we got 2 correct. The time was 9 and we scored 100%. Now we might just want to put seconds. So what we can do is first, let's remove these spaces so that it doesn't look weird. And let's just go plus an S. So if we do plus S here, that'll just represent seconds. Let's run this one more time. Okay, to what is the capital of Canada? Ottawa. I lived in Canada, so I know that. What year did the Titanic sink? 1912. Correct 2 time 7 seconds and score 100%. All right, so let's dive into the project. Now, the first thing to mention here is I do not at all support gambling. I'm just doing this project because it's a really good one for beginners and to really dive into code and kind of see how to create a complete project. But please do not gamble. I don't gamble myself, and I would never encourage anyone to do that. Regardless, I'm going to quickly explain to you how a slot machine works in case you haven't seen it before. If you already understand, feel free to skip through. But here we're going to do like a simplified version of one just to make it a bit easier for us. So I have the whiteboard in front of me, and I'm just going to draw out in a very messy manner here kind of the idea behind what we're creating. So we're going to imagine here that we have 3 reels. Now in each of the reels, we're going to have 3 symbols. So maybe we have something like A, B, C, A, B, C, and then maybe we just do A, A, A. Now excuse my handwriting here, this is with my mouse. Now what we're going to have here for our slot machine is 3 lines. Now whenever you play a slot machine, there's a certain number of lines that you can win on. Usually it's like 80 lines or 60 lines or a stupid amount. In our case, we're just going to do 3, and they're just going to be each row. Okay, so these are the 3 possible lines that you could win on. Now, you only win when you have 3 symbols that match in a row. So in this case, we would have a win, but we would not have a win in either of these 2 rows because we don't have 3 symbols. Now, each symbol will have a varying multiplier. So if I bet, say, $1 on the line and the symbol had a multiplier of 5, then that would mean that we won $5 on that specific line. And we're going to allow the user to bet on a certain number of lines. So if they bet on 1 line, they just bet on this. So they need to have something in this section. If they bet on 2 lines, then they're going to be betting on both of these lines. If they bet on 3 lines, then they bet on all 3 of these. And whatever bet amount they make is going to be multiplied by the number of lines that they bet on. So if they bet $1 on 3 lines, then they bet $3 in total. And if they get symbols in any one of the rows, then they're going to win a certain amount of money based on what the multiplier is for that symbol. All right, so let's dive into it here. First, we just have a little bit of setup. I'm using Node.js, so make sure you download Node.js. I can leave a link for that in the description. And then I'm using Visual Studio Code. Feel free to write your code wherever you want. Now, I've opened up a folder here on my desktop where I'm going to be writing the code. And the first thing I'm going to do is create a new file. So I'm going to say project.js. This is my JavaScript file. Then I need to set up a kind of node directory here because I'm going to install one package, which is going to allow us to get some user input. So I'm going to go here to my terminal, Notice I'm inside of the directory where I'm going to be working, and I'm going to type npm init. Now, this command will only work once you've installed Node.js. If for some reason it's not working and you installed Node.js, then restart VS Code or your terminal, or restart your computer, come back in, and then the command hopefully should work for you. Okay, so when I type npm init, it's going to walk me through kind of setting up all of this information. You can fill it in if you want, but you don't have to. I'm just going to click enter through all of this. And now you're going to see that we have a package.json file inside of our directory. Now that we have that, I have the ability to install my package, which I need, which is called prompt and then sync. So npm I prompt-sync. This is what we're going to use to collect user input. So go ahead and run that command. Again, just installing that package. To do this, again, you need Node.js installed, need to be in some directory. And whenever you're in the directory, type npm init, npm I or npm install prompt sync, have some JavaScript file ready to go. And now we can start writing our code. So the first thing I'm going to show you how to do here in JavaScript is collect user input. But before I do that, I quickly want to explain kind of the steps that we need to go through so that we understand what it is that we're going to be building before we start writing any code. This is an important step whenever you're working on a project. You want to kind of break it down into some subcomponents so that you know what it is that you actually have to do, and then you can prioritize those tasks. So let's do some comments here. I keep thinking I'm in Python using the pound symbol. But the first thing that we need to do here when we're setting up a slot machine is we need to know how much money the user has to play with. They're going to deposit or put some money into the slot machine. So the first thing we need to do is deposit some money. Okay. Next thing we need to do is determine how much the user is betting on the slot machine. So we need to collect a bet amount. But before we do that, before we determine the bet, we probably need to know the number of lines that they want to bet on. Do they want to bet on 1 line, 2 line, or all of the lines, which in our case is 3. So I'm going to make another comment here to determine number of lines to bet on. Okay, and then 3 is collect the bet amount. Now, next, we need to actually roll the slot machine or spin the slot machine and then see if the user won. So we're going to say spin the slot machine. And then 5, check if the user won. And then lastly, after we check if they win, we need to then give them the money, right? So give the user their winnings, or in the case where they lost, then we would take their bet, right? And then lastly, we probably need to play again or handle a situation where the user has no money left. Okay, so those are our 7 steps. So what I like to do now that I have these steps and I've kind of thought through the program a little bit is start going through them one by one. It doesn't really matter the order that I complete them in, but kind of creating little pieces of code or functions that implement each step or each thing that we're doing. So let's start with step 1. That kind of makes sense, where we're going to collect a deposit from the user. So to collect the deposit, we're going to create a function. A function is a reusable block of code that you can call that's going to do something for you. So don't worry about it too much if you haven't seen functions before. There's 2 ways to create them in JavaScript. The first way is to write function and then to give the function a name. In our case, the name of the function is going to be, if I could spell this correctly, deposit. Then you're going to do 2 parentheses like this. Any arguments or parameters you have for the function are going to go inside of here. These are things that the function may need to handle that you're going to pass in to the function for it to use while it's doing some code. In our case, we don't have any of those. We just want to get a deposit. And then we're going to open 2 curly braces like this, or open a curly brace and close a curly brace. And then inside of these is going to be the body of our function, which will run when we call this function. So I can call the function by writing the name of the function and then putting 2 parentheses like this. That's going to call the function, trigger it to run. Function's going to do whatever is inside of the curly braces or the body of the function. And then we have the ability to return something from the function. So for example, I could return 1. If I return that, it's going to be returned to where the function was called. So in this case, if I had a variable and I said const x equals deposit, then what that means is that if I return 1, the variable x is going to be equal to 1 because that's what this function call returned. Hopefully that makes sense, but that is your 20-second lesson on how functions work. Now, this is the first way to make a function. The next way to make a function is to do the ES6 style, which is to write a variable. So in this case, I'm going to do const, which stands for constant, meaning this variable does not change. That's going to be the case for our function. I'm going to give it a name. I can't name it deposit because that's what this one is named, but that's fine. I'm going to get rid of this. So let's comment that out. Then I'm going to say this is equal to, and then a set of parentheses. Then I'm going to kind of make an arrow here. So an equal sign and then a greater than sign. Then I'm going to open my curly braces. And this is exactly the same as this function right here. At least that's the way that you can think of it. So in fact, we're going to use this style of function because this is kind of the newer style that most people are using. Works the exact same way, is called the same way, and we can return stuff from this function. Okay, so inside of the deposit function, what we need to ask the user to do is to enter a certain amount. So how we're going to get the user input is using the package that we installed called prompt sync. So the way that we're going to do that is import the package. So we're going to say const, which stands for constant. We're going to say prompt, which is going to be the name of the function we're going to use in a second. This is equal to, and then this is going to be require, and then prompt sync like that. And then make sure you add another set of parentheses here, because what we actually need to do is require this package or this module that we're using that kind of imports it into the program. Then when you call this with these parentheses here, it's going to give you access to a function, and it's a bit confusing, that you can use to get user input. Okay, so now that we have prompt here, we're going to say const, and then we're going to say, let's go with deposit amount is equal to, and then this is going to be prompt. And then inside of parentheses, we're going to put a string, which we do 2 quotation marks for. And we're going to say kind of what we want to ask the user. So I'm going to say enter a deposit amount. Then I'm going to do a colon and a space. I'm just doing a space so that when the user starts typing, they have a little bit of space from the colon. If I didn't do a space, they'd kind of be typing their deposit amount right beside the colon. We don't want that. We want them to have a little bit of space. Okay. And then I'm going to come here, and just for testing purposes, I'm going to call the deposit function. Okay, so I know if you're new to programming, this might be a little bit overwhelming, but all we're doing here is asking the user to enter a deposit amount, storing that in this variable, and then I'm calling the function. So when I call the function, it's going to run the code inside of here, and then it's going to ask the user to input something. They're going to input something, and that's all we have for the program right now. So how do we run this code? Well, we're going to use Node.js. So we're going to go to our terminal, make sure you're in the directory where your project file is or where your code is, and you're going to run node, and then the name of your file, which in this case is project.js. So it says enter a deposit amount, and then notice my cursor is here and I can start typing. So I'm going to type something like 100. Perfect. I've now entered my deposit. Okay. So now that we have the deposit amount, what we need to do is convert this deposit amount to an integer or to a number type in JavaScript, because by default, what's going to be returned here by the prompt is a string. A string is anything that's inside of double or single quotation marks. So we're going to convert this to a number. And the reason we want to do that is because we're going to have to be subtracting from it, adding from it, etc. And we also want to make sure the user entered a valid number. For example, if they enter -100, then they have no balance and, well, they can't play. So the way that we convert this to a number is the following. We're going to say const number deposit amount is equal to, and then this is going to be parse float, and then deposit amount. Now, this parse float function is just going to take a string, and it's going to convert it into its floating point value. So if I had a string that was like 17.2, then that function is going to give us 17.2. Pretty straightforward. Now, if we have a string that is not a number, so a string like hello, and we use this parse float function, it's going to give us something called not a number, so nan like that. And if we get not a number, that means that they didn't enter a valid deposit amount, and we need to ask them to do that again, or we can just quit the program and they would have to try again. Kind of up to you what you want to do there. I'm going to make it so they have to enter the number again. All right, sorry for the cut there. My cat was going a bit crazy, so I had to deal with that. Anyways, what we're going to right now, what we're going to do now is check if this is a valid number. So to do that, we're going to say if, and then we're going to use a function called isNan. Now, isNan checks if something is not a number. So I'm going to say if isNan number deposit amount, or, and you represent or with the 2 pipes here, 2 vertical lines on the keyboard, or number deposit amount is less than or equal to 0, then we're going to say console.log invalid deposit amount. Try again. Okay, so we're just simply checking, is it not a number? If it's not a number, or the number is a number, but it's less than or equal to 0, then this is invalid. So we need to tell the user that. Hopefully that makes sense. I don't think I need to explain that much more. Okay, so let's quickly run the code and just make sure this works. So I'm going to say node project.js. I'm going to enter hello, and then notice I get invalid deposit, try again. Now, if I enter a number like 10, all is good. And if I enter a number like -10, then same thing, I get an invalid number. Okay, perfect. Now, next, what we need to do is return the number from this function. And we also need to make the user enter a number again if it's invalid. So the way we do that is the following. We're going to say while true, and then we are going to put all of the code that we just wrote inside of this while statement. Now, this while statement is a loop. This here is the condition for when we should continue looping. So right now I'm saying while true, which just means forever. So it's essentially an infinite loop. We're going to continue to do this. So we're going to ask the user to enter deposit amount, convert it, and then we're going to check this. Now, in the case in which this is a valid number, so in the else case here, we're simply going to return the number deposit amount, which is going to break this while loop. Hopefully that makes a bit of sense, but we're looping forever. Okay, so we're just going to continue to keep looping. We do this, we check if it's an invalid deposit amount. If it is, we're going to console.log this, and then we're just going to ask the user to do this again and continue asking them until they give us a valid amount. Now, otherwise, which is where this else statement comes in. So if this is not the case, then we're going to go in this else statement, and we're going to return the number deposit amount to this deposit function call. So to show you this, I'm going to say const deposit amount is equal to deposit. By the way, I've said this before, but const stands for constant, and it's how you declare a variable. So constant deposit amount is equal to deposit. And then I'm going to say console.log, and then the deposit amount. Okay, so now let's go here and let's run our code and check this out. So node project.js, enter deposit amount. Let's go hello, invalid, enter again, -10, invalid, 10, and then it prints out 10 because that's a valid amount. All right, so we've just finished step 1 here to deposit some money. I realized I spelled this wrong, but that's okay. Now that we've determined what the user has deposited, the next thing that we're going to do is write a function to get the number of lines that they want to bet on, and then we're going to collect the bet. So let's go ahead and do this. We're going to say const get number of lines. And notice that all of these different tasks I'm putting in a function, so that's very clear where that code lives. It's easy to go change it, find it later on. It just makes the code very structured and easy to understand. Okay, number of lines. Let's do this. We're going to ask the user to input number of lines that they want to bet on. So we can really do the same thing that we did here. We can kind of copy all of this code and paste it in. But rather than a deposit amount, this is going to be number of lines. The prompt is going to be enter the number of lines to bet on, and then we can just kind of hard code in here between 1 to 3. Okay, then we're going to say, actually, let's just do lines for this, and then this can be number of lines, and then here we can go and change this to lines. Okay, so already we're doing the exact same thing we did before. We're getting the number of lines they want to bet on between 1 and 3. We're then saying const number of lines is equal to this, and same thing, we want to check if the number of lines is not a number, or the number of lines is less than or equal to 0, or the number of lines is less than or equal to 3, because these are the lines they could possibly bet on. So actually, sorry, if it's, no, not if it's less than or equal to 3. Sorry, if it's greater than 3. My apologies. I'll re-explain that. So we're checking if is what they entered not a number. If it is, okay, that's invalid. Is what they entered less than or equal to 0? If it is, that's invalid. Is what they entered greater than 3? If it is, it's invalid. Now we just need to change the message. We're going to say invalid number of lines. Try again. And then here, we're going to return the number of lines. Now I went a bit faster here just because I've already kind of explained how a lot of this code works. Just note here that you can combine as many conditions as you want, and you're just going to go through and check one by one. So we check, is this true? No. Is this true? No. Is this true? No. Okay, we go to the else statement. If any one of these 3 are true, it's invalid. We print that, and then we try again. Okay, so now let's get the number of lines. So I'm going to say const number of lines is equal to get number of lines, like that. And now we can run the code. So first it's going to ask us for a deposit because we did that first. Then it's going to ask us for our number of lines. And notice that I'm kind of writing these functions in the order in which I have them here. Doesn't really matter where I put them, so long as I place them above where I'm using them. So they need to be defined before I call them. All right, let's run our code. So clear node project.js, enter deposit amount. Let's do 100. And then we're going to have to fix this prompt, but enter the number of lines to bet on. Let's do 4. Invalid. Let's do 3. All is good. We can bet on 3 lines. Okay, so let's move on here after I fix this prompt. All right, what is next? Collect a bet amount. So we need to figure out how much the user is betting. Now, the amount that the user can bet is going to be based on whatever their current balance is, right? They're going to have some kind of balance, and that's going to be based on whatever they deposited. So rather than having the const deposit amount here, let's actually change this variable. And let's say that this is let balance equal deposit. Now, that's because the starting balance is going to be equal to whatever they start by depositing. And then we're going to adjust the balance based on what they're betting and what they're winning. Now, notice that's why I changed the type of this variable here to be let. Rather than having a constant, I'm changing it to let. Now, what let lets me do is adjust the value of this variable. So later on, I can say add to the variable, subtract it. I can change what it's storing. Whereas if I have a constant, I can't do that. I can't change the value of a constant because it's constant. But a variable using a let, you can change the value of it. So that's why I needed to change the variable type here. Okay, so we have the balance, we have the number of lines, and now we're going to write a function that allows us to get the total bet. So we're going to say const get bet, and the bet is going to be based on the balance that the user has, because they can't have a bet that is more than their current balance. So I'm going to take balance as what's known as a parameter. What that means is I need to pass a balance to this function when I call it. And now inside of the function, we can use this balance variable to determine what the maximum bet is. So same thing here. I'm going to copy this code. Really, we could probably write a function that, reworks this, but for our case, it's fine to kind of copy it and just adjust it. So I'm going to have, again, while true. Now this time, I'm going to have const bet is equal to enter the total bet like that. We're going to have number bet just because I'm converting it. Now here, we're going to put bet. And then again, we just need to change a few of these things. So we're going to say number bet, and then we're going to say number bet is greater than the balance this time, because now the maximum they have is the balance, not a fixed number like 3. And then here we're going to say invalid bet, try again, and then we're going to return the number bet. So I know this is fairly repetitive. That's kind of why I'm going through it quickly, but you get the idea. These are 3 kind of input functions: get the deposit, get the number of lines, get the bet, make sure all of those are valid. Once we have all of that, we can kind of do the more interesting stuff, which is spinning the slot machine and calculating how much the user won. So now let's call this bet function. So we're going to say const, and then we're going to say bet is equal to, and then this is going to be get the bet, and the bet is going to be based on the balance. Perfect. So let's test this out and make sure it's working. Clear. Node project. Okay, let's enter deposit like 100. Let's do 3 lines, enter the total bet, and let's bet 2. Okay, great. Now, while I was doing this, I just realized that the bet that you're going to have is going to be multiplied by the number of lines. So this is actually not quite correct, because right now we're only allowing you to bet based on your balance, but not based on the number of lines. Really, the maximum bet you can make is whatever your balance is divided by the number of lines that you're going to bet on, because that's how many places you're going to place the bet. If you bet 2, really your total bet's going to be 6 because you're placing that on 3 lines. So I'm going to change this here to say enter the bet per line. Okay. And then we're going to now take in the number of lines. And here, we're going to pass the number of lines. Now, we're going to make sure that the number is not greater than the balance multiplied by the lines. Sorry, not multiplied, divided by the lines. And just to make this clear, we're going to put these in parentheses. I guess actually we don't need the parentheses. It just removed it for me, so that's fine. Hopefully you're getting what I'm saying there. Since the bet is distributed between multiple lines, based on the number of lines you bet on, that's going to affect what the maximum bet can be. Okay, now that we have this, let's just try this one more time. Okay, so here, enter deposit. Let's enter 50. Number of lines is 3. Now let's try to bet, say, 40. Invalid bet, try again, because that's going to be over based on the number of lines that we have. Now if we try 20, Same thing, it's invalid. It's going to be over based on the number of lines. If we do 15, that's fine. We can bet 15 per line. Okay, perfect. So we've done the first three things here, which is deposit some money, determine the number of lines, collect a bet amount. Now we need to spin the slot machine. This is where it gets a little bit more challenging, but that's okay. Let's dive into it. All right, so as we dive into building the slot machine here, I'm going to give myself a bit of room at the top of the program because I'm going to start defining some variables that are going to depict how big the slot machine is and how many symbols we can potentially have in each row. So first, let's just define the number of rows and columns we want to have. So really the number of reels and the number of symbols that will appear in each reel. Then we need to know what symbols we have in total. So do we have 5 different symbols, 7 different symbols, etc.? And what is the value of each symbol, as well as the quantity of each of them in the reel? That's what's going to define kind of the payout structure, the probability, etc. I'm not going to make this balanced. I don't really know what I'm picking here. It's a little bit random, but I like to declare all of these as what I refer to as global variables. And I do all of my global variables at the very top of the program, so it's very easy to see them and to change them. So all I need to do if I want to adjust, say, the size of the slot machine is go to the very top of the program, change a clearly named variable to, say, 4 or 5, some larger number, and now all of a sudden I have a bigger slot machine and my entire program will work. You'll see what I mean, but let's define these variables. So first of all, you'll notice I'm going to do this beneath where I have my prompt. So the typical tradition is you want to have all of your imports and kind of libraries at the top of your program, then your global variables, then your classes and functions, and then the main line or the other aspects of your program, which is kind of what I'm following right now. So I'm going to say const because all of these are going to be constants. And the first variable I'm going to have is rows. Now I don't need to make this a constant, but it's typically a practice of any of your global variables that are constants are in all capitals. I know it seems a little bit weird, but that's what we're doing here. So I'm going to say const rows. We're going to have 3 rows, and const calls is going to be equal to 3. Okay. Next thing we need to define is the symbols. So first of all, we need to know what symbols we're going to have and how many of them we can have in each reel, so each column. And then we need to know what the value of each symbol is, which is just going to be some multiplier based on your bet. So we're going to create a map. And the way we can do this is the following. Actually, we're going to create an object. It's kind of similar, but you'll see. We're going to say const symbols is equal to, and actually I'm going to say symbols underscore count. You'll notice that I'm going with snake case here, which uses an underscore for kind of a space separator rather than camel case. And that's because I'm doing this in all capitals, and that's the convention. Anyways, for my symbols, I'm going to have A's, which will be my most valuable symbol. And we'll say there's only 2 A's in each reel. Okay. I'm going to have B's. We'll say there's 4 of those. We're going to have C's. We can say there's 6 of those. And then D's, we can say that there is 8 of them. Again, I don't know if this is going to be balanced or not, but these are the symbols that you can possibly have in each reel or each column. And we're going to randomly select from these number of symbols, okay? Now, this object allows me to have keys mapped with different values. So I have a key A here mapped with the value 2. So that means if I were to do something like symbols count at A, this would give me the value, which is 2. Hopefully that makes a bit of sense, but that's like a very quick introduction to objects in JavaScript, allow you to have keys or properties or attributes associated with values, okay? All right, next, we're gonna have our symbol values, okay? Now, the values are going to be similar here, but we're gonna say A is 5, B is 4, C is 3, and D is 2. Now this means if I get a line of A's, I'm going to multiply the bet by 5. That's going to be the payout because of that line. If I get a line of B's, I'm going to multiply the bet by 4, etc. So this is the multiplier or the value of each symbol relative to what we're going to multiply it by. Okay, so now that we have our constants, what we need to do is create a function that kind of spins a slot machine. Now, really spinning the slot machine is just going to be randomly selecting, based on these counts, what symbols we have in each reel. Then we need to determine if the user won anything. Okay, so let's do this. We're going to say const, and we're going to say spin. Okay, now for the spin, we don't need to take in any parameters. We can just generate the different reels. So to generate the reels, the first thing that we need to do is figure out how many symbols we have. Now we know that based on this, But what I'm going to do here is I'm going to put all of the possible symbols that we could use inside of a list or inside of an array, and then I'm going to randomly select them out of the array and remove them from the array every single time that we use them while we're generating each reel. So we're going to generate individual columns, right? That's what we need to do. Yeah, let's generate the columns and then you'll see what I mean. All right, so as I was saying, let's generate an array that contains all of the possible symbols that we could have. So I'm going to say const, and then this is going to be symbols is equal to, and then an empty array. Now, notice that even though we're going to be adding elements into this array, I still made this variable type a constant. That's because I'm not going to change the value of the array. I'm not going to actually change what array I'm using. I'm instead just going to be adding elements inside of it. I know that seems a little bit misleading or a little bit confusing. This is something to note in JavaScript. An array is what's known as a reference data type, which means I can manipulate what's inside of the array without changing the reference to the array itself. So I don't need to assign a new value to symbols. I can just add stuff inside of this array, and that's not going to violate the principle of this being a constant variable. It's a little bit strange. A lot of people get confused by that. Hopefully that gives you a bit of an explanation. So what I need to do now is I need to loop through all of the different entries that I have inside of my symbols object, or my symbols count here, okay? Now, notice that I got rid of my quotation marks. You don't actually need quotation marks for your keys or for your properties or attributes in JavaScript. You do in Python, hence why I added them, because I thought we're in Python, but no, we're in JavaScript. Okay, so I'm going to make a for loop here. I'm going to say for, and then this is going to be symbol of, and then I'm going to say this is object dot entries of, and then our symbol underscore count. Okay. So the way that you loop through all of the different entries inside of an object, and our entries are going to be this, right? So A2, B4, C6, D8 is you use this, right? You use symbol of object.entries, and actually we're going to say symbol and count of object.entries, and we need to put these inside of an array, and we need to put our const here. Okay, sorry, I'm getting a little confused just because I usually work in Python and it's a bit different, but we're going to say constant, and then inside of an array, we're going to say symbol and count of object.entries. That's going to loop through all of the different entries in our symbol count, and it's going to give us, first of all, what the key is, or what the symbol is, and then what the value is associated with each of those. So to quickly illustrate that, I'm just going to console.log the symbol and the count, and I'm just going to call this spin function here, just so you can see how the looping works before we go any further. So let's quickly run this, and notice I get A2, B4, C6, and D8, okay? So I'm looping through all of them, and now I'm just going to get out of this. I guess I need to just enter some values here. Okay, perfect. So now we're out of that. All right, so that's how the looping works. Now that we have the symbol and the count, we're going to add that many symbols into our symbols array. So we're going to do another for loop, and we're going to say for, I'm going to say let I equal 0, I is less than, and this is going to be count. Then I'm going to say I plus plus, and then I'm going to say symbols dot push, and I'm going to push the symbol into the array. Now this is just going to add however many symbols we have. So in this case, if we had 2 A's, it's going to add 2 A's into this symbols array. The way that you add them in is by pushing them into the array. So typically in other languages, you'll see append. In JavaScript, it's push. That's how you insert a new element inside of an array. And an array is just a collection of multiple elements. So I could have A, B, 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 like that inside of the array. Okay, hopefully that is clear. So for every single symbol and for the count of those symbols, we're going to have another for loop, and we're going to insert that many symbols into the array. So now again, just quickly before we go any further, let's print out what the symbols array looks like after we run this code. So let's call the spin function. Let's go here and run it, and notice that this is our array, okay? So we have 2 A's, 4 B's, 6 C's, and 8 D's. The point of doing that is now that we are going to be able to, one sec, let me get out of this here, randomly select elements from the symbols array when we are inserting them in our reels. Okay, so let's do this. We're going to say const reels is equal to, and then we're going to create 3 nested arrays. Now, this is simply an array inside of an array. You can do that. It's valid. Just like we had elements inside of here, we can have arrays inside of arrays. And each one of these arrays is going to represent a column inside of our slot machine, okay? So if we had A, really you'd visualize that like A, okay? So each one of these kind of nested arrays is a column, and we're going to generate what's inside of them using this symbols array. Okay, how do we do that? Well, we need to go through each one of our reals. So we're going to say for, and then this is going to be let I, and actually, yeah, we'll say let I equal 0, I is less than, and this will be the number of columns that we have, and then we're going to say I plus plus. So this first for loop here is going to be for each one of our reals. So for every single reel that we have or every single column that we have, we need to generate what's inside of it. Then for every single column, we need to pick the 3 elements or the X elements, whatever the number of rows is that we have that are inside. So then we're going to say for, and we're going to say let J equal 0, J is less than rows, and then J plus plus like this. So we have a nested for loop. The reason we need that is because we have nested arrays. So for every single array, generate the number of rows, the number of elements that need to go inside of that array or inside of each reel. Hopefully that's making a bit of sense, but that's kind of what we're doing here. Now, in case you're confused by this syntax, the way this works is we define some counter variable that we can use while we're running through this for loop to keep track of how many more iterations or loops we need to perform. We then set how many loops we want to do. So we say while I is less than the number of columns. That's what this means. It means while I is less than the number of columns, keep looping. As soon as it's equal to or greater than, we're going to stop. Then we have what's referred to as our increment. We're saying every time we do this loop one time, increment the variable I by 1, allowing us to keep looping, keep track of what loop we're on, and then eventually exit the for loop. So obviously same thing is happening here for J. I'm just using a different variable because we can't have the same variable for both of our loops. All right. Now inside of here, we need to randomly select elements from our symbols. But remember that the elements that we can have, or the symbols we can have in each reel, are for each reel. So what I actually need to do here is create another variable. I'm going to say const reel, we'll say reel symbols is equal to, and then this is going to be an array. Now, actually what this is going to be is an array, and we're going to say ... and then symbols. Now, what this is going to do is just copy the symbols that we have available to choose for each reel into another array. The reason we're doing that is because for every single one of our reels, these are all the available symbols that we have. So what I'm going to do is randomly select a symbol, and then I'm going to add that into the reel, and I'm going to remove it from the available symbols to continue to select. So if I already used 2 A's in one reel, I can't have any more A's. I need to remove them so I don't pick them again. But when we move on to the next reel, we have to have those A's available for the next reel. So I can't be removing elements from this symbols list. I need to remove them from one that's specific to each reel. So inside of our for loop, remember, this is for every one of the reels that we have, we generate the available symbols. Then we're going to remove from them as we add the symbols into each reel. I know this is a little bit confusing, and I said reel probably 100 times there. Hopefully it's a little bit clear why we're doing that, but it's because each reel has their own symbols that they can pick from. So we need to have a copy of the available symbols that we're manipulating inside of the for loop. Okay, let's continue here. I'm going to say that our symbol, so I'm going to say const selected symbol is equal to, and then I need to randomly select an element from this array. Now, the way I randomly select an element from an array is I randomly choose an index or a position in the array. So quick recap here. If we have some things in our array, say we have A, B, C, each one of these things has an index in the array. Now the first index is 0, the next is 1, and the last is 2. So you always start at 0, you count up by 1. Fairly straightforward. So what I want to do is randomly select one of these indices or indexes, and then choose the element there, remove it from the existing array, and insert it into my reel. That's what we need to do. So we need to randomly pick one of the indices. Now, how do we randomly select an index? Well, we need to use our random function. So we are going to say, actually, this is going to be reel symbols at the index. Now, the way that you access elements at a specific index is you write square brackets, and then you put 0, 1, 2, 3, whatever the index is. So if we're accessing the fourth element, we put index 3. Now the question is, what is the random index? So we can go here and say const random index is equal to, and then in all capitals, we're going to type math dot random, and we're going to multiply this by whatever the length of our real symbols is. So we're going to say real symbols dot length, and then we're going to put around this math dot floor. Okay. Then here, this is going to be random index like that. All right, what are we doing? Well, we are generating a random index. Now, what I've done is I've taken math.random, and math.random is going to generate a random number between 0 and 1. So it's a floating point value between 0 and 1. Then we take that number and we multiply it by whatever the length of our symbols is. That means that the maximum possible number that this expression is going to generate for us is going to be however many symbols we have. It's the maximum possible number. Then we're going to say math.floor. Now, the reason we're doing math.floor is we're going to round this number down to the nearest or to the lowest whole number. So if we had like 1.9, we're going to round it to 9. The reason we do that is because really the possible numbers that we can pick from, the possible indices we can pick from, is the length of our array minus 1. So we don't want to round up because that would give us an index that's possibly out of the array. We need to round down so we get one that is less than the real symbols dot length. So again, just to kind of clarify what's happening here, this is going to generate a random number between 0 and then whatever the length of our reals is minus 1. And then we can use that to select the element or the symbol from our real symbols array. I know it's a bit complicated here, but that's why I wanted to do this project, to give you a bit of a challenge. So now that we have our selected symbol and we know the random index, we're going to first say reals, and then this is going to be at index I. Now, index I is going to represent the real that we're currently working on. So if we're working on the first real, I is 0. So it's index 0. If it's the first real, or sorry, the second real, then I is 1. So it's index 1. So I'm going to say reals I dot push. So I'm pushing into the interior array the selected symbol. Okay, we're almost done. The last thing we need to do is remove this symbol so we can't select it again while we generate this real. So we say reals symbols dot splice, and we're going to splice at whatever the random index is that we selected, because that's the position that this element existed at, or this symbol existed at, and then we're going to put 1. Now 1 just means remove one element, so that's all we need for that, and random index is the position at which we're removing that element. So we're selecting the symbol at this index, we're adding it into this array here, and then we're removing it so we don't select it again when we continue generating this real. And that's all we need for generating our reals. Now we can return the reals like that. Now I just want to quickly print out what we're going to get for our real. So I'm going to say const reals is equal to spin, just to make sure this is working before I go on to explain too much more stuff. I will walk you through this again, but let's just quickly run this. So I'm going to say node project.js, and then notice this is what we get for our reals. So C, D, 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 A, D, 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 D. Now notice we get a lot of D's because we have 8 of them available in our symbols cap. If I run it again, so let's just get out of this. Okay, and run it one more time. Notice that we get different values here in our real. So it is indeed random. Okay, so that means now that we have completed these 4. Deposit some money, determine the number of lines, collect a bet amount, spin the slot machine. Now we need to check if they won, which is fairly simple. We need to give the user their winnings, and we need to play again. Let me quickly recap what we did here, then we'll get into those steps. So we started by generating an array of all of the available symbols that we can pick from when we are going to choose what's inside of each reel, randomly choose. So this contains all of the available symbols. Then we created an array here, kind of temporary array that we're going to add to, that has all of the different reels. So we have one reel, second reel, third reel. We loop through all of the reels that we have, which is represented by the number of columns. Now, really, I just realized it's a little bit flawed what we're doing here, because if the number of columns is different than 3, we're going to get a bit of an error here. So I'm just going to quickly fix this, even though I don't love changing this all right now, by saying reels.push, and then I'm going to push an array here. And now we can remove this. The reason that's going to work is because for every single reel or column we have, we add one inside of here, okay? And then once we add it, we can now push elements inside of that reel. Hopefully that fix makes a bit of sense. Anyways, once we do that, we then copy all of the available symbols that we have. So we now have kind of a unique array to pick from for this specific reel. Then we loop through all of the rows. All of the rows is the number of symbols we're going to have in each reel. And we randomly generate one of the available symbols. So we pick one of the symbols that are available and we insert that into our reel. So we say our random index is this. We get our selected symbol. So that's going to be whatever the symbol is at that index. We push that into the current reel that we're working on, which is represented by I, and then we remove that from the available symbols so we don't select that again. Perfect. Okay, then we return reels and we are all good. Let's continue now and work on generating or checking if the user won anything. All right, so let's go ahead and continue. Now, first thing to mention here is that with our reels, and by the way, I'm just going to take these and move them down because that's kind of the logical order we need here. Our reels look like this when we get them. So we have arrays, right? And each one of our arrays, let's just do A, B, C, maybe D, 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 A, A. These are our kind of vertical columns, right? These are, our columns. Now, what we want to be doing when we're checking if a user is winning is we want to check in the rows. Now, right now, based on the way that we have our data, it's going to be a little bit difficult to check each row and see if every element in the row is the same. So what we're going to do is we're going to transpose this array into all of the rows. So again, I know this is a little bit weird, but these right now are our columns. What we want to have is an array that has all of our rows. Once we have the rows, we can then check who's winning or what row is winning, and we can then present that to the user. So when we're looking at this, right, we have these as our columns, but we want to instead have it like this, where we have rows. So our rows would look like this, A, D, A, and notice I'm taking A, D, A, because that's what's going to be in row 1. These are all in unique columns. Then we're going to have B, D, A, and then we're going to have C, D, A. Again, if we look at row 2 here, that's B, D, A. We look at row 3, C, D, A. So we need to turn our data into this format, and then once we have that, we can continue. Now, this is called transposing a matrix or transposing a 2D array, whatever you want to refer to it as. So we're going to write some code that does that. We're going to get the transposed kind of matrix, reels, whatever you want to call it. Then we can check who's winning or what rows are winning, how much money they won, etc. And we can continue from there. So let's write a function here. Let's actually just call it const. And we're going to say transpose. Again, this is going to give us the rows. So we're going to take in our reels and we're going to transpose them. So how do we transpose? Well, first we need a new array. So we're going to say const. We'll just call this rows like that. And for our rows, that's fine for now. So what we're going to do here is we're going to create a for loop that goes through the number of rows that we have. For each row, so row 0, row 1, row 2, or row 1, 2, 3, whatever you want to refer to them as, we're going to collect all of the elements from our columns that are in that row and then push that into the rows array. So we're going to say for let I equal 0, I is less than, and then this is going to be the number of rows, and then I plus plus. Okay. Then what we're going to do is say rows dot push, and we're going to push a new row because for every single row, we need to have an array that represents that. So we push those inside of here. Then we're going to say for let j equal 0, j is less than, and then this is going to be the number of calls, and then j plus plus like this. So for every single row, loop through every single column. So now for every column that we have, we're going to grab the element that's in the first row in that column and push it into our rows array. So we're going to say that rows at row I, because that's the current row that we're building, dot push, and then we're going to push the reels at, and then this is going to be column J at row I. I know, seems a little bit weird, but we're accessing each of the individual columns. So we're going through the 3 columns that we have, or however many columns that we have. So we're accessing that column. Then for each one of those columns, we're getting the element in the row that we're currently building, which is represented by I. Okay. Then we can simply return our rows, and that's how you transpose it. Now I'm going to print this out and you'll see what the transposition looks like, and then it'll make this a bit more clear. Okay. So we have our reels. Now I'm going to say const, let's call it rows is equal to transpose, okay? And then we're going to transpose the reals. Now we're going to just console.log the reals, and then we're going to console.log the rows, and you'll see the difference and how that transposition occurs. So let's run this. Say node project.js. Okay, let's run through this. And here we go. So we can see that we have all of our individual columns. So CID, CDC, DBD. Now let's look at our first row. Remember, this is kind of flipped. So for our first row, we have C, C, and then D. That's what we want. For our second row, we have A, D, and then B. Okay. And then for our third row, we have D, C, B. So now that we have those, what we can do is simply print those out, and we can kind of represent to the user what it is that they actually spun. Okay. So we're going to make another function here that's going to print our rows. So we're going to say const print, we could say print slot machine, or print rows is fine. And we're going to take in our rows, and we're just going to print out all of these elements in some kind of styled way. Okay. So we're going to loop through every single one of our rows, and then print. So we're going to say for, and we're going to say let I, actually, do we need to go I? I think we can say for const row of rows. Okay, then we want to loop through every single row and kind of build a string that represents that row and then print that out. So I'm going to say let row string equal, this is going to be an empty string. And essentially what I want is this, like A, pipe B, pipe C. And we're going to build that using a for loop going through each of the elements in our row. Now, by the way, this is iterating by item, which means that I'm going to get an array here. So I'm looping through every array, every nested array, or every row inside of my rows array. Remember, it's a two-dimensional array. So this will be an array that I can then loop through and get each of the elements. Okay, so we have our row string here. And I'm going to say for. And this time I need to do a different style for loop here. I'm going to say for const, and then we're going to go with I symbol of row dot entries. I think I can access dot entries on an array. We're going to see if that works. Then we're going to do the following. We're going to say row string plus equals, and then this is going to be the symbol. So when you do plus equals, you're kind of concatenating a string. So you're adding elements into the string. So if I go plus equals A to my empty string, I get A. If I go A plus A, then I get AA. So that's what we're building here, okay? That's what we're doing with the concatenation. Then we need to determine if we're going to add our pipe operator or not. Now, we're only going to add the pipe operator if it's not the last symbol that we have. Because again, we have A, B, C. We don't want to have a pipe here, so we need to make sure we don't add that. So we're going to say if I does not equal rows.length minus 1, because this is the maximum possible value I can be equal to, then what we'll do is we'll say row string, and then this is going to be plus equals, sorry, and then we're going to add a space and a pipe and a space. I think that is correct. And then in terms of this here, sorry, I'm just going to change this to say row.entries. And then this is going to say row.length. I don't want to use rows. We're already doing that here. We want to loop through our individual row. Now that we have the row string, we're going to say console.log, the row string. And now we're going to print each of our individual rows, and they'll be nicely laid out, and we'll kind of see each of the elements that's in each row and column. Hopefully that's making a bit of sense. Again, we're going through every single row in our rows. That's going to give us an array representing the elements in that row. We're then going to loop through both the index and the element that exists in this row. So if we have rows like A, B, C, then what we're going to be getting here is 0, so 0, A, 1, B, 2, C, because it gives us the index as well as the element. We're then checking, okay, is the index the last index or the last element? If it is, then we are going to not put the pipe. If it isn't, then we're going to put the pipe and the separator in this string. So we build this string up, and then we can print it out here, and that's fine for printing the rows. So let's go print rows like that. Let's go here and clear, and rerun. Okay, let's do this here. And there we go. We get our nicely printed slot machine. Now, in this case, we didn't win at all. But if we did win, well, that's what we're going to handle next. Seeing if user won, giving them their bet amount, or whatever they won, etc. Okay, so let's just quickly recap here. We've done depositing some money, determining the number of lines, collecting a bet amount, spinning the slot machine. We then transpose the slot machine. Now that we have it transposed, it's going to be really easy to check if the user won. We're going to do that, and then we need to determine their winnings to get back to them, right? Okay, so let's go ahead and do that. So we're going to say const get winnings. All right, now to do this, we're going to take the rows, we're going to take the bet amount, and we're going to take the lines that the user bet on. That's what we need to know to be able to determine what they want. If they only bet on one line, we're only checking the first row. If they bet on 2, checking both those rows. If they bet on 3, then we're checking all of the rows. Okay, so let's go through this. So we're going to begin by saying let winnings equal 0, and then we'll add to that whenever they win something. All right, so to do this, we're going to loop through all of the lines, which is really the row indices that we want to be checking. So we're going to say for, and we can say let row equal 0, row is less than lines, row plus plus. Now, the reason this for loop is going to work for us is if lines is 1, that means we're only ever going to look at row at index 0. If lines is 2, we're going to look at index 0 and index 1, which would be the first 2 rows. If it's 3, we look at 0, 1, and 2, and that means that we're going to look at all of the rows that are inside of our, well, rows. Okay, so now we're going to say const symbols is equal to, and then this is going to be rows at whatever the row index is. All right, so now that we have all of the symbols, we just need to check if all of them are the same. So I'm going to create a variable here, and I'm going to say let all same equal true. Now, what we're going to do is if we find that one of the symbols is not the same, we're going to make this variable false. We're then going to use that later to determine if the user won in this specific row. Okay, so we're going to go for, and then we're going to say const symbol of symbols. Again, iterating by item here, looking at each of the individual symbols. All we're going to do here is we're going to say if the symbol does not equal symbols at index 0, then we're going to say all same equals false, and we're going to break out of the for loop. Now, there's a bunch of different ways to go about doing this. What I'm doing is not necessarily the most efficient because we're going to be repeating a certain check, but it's fine for the purposes of this tutorial. So the reason I'm doing this is I'm saying, okay, I'm going to loop through every single one of the symbols that I have. Now, if every single symbol that I have is the same as the first symbol, all of them are going to be the same. So I'm just using the first symbol as what it is that I'm going to compare against. And again, if all of them are the same as the first symbol, then all of them must be the same. So in the situation where one of them is not the same, so symbol does not equal symbols at index 0, then I'm going to say all same equals false. And then I'm going to break out of this for loop because there's no reason to continue looking if one of the symbols is not the same. Now, this break keyword, as I just described, is simply going to exit the for loop. So it doesn't matter what iteration you're at. If you see this break keyword, boom, you're done iterating. So we're setting all same equal to false, and that means we did not win in this specific line or in this specific row. So now we come down here after we've iterated through, and if all the same is false, we didn't win. If all same is true, we did win. Because if it's true, that means we got through here. This was never the case, and that means that all of the symbols are the same. So we're going to say if all same, then winnings, and this is going to be plus equal the bet multiplied by, and then this is going to be the, not rows, sorry, the symbol values at symbols at index 0. I know a little complex here, but remember symbol values is what we have all the way up here. We have 5, 4, 3, 2, right? This is the multiplier. So we need to find that multiplier and multiply that by our bet. So if we had a row of A's, then we're going to take whatever our bet is and we're going to multiply it by 5. Again, we're only doing that if all of the symbols were the same. We're determining what the symbol is that we want to look for the multiplier for by just grabbing the first symbol in the row. At this point, we know that all of them are the same, so we could really grab any index from the row, but we know we're always going to have at least one symbol, so this is fine to do. Okay, so that's actually all we need for this. now we're going to return our winnings. All right. Hopefully that is all clear. I think that that is correct. If I made any mistake, of course, I will fix that. And also, let me just get rid of this. Actually, no, we want the console.log. Sorry, I don't know why I was going to remove that. All right. So now, after we print our rows, we want to determine what the winnings is. So we're going to say const winnings is equal to get, and did I call this winnings? Yes. And then what do I need to pass here? My rows, my bet, and my lines. So we're going to say rows, we're going to say bet, and then we're going to say lines. Now, I just want to confirm here what the bet is actually going to be, because if the bet is the total bet, that's not what we want. We want the bet per line. So let's look at get bet. Okay, so get bet, return number bet. Yes, okay, so it looks like the bet that we're returning here is the bet that we have per line, which is what we want because that's what we're multiplying by if we have an entire line. Okay, so now we have our winnings. Now I'm just going to print U1, and then we can say comma and a $sign, and then we can say plus, and sorry, this is not print, this is console.log. I'm writing in Python right now. And then we can say plus winnings. And I don't know if we have to do .toString or not, but I'm going to put this .toString. Okay, so we have const winnings equals get winnings, rows, bets, lines. It tells us how much money we won. So we're going to get that, and we're going to print out U1 and then whatever that dollar amount is. Then we're going to have to kind of continue this game a little bit, but for now, this should give us one round or one spin of the slot machine. So let's try this. Okay, enter deposit amount. Let's deposit 100. Let's bet on all 3 lines. Let's enter the bet per line of maybe $10. And we got an error here. It says lines is not defined. Okay, so that's at line 144. Lines here. That's because we need number of lines. Okay, so that was the issue. Let's quickly fix that. Let's come back here and run 100, 3, and then 10. And we won $0. Okay, let's try it again. 100, 3, 10. You won $0. Okay, hopefully we're going to win something. So let's see here. 3, 10. You won $20. Okay, perfect. And the reason we won 20 is because we bet $10 on 3 lines. And we won with this line here, giving us $20 because we had a 2 times multiplier with the Ds. Now, if we won on multiple lines, of course, we'd get the winnings for all of that. All right, so that is really the core logic for our game. Now, what was the last thing we need to do here? We need to give the user their winnings, and we need to play the game again. So let's work on that. And once we do that, then we're going to be finished this game. All right, so how are we going to turn this into a fully functioning game? We have the core logic here, but after we determine what the user wins, we need to give them those winnings. We also need to subtract whatever their bet is from their balance, right? So let's make a function. Let's say define, or not define. Again, I keep writing in Python. Sorry, guys. We're going to call this game. Now, this will just be one round. Will this be one round of the game? No, it's okay. This can be the entire game. So we're going to go game, and then we're going to call the game function down here just to kind of clarify where everything is for our code. Okay, so we start by determining the balance. That's fine. Then we get the number of lines, the bet, the reals, the rows, etc. Now, all of this stuff here, we're going to do no matter what, right? We're just going to keep playing if the user wants to continue playing. So I'm going to say while true here, and then I'm going to do all of this. Okay. Now we're going to add some more code, obviously, but we're going to keep doing this. If they run out of money, then we are going to break, or if they say they don't want to play anymore, then we're going to break the while loop and kind of get out of it. So we start, get the number of lines. We get the bet, we get the reals, we get the rows, we print this out, we get the winnings. Now let's start handling some logic here. So after we collect what the user's bet is, we are going to take the balance and we're going to subtract. So minus equals, this means take the balance and subtract from it whatever the bet is multiplied by the number of lines. Because this bet is per line, so whatever number of lines they bet on, that's what we're removing. Okay, so we remove that from the balance, subtract it. Then we generate our reals, we print the rows, we tell the user what they won, and then we have to add this to their winnings. So we're going to say balance plus equals winnings. Perfect. Now at the top here, we should probably always tell them what their balance is so they know what it is before they spin again. So we're going to say print, you have a balance of, and then we're going to do a dollar sign, and then we're going to do a plus, and then we're going to put the balance so that it looks like it's money. Okay, so we print what their balance is. Sorry, this needs to be console.log. I'm going to keep making that mistake. We have the winnings, and now all we need to do down here is we need to check if they have $0 left. If they do, then we are going to quit the game, or we're going to ask them, do you want to walk away? Do you want to stop gambling, etc.? If they say yes, then we're going to break. So I'm going to go here. I'm going to say if the balance is, we can say less than or equal to 0, but really it's never going to be able to be at that, but that's fine. We'll just say if it's less than or equal to 0, then we're going to break. But first, we'll go console.log. You ran out of money, exclamation point. Okay. And then we're going to say, after this, we're going to ask the user if they want to play again. So we're going to say const play again is equal to prompt. Do you want to play again? Question mark. And then we're going to accept as an answer either Y or N. And if they type anything other than Y, then we are going to quit. So I'm going to say if play again does not equal Y, then we can simply break. Notice that when you're just doing a one-line kind of if statement, or you have a one-line body, you don't actually have to add the curly braces here. You can just write it directly after the if statement. So if they didn't type yes to wanting to play again, then we're just going to break and leave the game. Otherwise, we just keep playing. So if they run out of money, we quit. Or if they tell us they want to leave, then we break. Okay, hopefully that's clear. Let's test our game, make sure everything's working, and then that's going to pretty much wrap up this project. So let's go here, node project.js. Let's deposit 100. We have a balance of $100. Enter the number of lines to bet on. Let's bet on 2 lines. Enter the bet per line. Let's do $5. You won $0. Okay, do you want to play again? Yes. You have a balance of $90. Enter the number of lines to bet on. Let's bet on 3 lines. Bet per line of $10. You won $0. Do you want to play again? All right, this isn't going too well for us. You have a balance of $60. Enter the number of lines to bet on. 3, bet per line. 2, we won $6. So I guess we had a 3 times multiplier there with our C's. Play again, and you get the idea. We can continue playing this. Obviously, we could clean up the terminal a little bit, make it a bit cleaner and kind of easier to understand. Let me just go through this here so I can quit and exit, but I think that is going to do it for now. All right, so let's quickly run through everything one last time. I'll just like kind of high level overview the code and everything that we did. By the way, all of this code will be available from GitHub. Then we're going to wrap up the video. So first of all, we have prompts. We're requiring this module so we can get some user input. We define some global variables here. We do them in all capitals just so that it's clear they are constants and they're at the top of our program. Okay, we have our function deposit, talked about that. Continue ask the user for a valid deposit. Get number of lines, get the number of lines or rows in this case that the user wants to bet on. Get the bet, same thing. We're going to get a valid bet amount per line based on the balance that they have and the number of lines they are betting on. Next, we are going to spin the slot machine. To do this, we need to generate all of the possible symbols in each reel. We then need to randomly select them, put them on a reel, and that's what we've done. Okay, then we have transpose. This is kind of a helper function that's going to convert all of our columns into all of our rows so we can better use this information. It's easier for us to check if the user won anything, and it's easy for us to kind of print out this information. Next, we have print rows. Again, this is just going to print out all of our rows in kind of nice, fancy formatting. Then we have get winnings, determining all of the winnings a user won from the specific rows or reels that they had in the slot machine. Lastly, we have our game function where we continually play the game until the user runs out of money or until they tell us they don't want to play anymore.